Good morning, everyone. I think it'll be a little louder. Good morning, everyone. That's much better. Welcome to this 103rd edition of the Zak World of Façades conference. My name is Ahmed. I'm part of the organizing team here. I quickly introduce the Zak World of Façades conference series to you for those who are attending this conference for the first time. And then we'll get into today's proceedings. Okay. Okay. We started the Zak World of Façades conference series back in 2012. It was a small networking event which has now grown globally to 35 countries. We've been doing it from the last 10 years, minus the 1 year of COVID of 2020. They're all across, as you see, different continents, different languages, different cultures. So it's been an exciting journey for us. We finished 102 editions till now. We just finished our 100th edition 2 weeks back, and this is edition 103. These are one-day networking conferences where we talk about the best practices in facade design, engineering, execution. So we're very proud with what we've achieved, and every event is different. Every event is unique. Every country is unique. The projects over there, the way they design, engineer facades is fabulous, which has helped us to bring people from different continents, different countries, and share their expertise with each other. Obviously, the UK is one of the facade engineering hubs of the world, especially London. The number of facade engineers here in London, in New York, are way higher than any other country or cities in the world. So obviously the content being presented today here is more UK specific. Of course, we've got a lot of international references also. We've got a lot of designers who are based here in the UK who are designing for projects all across the globe. So you will have a wide range of projects and concepts being discussed today. But I'd like to thank our event partners, without whom we wouldn't have been able to grow to such a level. I'd like to introduce the partners for this year's London edition. Our presenting partners are Schuco. Schuco are world leaders in aluminium door, window, curtain wall systems. So they've been ever present with us with our first event here in the UK since 2017. Our associate partners are AGC Glass, AkzoNobel, Exalta, Blue Chip, Boston Valley Terracotta, Concrete Valley, Cosentino, Dow, Ephesus, Euramax, Porcelanosa Facades, Phils, Flexbrick, FSI, Future Architectural Glass, Hilti, ISD, North Insulation, Curare, Montanstal, NBK Terracotta, Nordic Copper, Obex, Proctor Group, Proteus, Q-Railing, Saflex, Saint-Gobain Glass, SE Controls, Scene, Search Ferrari Stamisol, Siderise, Sika, Slojund, Tenmat, Thomas Bellwright, Turkish Glass, Vitro Architectural Glass, Window Master, Laswit. So Laswit are our luxury art facade partner. We have some unique products, it's a unique title for them. So these are our event partners. I think they've been extremely grateful in supporting the event. Some of them are first-time partners. Some of them have been partnering with us from the years. I think it's their support which has helped us to go to different countries. So we've had a fabulous year this year. So obviously it was a little confusing in the beginning of the year, but I think after things settled down, we've been having events left, right, and center. Events have been all across the continent. We've still got 5-6 more events to go end of the year. So our next event, so we've got 2 events next week. So we've got one in Israel, in Tel Aviv. We've got the next one 2 days later after that in Warsaw. A few weeks later, we've got our event in Hanoi. We've got one in Dallas. And then the last one for the year is in Riyadh. So all these are different places, different countries, and everywhere there are different challenges. There are different ways we approach events. Not all our events are in English, so that's another challenge for us to adapt to the local language and to curate content which is more specific to that region. Earlier this year, we had our first engineered timber envelopes event. So I think late 2019, early 2020, there's been talk of low carbon design, and timber was identified as a material which helps in low carbon designs, and because of its natural properties. And there were always pockets of references to timber at the Zak World of Façades conferences. So we thought, why not we do a unique mass timber event, with a twist. And we launched the first timber envelopes event earlier this year in February at the Central Hall in Westminster, for those who attended. I think it was a very different, very unique event. We were just coming out of Omicron, and it was a great gathering of 300, 400 people. We are now coming back with the second edition. Obviously, the rules for using timber in the external envelope here in the UK are complex, complicated. I think the regulations are a little regressive when compared to other parts of the world. But the beauty is you've got fabulous designers here, as I mentioned, who are designing timber projects here, but for other parts of the world. So that's something which we want to take it to the next level. So we will be doing a smaller boutique event like earlier this year, next year in London at the Business Design Centre on the 9th of February. And as I always say, this is a very unique material, timber. We are learning a lot about it. So if you feel you can contribute something on timber envelopes, please come see me or any members of my team. And if you wish, you can contribute to this event. We're more than happy to have you, because it's a niche within a niche. So it's something which even we are learning and we are evolving as the industry is progressing. For next year, we have our 2 events in UK, in Birmingham and London. But I'm excited. We're going to Madrid, we're going to Milan, we're going to Frankfurt, especially Milan. I've got a lot of Italian facade engineering friends here in London, in New York. So that's going to be a ball. So these are our European events. A few things a little different from this year, which we've tried. We've not had the conventional panel discussion which we've been having all these years. So we've thought we'll do something different. This is something common what we do in North America, where instead of a panel discussion, we have a project discussion. So we selected 3 projects. So one is a timber project. Yes, timber always has to be presented. We selected a Passivhaus project, and then we selected a regeneration project. So instead of a panel discussion, we had project discussions, which are in the 3 tracks. So those who are attending first time, just wanted to let you know that after lunch, the hall is going to split into 3 tracks. Towards your right is going to be track A, this is going to be track B, and this is going to be track C. Okay, so I'm again repeating, that's going to be track A towards your right. At the end, this is going to be track B and track C. You have a program book. You can pick and choose. So we will close the doors of the tracks which are full. So you can pick and choose which track you want to attend. Yes, you can jump between tracks, but if there is space, if you don't have this book, there are QR codes behind the chairs where you're sitting. You can scan and you can use the digital copy of the agenda. So this is something which we have tried. And right at the end of the day, those who are in the industry here will be aware that the CWCT has come out with a guidance on engineering low carbon facades. So we have a somewhat mini decoding of the guidance which they have published. So we've tried to do something different this year. And something else which is going to be different this year is we have collaborated with the Society of Facade Engineering to host a Facade Design and Engineering Awards this year. So this is at the same hall, 7 p.m. onwards. So we will end the conference by 6 o'clock. And then those who are staying back for the awards, I request you to vacate this venue. We are going to turn around this venue. And 7 to 12 is the gala dinner and awards. So if you're signed up for that, you'll need to go back down. You'll need to collect a wristband. That's a completely different event, has no connection with this event. So you'll need to go back down. Their staff will be manning the registration counter where you entered. You can collect your wristbands and then enter at 7 o'clock. So we will use that 1 hour to turn around this venue. Those who need a changing room to change to your evening dresses, you can use the Nelson Suite on level 4. This is there on the link which I have given in the which is on the QR code, so it's mentioned there. Those who want to change their clothes can go to the Nelson Suite on level 4, 6 to 7 only. So we've got a 1-hour window. They've given us that room. You can go and you can change over there for the evening dinner. So that's it from me. I'd like to call upon today's event host and convener, Stephen Tano. He's the Director of Pre-Construction Services at Schuko International. He'll be taking it forward. Sorry, one last thing. Those who have the delegate badges, the red color badges, you will have a USB stick hanging on your lanyard. So the USB stick has all the brochures of all our exhibiting sponsors. You can use that it's a 16 GB USB stick. You can use that USB stick for your use, and we don't give the goodie bag anymore. We've had complaints on why you're giving bags and paper and tree and all that stuff. So we moved digital, so everything is on that. So that's your resource. And what else? Yes, and I'd like to also thank our lanyard partners, Obex, so courtesy of them, having these nice lanyards. So thank you, Obex team. And yes, I wish all of you enjoy today's edition. We've tried to have a few things different from the previous years, new set of speakers and topics, obviously. And yes, there will be reference to low carbon design, but I think this word low carbon has to be, embodied carbon, low carbon has to be something which is very important for us going forward. So over to you, Stephen Tano.
Thank you. Good morning, everybody. I hope everybody can hear me okay. Yep? Great. So my name is Stephen Tano. I'm from Schuko International. It's an absolute pleasure to welcome you to the 5th Zak World of Façades in London, the 5th event. Where has the time gone? It was back in 2017 that we held the first event. And I remember the lead up to that event very clearly because Ahmed and I spent a good 6 months in advance planning how the event should be done, curating the content, and planning it in the normal, meticulous way that you've become accustomed to from the team, from Zak. The driving principles were then and still are today. It's about sharing, it's about learning, and it's about teamwork. So after 5 years, this event has become or has proven itself to be the right medium for architects, for consultants, for contractors, suppliers to come together to mix and learn from each other. And this morning, I just want to take a minute to recognize this and recognize the effort that's been put in by Ahmed and his team and into making this event what it is today. I also want to recognize the guidance and the support that Ahmed's dad gives to Ahmed, because Ahmed is very much shaped by his dad. It's a team effort, it's a family business. So I'd like to invite Dad and Ahmed to join me on stage for a minute, please. You and Dad can open that. Come in the middle, please. So this is just a small memento, because that London event from 2017, I think, was very much a turning point for the Zak event. And I know these days, these guys do events all around the world, but I feel Zak London 2017 was a turning point. And I want to thank them and congratulate them on behalf of you all. So thank you.
Thank you so much.
So we meet again this year at a time of crisis. The war in Ukraine has come very quickly at the beginning of the year. We barely said goodbye to COVID, and we were into war. This war continues to cause terrible suffering and devastation in Ukraine. It's also having a profound impact on people's lives in large parts of Europe. The world economy is suffering massive losses because of this war. And the situation could still be more dramatic. Maybe we haven't seen the worst of it yet. Also this year, we lost an icon, Her Majesty Queen Elizabeth II. I was lucky enough to meet her back in 1999 when she came to open one of the projects I was working on. And I think it's appropriate at this time that we stand in a minute's silence and respect. So I would join you, please, to stand if you're able to. First of all, in solidarity with the people of Ukraine, and also in honor of Queen Elizabeth. So today we offer a collective prayer from everyone gathered here for some solace for the people of Ukraine and for wisdom, forbearance, and resilience for King Charles. Thank you. Please do sit. So the impact of the war has given us this graph that you see here. Inflation is sitting at around 10%. It's projected to go up to 12% next year. And I think it's a similar situation in most countries. This is causing concern about where the world economy is going, and there are potential predictions for a global recession next year. One of the key steps that's happened this year as well is that the CWCT here has published the guide and worked example for embodied carbon in facades. These documents are the culmination of work by groups of people from different organizations. I want to congratulate them all for the work they've done. And I would also urge all of you to please review these documents, give feedback, ask questions, make suggestions. It's only by giving this feedback that we're able to shape these documents into giving us what we want out of this complex issue of sustainability and carbon. On the topic of sustainability and low carbon, there has been a lot of greenwashing riding on the back of it. People have been looking for a quick solution. But the truth of the matter is the topic is very complex and is interdependent on green energy, green electricity, and the balance between embodied carbon and operational carbon is constantly shifting. I think what we need also is to recognize that how we use data, how we use assumptions is important in this type of scenario. We need a dynamic database on which to execute our calculations. For us at Schuko, for years since we have been doing environmental product declarations, we have been using the Sphera Gabi as our database. It seems that the BRE is working on a database, and there are others such as EcoInvent. Perhaps the next step is to provide a universal tool that is, if you like, a cradle-to-cradle tool that takes over the whole sequence of what we do, including the recycle or the circular economy at the end of life of a building. We can use common assumptions that will hopefully bridge the gap that currently exists between calculations that everyone is producing. At the moment, I feel there's a lot of stuff that's being published that has its own assumptions and has no relationship to what other people are doing. From our side, from Schuko, as you know, we in Europe are very lucky. The aluminium that we already have here in Europe is very low carbon compared to other parts of the world. Our standard aluminium is at, by the time you get it in profile form, is around 6 kg of carbon per kg of aluminium. But starting straight away, we are switching this to what we call a low carbon aluminium that will be available immediately. And because recycled material is only available in small quantities, we're not able to offer the ultra-low carbon universally. That's still going to be on a limited edition based on available recycled material. So that's more or less it from my side. Before I introduce our first speaker for today, I want to say a huge thank you to all the speakers, all the panelists, all the contributors. It's only through them putting time and effort in preparing their material and delivering it that we are able to get together and learn and have a discussion today. So on to our first presentation of the day. Our first speaker hardly needs introducing. He's been doing fantastic projects here in London for a very long time. It's Keith Priest, who's the senior partner at Fletcher Priest Architects in London, and he will talk to us about unwrapping the process. Thank you.
Hello, thank you for having me. Is there an echo on this? No. Hi, I'm one of the people who was mad enough to start a practice. We're now about 120 people in London and about 25 people in Cologne and one person in Riga. So that's the extent of this Hanseatic organization. We work across urban design, architecture, interior design, and research. And I think I've been asked today to talk a little bit about what happens before we get to the point where we know what we're doing on the outside of the building, to give you an insight into the process. I understand the audience is about 33% architects, and so 66% of you are not architects. And this is what goes on before we get to the point where we can say that's what we want to do. So the practice really is a group of all of those disciplines, and they are all involved in the decision process and then the design process. And they're very actively encouraged to be free thinkers, so here we are, London, Cologne, Riga, for those of you who don't know where they are. I'm sure you do. And that's us. And this is what we're about. And we take that bit very seriously. So when it comes to a building, we're all involved at various levels. And then the building begins to emerge. And I thought to illustrate this, one of the blights of our life is our NDAs. I don't know about anyone else, but pretty much I can't talk about anything I've done almost in the last 18 months. So I've got to talk about before that. So we sat together and thought, let's pick a few projects that we've worked on that might illustrate our approach. And there are 3 of them. You might be relieved to hear. So the first one, we were actually asked to design a storage building on the banks of the Thames. And this is what we ended up doing. The brief was to do a yellow box storage building right on the banks of the Thames. And we thought, well, isn't this where you might want to work or do anything else? So the first thing we were doing was researching the site, challenging the brief, and we ended up doing an office building. It's quite a large one. It's about 800,000 square feet. And the curved building, you can see on the image there, at the time, and I doubt whether we could claim it now, at the time was the first zero carbon in operation building in London. It's got a very large office block behind. It's occupied by Nomura, and they took it in a situation which is much worse than the situation than I think we might be entering into now. 2008, Rupert Murdoch and Nomura were both bidding. Rupert Murdoch was going to move all his newspapers into here, and Nomura had just bought Lehman Brothers cheaply and decided to move them into this building. Then it came to the design. How did it end up like this? It's a big block which drops down for St. Paul's Views and has two sort of pavilion buildings and massive rooftops where Nomura bankers now have 150 hives. They make their own honey. They grow their own vegetables. We didn't put that in there. So they have developed that since we finished the building. They've taken out the formal gardens and put in the vegetable planting and all of that sort of thing, and managers are bullied by switchboard operators, and they still have a switchboard operation there. So why does it look the way it does? At the time, we were very, very concerned about buildings looking like they were all the same on the riverside. So we wanted to do a riverside building along with the planners and with our clients. And so the photograph on the left is the Thames, a photograph of the Thames River. Then it's pixelated. And then with Gartner, we developed a ceramic frit that could work across the building to produce exactly this sort of pattern. And we also were a bit concerned that the buildings didn't look like they were on the river anymore. And as the building was between the old Roman river bank, which is Upper Thames Street, and the current Victorian river bank, we started looking at lots of photographs of what used to be the river. This is what the river used to look like. And so we started developing, believe it or not, what was then a low-budget cladding system, which was a simple glass facade with an entirely freestanding, south-facing sunshade in front of it, which, using a lot of calculations, we were able to make the shapes which exactly shaded it. So they're floor-to-ceiling glass facing south. And this is how it ended up. The timber facade is also a theatre. With theatre lights, there are theatre performances. It's also a public park, and this is the public park 1 minute after they took down the barriers. Everybody thought people won't know how to use it. These two characters seem pretty relaxed about how you use a public park on a sunny day. So this is a piece of riparian architecture, riverside architecture, developed from the history and data coming forward and working with great facade engineers and great manufacturers to work together to produce something which has won ever so many awards, and I think the clients are very happy with the investment. The second one, the project that we chose was, now before I leave that project, I should say we started designing that probably in 2005 and finished in 2008, I think. The next one is about analysis, collation, and communication. And it's land securities at Piccadilly Circus. Now, this is a building with 11 or 12 facades. It's one building. It's a trapezoidal site, very famous. A lot of people see it. 100 million people walk down the pavements every year. And some of the figures take that to 200 million. It depends how you calculate it. But it's a phenomenal number of people on a 24-hour street in the middle of London. The major piece of facade in the first phase of our project was the famous Piccadilly lights. Now, these occupy 1/6 of the entire enclosure of the building. So we had to devise a facade which has got about 7 layers to it. There are the new digital lights, not unlike the screen behind me, but they're very responsive to the weather, they're responsive to the population walking past, and they change, and you can turn them into giant screens and have amazing effects with them. But it doesn't let a lot of light through to the people who are going to work behind them. So we built a giant winter garden, which all the office buildings, all the office workers will look onto and have access to. And the analysis in this particularly fraught planning location with a 60-year history of disputes and arguments, mainly resolved about not seeing any change. So we wrote an algorithm to give us the form that could not be seen from the opposite pavement. So we developed an algorithm about invisibility from the passerby to give us the form of the building, and then turned it into practical shapes, which became a series of slate roofs and terraces. Here's the trapezoidal plan. And for those of you who might think you know Piccadilly Circus, there was never anything behind the sign. A lot of dead pigeons and open space right in the middle of London. We've now filled that in. This was the supposedly empty site. The ghost buildings are all listed stone or brickwork buildings, all of which had to be repaired and stretched. You can see the extent of the digital sign. And these are some of the early sketches of what we have done. Now, we've got to build this on some of the busiest streets in London, and there's nowhere to do anything. And we've got to build it over a tube station. And people live quite close to the site. So it's quite a complicated task. And the team working on this have been magnificent. It's a much bigger team than us. Our firm, about 12 architects working on it, is one tiny bit of the overall scheme here. And there are some 11 facades running around there. Some of them are actually roof. So here, this is what it's like living in the roof now, CGI. This is one of the facades in a field in Kent before we apply high technology to make new bits of the facade and stretch it, repair it, rebuild it. These are some of the new facades facing Soho in the Huguenot district, which are precast concrete with tiles. And the link between BIM 2, our 3D modeling, the modeling studio, the tile manufacturer's studio, the Thorpe's studios and Thorpe's digital infrastructure, Waits delivering these things and the logistics of getting these things through central London, and it is, as I said earlier, complex to say the least. We were, I think, saved by COVID. COVID emptied the streets so we could accelerate the program, we could bring more to the site, and our life became easier. These are the panels going in place, and the response to this has been very good, very positive so far for a very well-observed site. And the new screens are starting to have a new life as well as their advertising life. There's an initiative where Ai Weiwei started it. The lights are given over to an artist for 5 minutes at 8 o'clock every night for a month. So David Hockney here can do what he likes for 5 minutes on the biggest palette he's ever had. And it's linked to Tokyo, to Seoul, to Times Square, to Buenos Aires, and about 5 other cities. The same artistic event happens within this facade, which is transforming the nature of what goes on in Piccadilly Circus through the facade. This involves local planners, a very, very engaged client, Landsec, and a remarkable organization called Circa. The artist produces a print. He doesn't get paid anything. Produces a print. The prints are sold at £100 each, and all the proceeds go to struggling art students so they can afford to live in London and do all that sort of thing. So it's a working, charitable funding facade for a building. Now, the last project is a project that we started 14 years ago and finished a year ago, 2 years, maybe 18 months ago. And when we started, it looked like this. Now, this is now the home of Sony Pictures, and all their films are launched here across Europe. It doesn't look like this anymore, of course, but it's also the home of the Premier League and a couple of hedge funds, and it's in a backwater, or what was a backwater, in Paddington. Now, when we came to design what was going to replace what you're just looking at, this is the inspiration and what we were all talking about before we began talking about facades. And the site is next to Paddington Station. Paddington Station's designed by Brunel. Brunel, great engineer. And Brunel designed the Great Western Railway, which is probably the biggest listed building in Britain. It's 300 miles long. Sadly, some of the best bits of it have been lost. This is one of them. This is the timber viaducts where the Great Western Railway ran into Cornwall and Somerset. And this, I think, is a Somerset viaduct. So we were anxious in our work with people like Google and with researchers and scientists and the other clients that we work with. They're all into veracity, and we were trying to attract the best occupiers. So we wanted something that was authentic in terms of its location. And bear in mind, we were on a Victorian canal, a pre-Victorian canal, a great piece of Victorian engineering. So we felt that an appropriate building should have a very strong engineering presence. This is what we built. It's a Brunel building for Derwent London. Derwent London were very engaged in the whole process all the way through. And allowed us to experiment a lot. It's a very, very, very constrained site, which results in the structure being in particular places, which meant we had an external structure given the planning constraints. Now, none of us would have set out to do that. It's madness. But for this situation, it was the best solution in development terms. And Derwent also decided that volume would be one of the biggest issues here. Could we create a high volume space, high volume workspace with lots of light? So they've actually gave up several floors of the building. It's 17 stories high. They could have had a 19-story building here. And we developed the facade from this starting point. The exoskeleton from our modeling showed that it gave us 30% of the shading of the facade. And the client cannot stand glass buildings and cannot stand floor-to-ceiling glass. And I share his perception of the paradox in that we all like being in them. You get great views when you're out of them, and not many people like looking at them and seeing the debris behind the glass. So we ended up working with Schalderbauer, producing a step module facade to suit the structural system, working with Arab facades and Arab structural engineers. And at the ground and lower floors, which are the only floors which you can see the canals, we've got giant opening doors which are operated by the people who work behind them. So if you're in reception, there are giant hangar doors. There's a new public path, public flock there at the weekends. There's new businesses, people who operate the barge, operate the restaurant and the base. The restaurant provides food. The Premier League, which are on the first and second floors, all have sliding balconies. This is the CGI. This is our model making. And this is a building that is all about models. We have very sophisticated digital modeling. It was a real BIM 2 building. Not many BIM 2 buildings are real BIM 2 buildings. The services were put in with VR goggles. There was no setting out. Everything was done by digital projection. Crown House and Lang O'Rourke put their digital research teams onto the project. Arab had theirs on the project. And we experimented with lots of things to produce the building. We were making physical models of this thing to test everything. We have model studios. We have slaves in the office, which are known as the slaves, which are the 3D digital printers which never stop. They work all night, every day, 24 hours a day, banks of them, making 3D models all day. And physically, for the clients to understand what they were going to get with the building, every piece of the building was physically modeled and tested for neighbors, for planners, and everyone else. We also went through all the stuff which I'm sure you're very familiar with, the sophisticated modeling. This is part of the BIM 2 exercise. But uniquely in our experience, we had massive mock-ups made of the facade, of structural bays, internal structural bays, of ceiling structures, The mock-ups were used for construction testing. They were used for the client to understand. They were used for tenants to understand. Derwent have I don't think I'm breaking any secrets here, have a very large factory in Acton in which you can build these mock-ups. And we took the whole factory to build the mock-ups for this project. And that was one of the most useful elements of designing this project, as far as I'm aware. We do normal drawings as well. This is us drawing for ourselves to explain what it first looks like. It's building under construction. This is the entrance hall. And these are the aircraft hangar walls which move away, which Schaldebauer found a Belgian manufacturer of aircraft hangar doors and then glazed them. And these are controlled by the receptionist. And we thought they might be open for 1 or 2 days during summer. They're open for, I would say, 6 months of the year. We thought there'd be problems with people misbehaving, just coming in off the canal side. No one misbehaves. We thought there'd be security problems. There'd be no security problems. So they were put in as a showpiece, and they've become very much a working part of the facade. And nothing like a showpiece, but everybody can listen to the water through the facade on the outside as the boats go past. The glazing was designed to give maximum daylight penetration, the height of the building to give comfortable thermal conditions, the height of the floors to give comfortable thermal conditions, 12 to 16 meter clear spans, but they also reduce the energy because no one switches the lights on during the day, no need to. And this is the occupied space where people work. And that's what happens with us before we get to a facade. Okay?
Thank you very much, Keith. Absolutely amazing 3 projects. Stunning, all 3 of them. And in fact, I've visited 2 of them, but not the last one. I'm hoping to go and see it up close soon. Just a couple of questions while Ahmed sets up the next presentation. You mentioned on the Piccadilly project, you had an algorithm for the external, to model the external appearance. Was this algorithm looking at sort of angles and surfaces, or was it looking at colors or materials or everything?
It's finding the shape of the 3D object you can't see from the pavement at ground level.
Right.
Yeah. From every pavement around it. And that gives you a very weird shape. Then you have to rationalize that weird shape into something that's buildable and manufacturable and transportable, which is how the plated roof arrives. It also produces terraces because some of the angles are so low you can't occupy beneath it. But we're always writing our own algorithms and Lisps, linking spreadsheets to our digital exercises. It's a very large team that's involved in that.
Fantastic. I mean, it's produced something. I was there yesterday and seeing it up close. It looks absolutely stunning. Thank you so much for today. I'm sure there'll be lots of questions you'll get during the break if you're still around.
Yeah,
thank you for this. Let's move on to our next speaker. Our next speaker is Kenneth Zammit. Kenneth is here. I remember Kenneth as a very young engineer, back in my days at Bureau Happold when he came to us as a fresh graduate. Kenneth has been around in the business for a long time. He's very knowledgeable. He has a PhD from Cambridge, and his most recent position is technical director at Thornton Tomasetti in London. And I think you're going to talk to us about artificial intelligence.
That's right.
Yeah. So over to you.
Thanks, Steve. So a few years ago, I was at Zak speaking to the audience about automation in facade engineering. And last year, we had Russell Cole from Arup telling us a little bit about the data flood, the data wave that was coming and is coming. And today, I want to talk to you a little bit about how we might tackle all this data that is coming to us. Artificial intelligence seems to be everywhere. It's in the news, it's pervasive. And some time ago, I was thinking, how is this applicable to my everyday work in facade engineering? And I hopefully can show you a little bit of how I've lived this over the past couple of years. What you see on screen is the automatic generation of DALL-E 2, an AI algorithm which generates images from text. And I asked it, generate an impressionist painting of a tower with glass and aluminium in the style of Le Corbusier. And I think this was the third image which I selected. To start, I need to introduce our computational research team, without which this would not have been possible. So our core studio are a group of engineers and application developers who help us with our advanced modeling and more recently in our artificial intelligence applications. What we do on an annual basis is we look out for opportunities, innovations, and ideas through innovation tournaments and hackathons. And we take these ideas, and once they're developed, we apply them into our practices. And with some of these, we also take them to our accelerators to develop subsidiary companies. You'll see a few of these later. And most of our work can be categorized into 4 quadrants: automation, interoperability, which is making different software platforms speak to each other, visualization of big data, and more recently, AI, which started with the application of structural engineering. And none of this would be possible without the contributions of 1,500 engineers and other professionals across our 45 offices. So I'll start a little bit with talking to you about machine learning as data science to try to demystify all of this. Then I'll look at some of the tools available now and how these could be applied to our projects. So I woke up a little bit early this morning to practice my presentation, and it was a little bit cold, so I whispered, "Alexa, set the heat to 20, not to wake up my daughters." And the AI deciphered my voice, translated it into a text string, sent it to the thermostat, and fired up the boiler. Yesterday, I was in the mood for some cooking, and I wanted a recipe for tacos. I went into Google, started typing TAC, and Google read my mind. AI is powering all of this in the background, and we're living with it. When I started looking into artificial intelligence and machine learning, I was at first confused. What is the difference between these two? And a definition that I quite found interesting was artificial intelligence is general automation. And it's the concept of machines being able to access the data and carry out tasks in a way that we consider smart. So it's very broad. Machine learning can be thought of as a subset of artificial intelligence, where the machines and algorithms learn from the data, identify the patterns themselves, and then make decisions with minimal human intervention. We often hear that data is the new oil. And if that's the case, AI is the refinery and the cloud is the pipeline. Which brings us to why now? Machine learning has been with us, at least the theory of machine learning and neural networks has been with us since the 1980s. So why is it exploding now? And there are 3 points. One is big data, enabled by the memory chip explosion, which has made it all very much cheaper. Second is processing power. A lot of the machine learning algorithms are also very much applicable to the video card processors developed for gaming, the gaming industry, which has enabled a big explosion of parallel processing, which means that our software can run multiple streams of the same algorithm simultaneously. And finally, the cloud has enabled connected sensors to collect vast amounts of data. So this takes us to the branch of machine learning. And a little bit of a rule of thumb that I use to understand whether machine learning could be applicable is, if you've got a problem where a human being can gain an insight but through repetition and feedback, probably there can be a machine learning algorithm that can be developed which will exceed human capabilities. And one of the reasons for this is that the algorithms do not only use the peak of information and the most recent information, which the human mind is geared to do, but it uses the whole gambit of data available. So the first branch is supervised learning. And this is the most common and also usually the most effective branch of machine learning, but it is also the most expensive because it requires humans to tag a lot of data. We're talking thousands, if not hundreds of thousands of data points. But the simplest form of this algorithm is the good old line of best fit, a simple regression analysis. This is one of the most simple AI algorithms. Of course, this can become rapidly more complex with multiple dimensions. Another one is the data tree, self-explanatory. Then we come to clustering of information. This is oversimplified, but if you can imagine the green being the dog images, the blue being the cat images, and the green and the red being the cow images, the data sets are pointed into this clustering algorithm, the most simple of which is the k-nearest neighbor algorithm, and your new data point can be fitted to the nearest cluster. Where the magic starts to appear is in unsupervised learning, and all of this is enabled by neural networks. I won't go into much detail into this, and I'm by no means an expert, but a single neuron can be depicted as what you see in the screen. You've got your inputs, you've got the weight or the relative importance of these inputs, an algorithm, in this case, a simple sum of product, and an activation function, when to output or not to output. And these are put together in such a way to mimic the way neural networks in our brain work. An example, calculating the price of a property. This would be a single neuron. You've got your area, your bedrooms, your distance to the city, and the age of the property. Weighted appropriately, it gives you the price of the property. Now, this is obviously much more complicated. So there can be several layers of neurons interconnected together to get a better and deeper understanding of the problem, to give you a more accurate price. Now, you can imagine with thousands of neurons, millions of data points, we can very easily get overwhelmed with data. So we need matrices to filter and simplify this information. And you can imagine a filter scanning an image to find the edges of your object. And the beauty of neural networks is that you can layer one upon the other multiple filters, known as a convolution stack, to build upon previous learning. So an example of this is in facial recognition. You start with the raw data, which is with pixels of red, green, and blue. The first layer identifies the edges. The next layer identifies the facial features, the eyes, the nose, the mouth. And the next layer puts it all together into a single human face, which can be recognized. Finally, there's reinforcement learning, which builds upon existing data in learning and augments it with live data coming in. And this is used in robot navigation and gaming artificial intelligence. So hopefully this gives you a little bit of a sneak peek into the black box that machine learning sometimes can seem. So how are we living this? We all use our digital voice recognition assistants. Handwriting recognition over the past 5 to 10 years has become so much better, all enabled by machine learning. We now have natural language processing, which is helping computer algorithms understand the context of what we are saying in a paragraph. But we haven't stopped there. We've got algorithms such as GPT-3 by OpenAI that can generate paragraphs of text with small prompts. And an application of this is Copy AI, where with a few prompts, it can automatically generate follow-up emails to speed up our daily lives. Object recognition, I'm sure most of us have used this in our photo libraries, and identification of kittens remains number one for some reason. But machine learning hasn't stopped there. We can now generate images. This is NVIDIA Canvas, and you can see on the right an image generated automatically by the ML algorithm from the doodle simply scribbled on the left. A more recent one is DALL-E 2, which is now open for public use. And I asked it, show me the future of architecture. And you may not agree with it, but this is what it spat out. And these, by the way, are not stock images. These are generated on the fly by the algorithm. They're not real buildings or parts of real photos. So, coming back down to earth, to our day-to-day lives, the tools available now. So, a few years back, we wanted to leverage the 70 years of engineering knowledge and experience built up at Thornton Tomasetti. Now, gathering data from multiple people, thousands of projects, is very laborious. So we combined this with synthetic information developed through parametric algorithms and calculation tools. And we wanted to compress decades of accumulated knowledge so that we could do what previously took months and compress it down into days. One example of this is our shear wall optimizer, and this app does not actually calculate the shear wall in finite element analysis. It uses a machine learning algorithm to give you the data based on previous analysis examples. The same is used here for glulam timber columns. Next, we tied our hand at knowledge management. And my colleague Emil Poulsen, in collaboration with Rambo, developed FryBotto. Yes, the names get even more quirky. And this chatbot, you can ask it, I want to design a bridge in Germany, in concrete, with a span of 25 meters. And it recommends pre-stressed concrete. Which projects have we worked on in such a fashion? It gives you a recommendation, links to the 3D model, and also whom I can speak to next. This is clearly a test version. One other application is simultaneous localization and mapping, SLAM, and you probably have seen this in action in your robot vacuum cleaner, but this has really taken leaps and bounds in autonomous vehicle technology. And we're seeing this in technology using 360 cameras applied by companies like OpenSpace in the US and Oculo in the UK, where the 360 images are automatically located in your site, and you end up with a Google Street View of your development. Artificial intelligence is used to improve accuracy and speed as the site is scanned one time after another. Some of you may have played a little bit with photogrammetry and LiDAR in our phones now. These can create 3D point clouds of our surroundings. And our colleagues last year, during a 2-day hackathon, developed an app with shop architects that could very rapidly scan the room. You can put a note in 3D space and then access that the next time you visit this location. And it automatically reattaches your point clouds to your surroundings. And this was in 2 days. I was surprised. This app is continuing to be developed, and the accuracy is quite astounding just with your regular phone. Multivista is another company. They developed and they taught a machine learning algorithm through manually labeling 200,000 photos to learn how to identify penetrations in your building that need to be fire stopped. TestFit also leverages artificial intelligence to populate multiple options very rapidly onto your development site. You can put in various constraints to suit your site. And we collaborated with them, sharing our automatically with their garage generator, parking garage generator. Application to projects. So this was a little bit of a fun experiment a few weeks ago with Heatherwick Studios. So you start with a general massing in your Rhino application. You shoot it to the app, give it a text string, similar to what we're seeing with DALL-E, but combining the text string with a 3D model. And in this case, once again, Le Corbusier with a glass building, and it starts to skin the building to help give ideas. In 2018, we started an initiative called Asterix. And the question we posed ourselves is, can we make an app that leverages the experience of 1,000 engineers and apply it in seconds? And here's some of the answer. You start by uploading your 3D massing, including the shear core. That's the reference geometry, which is fed into the algorithm. You also give it your floor heights, your facade bays, etc. And it automatically generates your steel sizing or concrete sizing, spits out your cost, embodied carbon, and weight. And you can play around with multiple different options very quickly. I'll skip to another software platform that we're testing out. This is Reconstruct, building on similar technology which I showed before, adding it to drone technology as well. And they developed an algorithm called Structure from Motion. And I think this video speaks better than I can. Through photos alone, it's generated this point cloud with quite good accuracy of an entire site. What they have also done, here you can see the location of the drone photos, in this case. And then you can select a photo. It's automatically aligned with the 3D model. And lo and behold, you can also take measurements from within your photo without any LiDAR, which is laser distancing, purely from photos. And of course, they also have technology to align your BIM model through this point cloud and your 360 imaging. See, and this is another example, a photo which can be measured upon, and the point cloud automatically aligned with a plan or your BIM model. But seeing is believing, so we called them in to do a scan in our office, and it automatically generates the plan that you can see in the bottom left, with no input, just walking around with the camera. Within minutes, a point cloud was generated, and I was astounded to see centimeter level of accuracy. T2D2 is a software we developed in-house using AI defect mapping. And we developed an algorithm taught by thousands of photos, which can automatically detect spalling of concrete, cracking of brickwork, exposed rebar through photos, drone footage. And here you're seeing the drone footage with the computer vision activated. And also in 2D, stitching together hundreds of photos, high-resolution photos, and detecting the defects over these. And you can imagine, once the defects are detected, it saves a lot of time for the engineers, because you don't have to scroll through thousands of photos. You can direct your attention to where this is necessary. And of course, this can be translated into 3D. Needless to say, automatically generated reports which highlight or attract human intervention when the confidence interval is relatively low. So you don't have to see everything, you just identify, and your attention is drawn to where it is really needed. Our naming convention, once again, T3PO. We're in discussion with George Lucas about the naming convention of our next piece of software, but this takes it into thermal imaging, the same technology. Where has this led us to? Our experience with Asterix, although successful, it taught us that if you try to do a little bit too much and automate a little bit too much, it gives us quite a lot of limitations. So we developed Swarm. And this is essentially a platform which enables your Grasshopper algorithms, which is a parametric piece of software, to be moved directly into the cloud. So within your browser, this is an example of a tower generator, just playing around with the geometry. But you can imagine the power of this, which can include computational analysis, all within the browser and within your phone. What we realized shortly after that is that Shapediver was developing a similar technology. So we merged the two companies together, and it enabled product configurators to be developed, even by small companies, not only by the behemoths who have the power to develop this software, quickly to produce product configurators and link them to digital fabrication. This is an example, cake houses for modular housing. Within a few clicks, it generates your 3D model in the browser, gives you a price, and you're ready to order. What we want to do next, and we're progressing this, is to move artificial intelligence and machine learning to give the same level of accessibility to engineers and designers who perhaps do not have the experience with machine learning. So my colleagues developed a back-end application interface and a user interface for all of this. And essentially what it does, it allows the engineer and the designer to pick a data set, choose the machine learning model that they want to test, because this is not always 100% clear. You sometimes need to test multiple different models, and then pull this into their preferred piece of software to give the results. When speaking about AI and machine learning, I think I need to speak about responsible AI. And as with any tool, it can quite easily be misused. But as DALL-E 2's idea of a lizard mad scientist playing with AI, be careful and be responsible. Thank you.
Thank you, Kenneth. I see a lot of staggered faces in the audience. They're not sure what they just listened to. Are there any kind of applications that you're using currently of this technology in your day-to-day work, or is this all stuff that we might use one day in the future?
I think it's applicable now.
Yeah.
There are smaller bits of software, like the ones I showed, which can be quite easily developed, little apps.
Yeah.
And I suggest starting small.
Yeah.
It's not that daunting, actually, to use the technology once you have the data. You need to gather the data. Once you have that, it's quite easy to apply algorithms and get the answers. So that's one side of thing in the design space. On the construction site space, this can certainly be used now.
Yeah. I mean, some of the stuff you were showing about
That's
defect
right.
detection.
Defect
drones
detection, the
and so on.
drones, the photos.
Yeah.
And I see this coming very soon to the UK because of the Building Safety Bill. The
Yeah.
golden thread of information. We're going to need this. There's going to be too much information. And we need to capture it and be able to digest it. There are not enough engineers in the world to do this alone. And this is where I think this will become inevitable.
Great. Thank you so much, Kenneth.
Thank you.
We're going to move to very much a facade topic next. We're going to talk about facade systems, but trying to use them more intelligently with other components that practically every building has, a blind and some air conditioning ducting. So I hand over to my colleague, Andreas Dziuk, to talk to you about that.
Good morning, everyone. It's a great honor being here and speaking in front of you. Before we start, the topic that I'm speaking about today, one of them is the ACT facade. We have a great mock-up, 2 meters in height, 1 meter in width, and it shows exactly what I'm talking about today. Unfortunately, it's not here today. So that's a bummer, yeah. It was supposed to be in the hallway. I have the most understanding boss who said, "Don't worry, Andreas, it's not a big problem at all. Just make sure your presentation is 150%. So as you can imagine, the pressure is very low. Thank you, Antonius. Beck. And yeah, let's jump right into the topic. So today I'm speaking about global warming, low-tech facades, and the opportunity to save operational carbon. Here we see a glacier on the right side in 2004, on the left side 50 years earlier. This is exactly the same glacier, obviously melting. This is Pakistan this year. 2.1 million people lost their homes. This is because of melting glaciers. 1,700 people died. This is Greece also this year in summer. Instead of the typical 4 wildfires, we have seen and counted 30 this year. 2,500 acres of land have been burned down compared to the usual 90. So this is 25 times as much. The equator belt, this is a perspective until 2070. So experts are saying until 2070, it will be unbearable to live in this area. So we have metropoles like Mexico City, Lagos, Mumbai, Islamabad, Jakarta, and Manila. And the annual average temperature in this area will be around 29 degrees annually. This is exactly the same which we have today in Dubai. 2 billion people will be affected by this. 2 billion, a quarter of our population. The global warming curve in the last 50 years is increasing rapidly. If you just focus at the very end there, you can see it's almost going exponentially. Sorry, actually I have to. It's going exponentially. And the reason for that is actually a chain reaction of the events which I've showed to you before. So the frequency of extreme catastrophes accelerates dramatically. And each of these events further add to the original problem, sometimes even multiple times. Melting glaciers, which flood cities, inhabitant people, which require new infrastructure and also new homes, fighting extreme wildfires, and vast destruction of the healing lungs of our Earth, trees. We're looking at the snowball effect here, a snowball which keeps rolling and growing. Okay. So why am I telling you this? Why do I care? Why do we care? Our industry is responsible for 40% of energy and material requirements worldwide. This equals approximately 50% of carbon emissions embodied and operational. 10 to 30% is coming from the facade. So let's have a look at whole life carbon, a prognosis until 2080. Today, operational carbon 72% against 28% of embodied carbon. In 2050, equally 50%. In 2080, 80% of embodied carbon, 20% of operational carbon. So there's a couple of things which we can see here. Number one, good news, the carbon emissions are actually going down. The reason for that, mainly though, is that operational carbon, in general, this is due to renewable energies, especially for operational carbon. So we can also see operational carbon and embodied carbon, the ratio is flipping in the next 60 years. So embodied carbon becomes more and more important towards 2050, 60, 70. Right now, the majority that we're looking here is this blue factor here, operational carbon. Wait a second, let's just recap what I said, because this is very important to understand. So I'm showing this now in a different graph, overlaying the last two slides in one. So global energy emissions, today the building sector 50%, the ratio between operational carbon and embodied carbon in 2050, in 2080. If we put the facade in perspective, right there with the yellow column at the very bottom, this is actually embodied carbon in facade. This is the amount of embodied carbon in facades. So if we put this in perspective on another slide, just to let that sink in for a second, this is what it looks like. So we're talking about the factor between 15 times or 15 to 24 times embodied carbon versus operational carbon. And don't get me wrong, I think what we have done as an industry, especially here in London, in the last 2 or 3 years, looking into embodied carbon, how to reduce embodied carbon in facades, I think this is great what we have done. There were great achievements. The CWCT releasing those 2 papers, how it can be calculated. We know how to specify it properly these days. And I think we are on the right track for the next 20, 30, 40, 50, however long we need to reduce carbon overall. However, there's a big potential in operational carbon, which we should not ignore and we cannot ignore. Therefore, I'm very excited and proud to present a solution which is able to reduce operational carbon in a very smart and simple way. ACT facade. ACT facade stands for Active Cavity Transition Facade. Cavity, is Schüco going to the closed cavity business? No, we're not. However, in the last few years, together with other industry leaders, we have developed a low-tech facade scheme, which works very similar to a twin skin facade, but without the second glazing layer. using existing, simple, and tested components. So this type of facade, or this facade scheme, it's not a product, it's a scheme, and it can be applied on different types of facades. So a fully glazed, unitized office building here on a green field, for example, or a more opaque window ribbon system. That's also possible. This is a refurbishment, by the way, the second project here. So that's possible. We see more and more these days that fully glazed office buildings are not that popular or are becoming less popular, I think because also certainly because of the sustainability topic. So it can be applied to different types of facade. Let me run you through the different components of this facade to explain to you how it works, how the principle works. So we do have an outer skin, either double glazed or triple glazed. It's a conventional facade. It assumes the thermal, weather, and sound insulation functions. It does shield the exterior from the interior. There's the inner skin, typically textile, typically a coated textile roller blind. And it's controlled by the building control unit. It can be manually overwritten by any user at any time. It does provide an adaptive sun protection. It controls the heat gain. You can fine adjust the heat gain by changing the position of the roller blind. And typically the openness factor is between 1% and 5%. The adaptive cavity, that's the corridor between the inner and the outer skin, together in combination. It's been continuously flushed with air, with fresh air supply. We get to that later. And this flow avoids any accumulation of heat in this cavity. Also, it enables for easy maintenance and cleaning because you can remove the blind at any time. The air supply. The air supply is coming from the fresh air supply, mechanical ventilation within the office space, so there is no further capacity, no further increase of volume required. It is exactly the same fresh air supply for the users within the office. There's a continuous circulation which needs to be guaranteed in order for the facade to work. And as I said before, the warm air is being flushed out of this cavity, so it doesn't become, before it becomes a problem, it's already out basically. The exhaust interface typically sits below the spandrel area, highlighted here in green. It can also sit at the ground, so below the raised floor. So in case if an architect wants to see, doesn't want to have a suspended ceiling, want to see the concrete at the slab, then you can flip that system. I show that later in a case study. The ductwork is exactly the same as you need also for your fresh air supply, because it's the same volume, it's the same airflow. You might need to reposition that ductwork slightly to the facade because you need to connect it to the facade. Of course, that's one thing which needs to be required. The warm air can be exhausted directly to the outside, or in combination with a heat pump or a heat storage, it's possible to be the most efficient and the most smart. So from here on, the climate and the MEP specialist can use their creativity to make most use out of the scheme and the captured energy. So there might be a higher effort required in the early coordination stages and further efforts for planning the ductwork. However, it is an investment which can be returned, for example, in reducing the annual overcooling loads, and that for the lifespan of a building. So it's a financial investment, an investment in saving our environment. Let's have a quick look, comparison of the ACT facade to other related facade types. So on the very left, we have the traditional double skin facade, not so popular here in the UK. The closed cavity facade with a total depth of 300 millimeters for the whole package, 2 layers of glazing, internal screen. The box window facade, which has an approximate depth of 200 millimeters, again, 2 layers of glazing, more aluminum because you need to have an openable on the inside, and the act facade where the space up to the inner glazing is only 75 millimeters and 180 millimeters approximately to the end of the mullion. And there's no internal glazing, only the external glazing, and of course the internal sunblind, which we have anywhere. Oh, before I change the slide, an interesting comment here, of course, less aluminium, less glazing means less embodied carbon as well. So compared to the other system, you can save 20 to 44% of embodied carbon. This is a CGI showing the unitized facade, showing the act facade applied to a unitized facade. It's very clean and neat and very simple, the connection really. The same for a stick system facade, it can be applied, it looks pretty much the same. And this is a vertical section showing the sunblind at the very bottom, highlighted in yellow. In green is the air exhaust interface, and then the exhaust air extract in red on the right side. This is where the creativity of the climate and MEP specialist is starting, basically. This facade invites for customization. It is not a product, so it can be varied for any project. It can go, for example, if we just look at the airflow, how this is being organized, it can go up, it can also go down, it can go through the blind if there's a higher perforation factor. It can gradually go through the blind if the blind is gradually perforated. This is just looking at the textile, so there are many variations for the textile. There are options also for the type of blind, if there's a guide rail, if there's a zip screen from Varema, for those who know this product. It can be also a Venetian blind that works as well. This is more difficult because it can make some noise, but it's possible. And a curtain is theoretically also possible. So there's many studies ongoing at the moment, project-related, to have different variations and options for any of the components which I've showed to you earlier. So, yeah, in summary, the act facade is a low-tech conventional facade with an internal screen, which you want to have anyway, especially if you have a highly glazed building. You have an additional exhaust interface. You receive an adaptive cavity, an adaptive G value, and there's a huge potential for recovering energy and being cost effective. There's a video, I hope that plays smoothly because it didn't all the time when I was testing. It shows what I've just said. It summarizes what I've just said. In a small animation, here in an office building, a typical day, not much sunlight, no active cavity activated. Now the active cavity is being activated. The blind is slightly down, doesn't have to be all the way down, just halfway is more than enough. It flushes the warm air in the cavity, which accumulates at the moment. On a sunny day, from the middle of your office space, approximately the middle, it can be at different positions. The fresh air supply is being redirected to the facade. There's a small gap at the very bottom where the air can go inside and thus flush the heat away immediately. Case studies. I want to show you a case study, the Festo Automation Center, which I spoke about before, which has been executed by company Schindler in the south of Germany. They are located there, and the project as well, so that's close to Stuttgart. And Festo were a perfect first client for developing this facade scheme. Actually, it was their challenge to the design team and to us, to Schüco, to develop something new, something low-tech, simple, and highly efficient. So on a cloudy day, the system works like this. The window, as you can see here, it's a pop-out window, the AWS 114 from Schüco, which is open, and the fresh air supply is being provided through that window. There is an electrochromic glazing integrated into that window, which is now inactive. The ACT facade is inactive as well. You can see the blind is all the way up. On a sunny day, the window is closed. The electrochromic glazing is activated. You can see it's pitch black here. And the fresh air supply is now coming from within the office space and flushes through that facade, now importantly above the screen. So this is one of the variations here, because the architect didn't want to have a suspended ceiling. So it's flushing up to the internal screen, flushes the warm air all the way down to the air extract, which is sitting in the raised floor. These are two sections showing how the unitized system, on the left side showing how the unitized system works like. You can see the raised floor. Don't be worried, this is not so high because of the ACT facade. This is for different reasons actually, but it did allow us to integrate the air exhaust interface right there. On the right side, we are looking at the stick system, which we have at the ground floor, and it integrates the zip screen, Varema zip screen, which is integrated into the mullion, back at the mullion, as you can see, I hope. Let's highlight this here if that's, no, I think it's clear to see. Measurements, there have been excessive measurements and simulations which we have done with our partner, the Fraunhofer Institute in Holzkirchen, Germany. You can see the sensors here on the inside, on the outside. The air temperature, flow velocity, pressure difference sensors have been located at the top, at the middle, and at the ground, inside the cavity and outside the cavity. The airflow has also been measured, of course. We wanted to make sure that the end user has the highest comfort, especially sitting next to that facade. Is there any draft ongoing which is uncomfortable? That has been tested, and we received very excellent results for that. Also, we wanted to make sure you can see, I hope, the smoke here, to make sure that this continuous circulation which is required is actually going, the air is actually going where it needs to go. Calculations, of course, many calculations have been done. One of the most important ones, certainly the G value. What happens with the glazing if the internal blind is down? I don't want to go in detail here, but the G value has been reduced. So the glazing itself, G value of 0.32, with the active cavity facade being activated, halved to 0.16. Also, everything in between is possible depending on how you change the position of the screen. Festo are very proud of their project and they are monitoring constantly how good the building is performing, which is really interesting. They have a twin room installed in the building, so which is 100% identical with the one exception. The ACT facade is not working on the left side in red, and it is working on the right side in green. And the temperature between those rooms annually is 3 degrees difference of 3 degrees Celsius is the difference between those two. And that actually translates to 25% cooling loads reduction for these two rooms. So here are the facts of Festo in summary. I just want to highlight the 3 most important ones. So this cooling load reduction translates to the whole building to 10 to 20% annually. There's an uplift of approximately 5% for the additional hardware which you need, which is mainly really the air extract at the top or at the bottom. And this project has received the DGMB Platinum Award. Platinum not only because of the facade and the performance of the facade, but it did receive excellent ratings for sustainable, innovative climate and cooling concept, as well as excellent user comfort. Another project which I want to mention briefly, because we're running out of time, is the Continental headquarters, also in Germany. The interesting thing here to see, here's a customization which has been done, so the airflow is not going above or below, it's going through the screen here. So there's a higher perforation factor, and the cooling or the temperatures which we receive whilst measuring how this facade performs. In front of the glazing, you received on a peak day in summer 30 degrees Celsius. And behind the screen, you receive 25 degrees Celsius. So a reduction of 5 degrees, which is really a lot and does a lot to your cooling loads. To achieve this, you need to balance the higher comfort, or it is the higher comfort really against the least operational energy which you want to spend. So this is the overall goal which needs to be achieved. How to achieve the comfort? These are four parameters. So the unobstructed view, minimal glare, maximum daylight autonomy, and maximum heat gain, depending whether it's summer or winter. And these 4 factors and parameter needs to balance against each other. Our partners for this facade are the Fraunhofer Institute, Transolar, who are climate and MEP specialists in Stuttgart, and Varema, who are the market leader in sun blinds and sun protection, and Priedemann Research Lab, Facade Lab, their research lab in Berlin. So, team effort is required. I've added this slide, even though I know we all in the building industry work very closely together and we are used to working as a team. But I still decided to add this slide because the facade, climate, and MEP specialists together with the architect have to drive the project in the same direction, and that from a very early stage on. So we will happily, as Schuko, provide support for this process, and we can bring our experience and the knowledge to the table. We can also introduce some of the partners to help the process for any project that you want to drive as ACT Facade. But with ACT Facade, you cannot switch a project last minute to be green and sustainable, as for example with low or ultra low carbon aluminum alloys. With the words of John Ruskin, quality is never an accident. It is always the result of intelligent effort. All of us here in the room are engineers, architects, innovators, tech and facade enthusiasts, very bright and smart people. Let's not forget where we're good at: teamwork and using our brains. That's the fun in our profession, isn't it? So please don't hesitate to speak to us. There's no one-size-fits-it-all scheme. This project or this scheme does not suit any building, fair to say. And let's discuss opportunities and possibilities within your project. And hopefully, together, we can all contribute a little bit more in stopping the snowball from becoming an avalanche. Thank you.
Thank you, Andreas. If you stay there for a minute, please.
Yeah, sure.
So to summarize, what you're telling us is you have a low-tech solution using standard available components today, which is facades, blinds, and some ducting. But the key step that you need is an early engagement, especially with the MEP design. It's not something you can switch the project to if you've already started down the line with a certain MEP design. You have to focus on the MEP design of this from the beginning.
100% right, yeah.
Yeah. Thank you so much. Thank you.
Thank you.
Our last speaker before our break is Stephen Beck from AGC Glass.
Yes.
He is going to talk to us about low carbon glass.
Yes. Yeah. Good morning, everybody. As Stephen said, my name is Stephen Beck. I am the International Building Project Manager for AGC UK and Ireland. I've worked for AGC for 12 years, and my role is to offer support to architects, designers, facade engineers. So a little bit of background on AGC if you don't already know. I won't run through the figures, but AGC are a world leader in float glass production. We specialise in two main areas, being automotive and buildings. If you don't know AGC by name, I'm quite sure you will know the products. We are currently in 1 in 4 cars, and more relevant for this audience, we are in 1 in 4 buildings across Europe. So AGC as a business, we've committed to reduce our carbon emissions by 30% by the year 2030, with a work towards being carbon neutral by the year 2050. So a very important key part of this journey is to reduce the CO2 footprint within glass production. So I'd like to show a short video now, which will give you some idea on how we're doing that. No volume.
Of the whole value chain, including the direct but also the indirect CO2 emissions. We melt sand and raw materials with electricity instead of natural gas. We pay a special attention to the type of raw materials used, including the recycling of glass cullet. Sustainable logistics has also a crucial role in this whole process.
For this low-carbon glass, we combine positive aspects of several raw materials. Not only the use of low-carbon soda ash, but also of local sand obtained with minimal processing and sustainable logistics.
Such high percentage of recycled glass requires dozens of different cullet flows that we collect. Our challenge, together with all our suppliers, is to keep our strict quality standards and to perfectly manage the use of this cullet in our furnaces.
Green energy is produced on site via photovoltaic panels, also by cogeneration, where we cogenerate electricity and heat, and we recover heat and make electricity.
The launch of AGC low-carbon glass range is an important and ambitious step in our journey to carbon reduction. Today, we are very proud to offer to our customers a glass that, from the extraction of raw materials to the final installation, will be generating 40% less CO2 than our traditional solutions. We want to support our customers in their effort to reduce carbon, and we want to lead the way in our industry for a better world.
So, as you will see, unfortunately, I won't have time today to go into great detail regarding each one of these pillars, but there are 6 key pillars to reducing the carbon output. So, the sustaining of raw materials, the highly efficient melting furnaces, the increased use of recycled material or the cullet, using the green energy and transportation, whether that be internal between factories and deliveries. I think the key message to take from this screen is it is all 6. It's a very holistic approach where everything combined is used to reduce the carbon output. So what does this mean practically? So we will start production of low carbon glass in December this year. in our Belgian factory at Moustier. And then early 2023, we will open another factory in Sambus, where we'll produce low carbon glass there as well. This is to supply the growing market across the Europe and the UK of low carbon products. So the low carbon range will have the same aesthetics, the same quality and the same performance as traditional float glass, but with an added reduction of 40% of the low carbon. So as you'll see there, 7 kilograms per square meter based on 4 mil. The products that we will be producing will be the monolithic float glass and the laminated products, so the Stratabel Strong, the Stratabel and the Strataphone. Also, the insulated glass with the I+ and the solar control range for the facade market, so the stop rays and the iPasols. Again, I just need to highlight that this will be available from December this year, early next year. So I've added a new slide in the next one, which is fresh off the press today, which basically we get asked a lot about recycle, reuse. So we now have the ability to reuse IGs, and we can take them apart, use laser measures to see what if the quality of the glass is okay to reuse, and we can use that as part of our offering. So it was a very short presentation. I know we're on a time limit, so myself, my colleagues, Mo, Henk and Andrea are here all day today. So if you like any questions, please get in contact. Thank you.
Thank you very much, Stephen. It's great to see the steps that are being taken by industry. And I know from our side, with our downstream supply chain, we do exactly the same, demanding audited data, accurate information. So it's great to see you've got all that in place. It's also good to see you're using colored.
Yeah.
How do you deal with coating on glass when it comes in coated glass? Can you use it as colored, or
you can still use it as color? Yes.
you can use it?
Yeah, yeah.
That's great.
Yeah.
Good to hear.
Okay.
Thank you so much.
You're welcome.
Before we go to break, can I please ask the speakers from the first session to come back to the stage, please, and Sean to join us on stage, and the rest of you can have 30 minutes for a coffee break. And see you in 30 minutes. Thank you. Well, welcome back, everybody. I hope you enjoyed the break, and it's good to see, we were just saying, it's so good to see people talking and networking outside, because that's as important as this part of the event. So it's great to see that. But we have a really exciting session, the second session, and kicking us off is one of my favorite architects, I have to say. John Bushell is a senior partner at KPF in London. Most of us have worked on some KPF project at some time or other, and it's the second time we have the pleasure of John speaking to us. So I hand over to John.
So good morning. I would like to talk to you about 81 Newgate Street, or BT as it was previously known, now Panorama St. Paul's. The building here, right just north of St. Paul's, and with a very sensitive context. This is a lockdown child. This was designed, as we started this, just as lockdown started. We've got planning permission after 6 months, so it was a very streamlined process. But this tries to be representative of all of the new city guidance that came out just before lockdown about what a good building should be, including operational carbon, embodied carbon, urban greening, cultural activity and activation, public access. So this is, we think, hitting all of the points for the city's vision for future buildings. And it was an evolution of our thinking here. And I'd have to say at the beginning, we had very early assistance from Mace and from Grants of Shoreditch to help develop some of these ideas. But the idea is that as far as is possible, this seems like a new building, but it's assembled from everything that existed on the site previously. So we've kept the frame of the building, we've reused the stone, and we're reusing many of the other components that are there. So this idea that an existing building can be reinvented and transformed to make something that feels absolutely as new, but has a huge embodied carbon advantage through doing that. So there was a developer bid, I think, between new builds, not doing very much. I think we were the only people who came up with a transformation, and there are many challenges to that, but it seemed to us as already a site where a very much bigger building was not going to be possible, that we should work as hard as possible to try and transform what is quite a bunker and quite a difficult building into something that felt absolutely new. So these transformations, KPF actually loved them. It's a kind of really strong part of our work. We were the only architects to suggest the World Bank in Washington, DC was a transformation 25 years ago. And that's just getting a lot of attention as it reaches its 25th birthday. So although we keep a lot of this building, it doesn't look the same. And so the idea is to be as creative and inventive as possible while keeping the carbon. And the mechanism that really helped unlock that was thinking a little bit about the history of the building. So it used to be the GPO. It's a property services project. Quite like the fact that the architect really wanted to make it pretty modern and ended up being a ginormous amount of Portland stone. But it was built extremely well. And because the PSA don't have to comply with all the planning laws, it actually doesn't stay within St. Paul's Heights. So it blocks some views of St. Paul's Heights and St. Paul's Height grid. So the fact that it had a lot of stone, was built very well, but needed to change a bit if we wanted to be a good citizen in terms of being near St. Paul's, got us to the point where we could change things quite a lot. So the building was 3 buildings with a large atrium in the middle, but quite a deep atrium. And effectively, where we add in cores, and we've learned over, through the Unilever HQ in 1930s building, King's Reach a little bit later, is relying on the lifts, the working aspects of the older buildings is very much problematic. So we put new cores in the atrium, as you can see in the middle. The ground floors didn't relate, but actually making a route through for lots of other reasons also meant that we could just negotiate the levels of the outside to the inside well. And then the St. Paul's Heights clipping the front in the end became the idea that we could pixelate or break down the massing of the building. And obviously, at the same time, we wanted to see if we could increase the overall net area. So this nearly doubles the net area on the site, but it keeps 75% of the existing structure. So putting the gross areas in the atrium was one of the big things that helped that increase in net area. Again, what we did on Unilever. And being a good citizen to the church and St. Paul's seemed to align exactly with creating terraces for every level, which both is part of a wellness agenda and part of the urban greening, and means there's amenity to every floor of the building. And it helps disguise what was added and what was retained, so it becomes blurred because of the change in the massing of the building. And then making this route through the building is the start of something that is really evolving into something very exciting. So left-hand side, the previous building. On the right-hand side, you can see that we give room for the dome in the drum of St. Paul's. And really the deal was, if you take that space away, you're allowed to add a little bit of space on the top of the building, but that was much more valuable space. We added about 2.5 floors on average. And taking space away at the bottom of the building helped with the depth of the floor plates on the lower floors. So with that, you can also see that we wanted to change the reading of the building from floor by floor by floor to bring more daylight in, and to therefore take some stone off. And the evolving idea that we had at planning is let's try and reuse all the stone. And I think it was a pretty brave commitment to make at planning. And the planners did continually ask us, are you really going to do this? Are you really going to do this? Because it was something that they were very taken by. And I would say it is only through, and it's been a roller coaster, as I think some of the people in the audience will know. We wondered whether it was possible, but through, I think, grants of Shoreditch's expertise and tests and things, we got to the point where we thought we could reuse all of the stone. So as a diagram, we have roof gardens, we have a biodiverse roof, a publicly accessible roof, a restaurant up there, and also space for the office. We have terraces for every floor, a very accessible and open base of building with a route through the middle and a cultural strategy. And then lots of things follow through from that to reduce its operational and embodied carbon. So the route through, a very tiny little bit of new build in one corner to add a really good gym and health club, all the way up to destination to the top of the building, and bringing light in from the side. So you see that the top is all of the different, the fifth facade, my favorite facade quite often. I did my fifth year dissertation on roof gardens, and so they're a key thing for any project that we're trying to do. Bringing light in and linking the building to the outside, even though you were in that amazing site previously, that wasn't really very obvious. And then transforming the ground floor, using the existing entrances to get in for the office space, but then all of the more active spaces through the route through the site. And that helps link to, so Tate, St. Paul's, the London Museum coming in the Barbican. The city is struggling to get people to kind of see the stepping stones of walking from one space to the other. And so the idea evolved that we would make us a destination and be on the list of places to go with the rooftop gardens and cultural events. And so that just shows then the complexity of trying all of those ambitious things within the existing concrete frame and the existing slab levels. But the route through, you'll see there's a gentle ramp through, and keeping the loading bay where it was, using the previous entrances, but transforming it totally from something that was closed to something that is open. Urban greening from the very base of the building all the way around the base. We're very skeptical about green walls going over a particular height. It needs to be accessible and easy to use. Terraces at every level, and then a roof garden that's trying to do many things, but it's enabled by the fact that we always try and stack all of the mechanical services to one side of a building. If you look at our buildings, the MEP engineers are not allowed the roofs. We can just have a vertical slot, roofs are for people. And then we share it out between the public, office, and biodiversity, with the bees and all the rest of it. But you can see it's really, truly amazing. So all of this as the stated intentions, we got through planning. It's very much got a lot of energy, but really trying to take this view that the operational and the embodied and the life cycle carbon testing is all part of the story that gets you to an answer and a scheme. And we're presenting to lots of different people, tenants, funds, etc. And this does manage to get to all of their preferred objectives. So we have a fantastic, so Chapman BDSP is the MEP guys, a fantastic operational carbon, but part of that for us is to have mixed mode throughout the building, so that open or build windows at every level on every facade. We're not claiming that replaces all the systems, we're claiming that that is one of the ways in which you reduce the load on the building. And then in terms of embodied energy, we definitely see carbon as a baton race. You know, we started this in the design, the design team take it on, the contractor take this on, and the owner and the operator. And so in keeping 75% of the structure, just getting rid of that corner that we need to for St. Paul's, you can see we've made a really big reduction in the embodied carbon of the building. But also because as we were looking at the structure, we thought, why not the stone? Why not the facade? So it becomes something where all of the solid of the new building was there already. And we've just fixed it onto the building. So this is just showing the piece that we removed and putting the new cores in the old hole, so nothing destructive about putting new lifts and circulation in. This shows how the massing evolved, and you can see that what was taken away from the front becomes something that's added to the top, very much strictly limited by views of all sorts of view limits to this. but maximizing the potential of the site and its interaction between inside and out. And I think we felt that everything that helps embodied carbon and operational carbon and COVID and wellness, and they're all saying the same thing. They're all saying a more complex building that's interesting to be in, a place with lots of different settings, a place where you can open the window, but you do have the resilience of systems there. And a lot of attention actually to smaller lets and multi-let building. And then this begins to show the evolution of the volumes of the stone from the existing building to the proposed building. And obviously we think that one part of what we've achieved is making it a more refined, more elegant proportion. But it's remarkable that actually, so we did a match to get every single piece of stone here to have a proper place there. So you can see effectively we've got 2 square meters of granite that we couldn't find on this huge building, so ginormous building. So we basically reuse 80% of the stone. There's just some pieces that are awkward or difficult. Those bits of stone we're now using in the lobbies. So there will be no stone wasted on this building. And yet I think it was a very unpopular building for feeling like a bunker and very closed. So that process was to look at the facade, to imagine making the double reading. We like terracotta, which we think has some very good embodied energy and long performance characteristics if it's applied to the building in the right way. Added in lots of vents, and came to a new wall type, which Fawcett and Grimshaw Shoreditch are putting together. And it does represent, we think, a complete reimagination or transformation of the building. But actually, going from there to there, the yellow stones are put in the yellow area, the orange, etc. So it's just a way of shuffling all of those units from one configuration to another. Obviously, that was quite a lot of work, but satisfying to do. We reused all the curved stone on the corners. Brought in winter gardens where there were slots before so that they can become inside-outside spaces, and then enjoyed the terraces, but again using the stone throughout. Big entrances, there's a retail lobby, etc. So just showed this to show you, in fact, it is a fully, the whole of this building is reused stone in this different configuration. And what we hope this demonstrates is that there's no limit to imagination while you're reusing things, right, with the structure, the materials throughout. And you can see the plant at the top, just on the north elevation. So the process is to carefully remove things. You've got to be careful. You've got your demo guys on the right wavelength here. But carefully remove the stone. Very, very, very low wastage rate in that. We're cleaning it. And taking any of the little bits on the back off too. And then modern methods of construction may want to build this in no time at all, obviously. So it's much, much, much larger components put back, and grants are doing all of that. All went on its way. And so we get this kind of complete transformation between the two. We're really pleased with this result, but it's been a lot of kind of consistent application of a direction. It was many times possible it would be cheaper to get some stone or not. It turns out no. It would be easier to do various things. But you can see that its character is utterly different, and we think it reflects or gives itself another generation of use with many external spaces, many beautiful places to sit within the building. My boss Jean always says the more corners you have, the more people who can feel important. So lots of corners, but actually a really interesting and completely different composition to the building. Just one last thing, we are working quite hard to get a new London Square, which we think will complete that, and that's also part of less traffic, more possibilities, and we think this will really cement the idea that we're also contributing to what happens next after you see St Paul's and move further on. So I think it was a little bit slow before the break, so we'll just try and make sure we can keep momentum this time. So that's using the building everything you can imagine using. The other things, the handrails, the floors, etc., were reused, but we've done that before. So we see this as what we hope is a good example. There are some other architects doing similar things, but a really nice example of how to rejuvenate a site.
I think you were very modest, John. It's not a good example. For me, it's the best example I have seen of planning to reuse a structure, planning to reuse the materials that are already in this site into the new building. I think you guys have gone to great lengths to do that, and the end result looks just amazing. I think you must have had some fun and games with your structural engineers as well, with the retained structure. And
should say AKT2. Definitely, I'm not sure if any of them are here, but they are amazing. As obviously many other engineers, but in this case, they've done us proud, yes.
And how far is the building from completion? And will the restaurant at the top be open to the public?
Yes, of course. And in fact, there's a large portion of that roof which has to be preserved for access to the public without any charge. So the facade mock-up passed its performance test yesterday, I was told by someone in the audience.
Congratulations.
So it's on site, well on its way. We have our price fixed. We feel very fortunate. We got a GMP just before last Christmas. I'm not sure that we could do the same at the moment, but so we're well on our way.
Fantastic.
Yeah.
Thank you so much.
Thank you.
So our next speaker is mic'd up and ready. It's David Entwistle from Saint-Gobain. David's going to talk to us about decarbonizing glass. I think it's a follow-up from last year.
Maybe it's the same as last year. I'm loving the scarf, by the way. Nice scarf. Well, good morning, everybody. How you doing? Well, there's a few people sort of doing all right. I walked out of my hotel this morning and walked past a guy with a pushchair with 2 dogs in it. And it's just funny how some things just make you smile when you start a day, you know, and so maybe you're smiling just because you like my shirt this morning, I don't know, but hopefully we'll be all right. So, well, it's very kind of you to say so. And don't you think the people at this Zak organization are amazing? I mean, who else could actually make the train people change their strike day? I mean, it's amazing, isn't it, you know? So as long as we pay our invoice on time, we're going to be fine, but obviously they're very influential. So a year ago, I stood here and talked about how glass is 100% recyclable, and it's also infinitely recyclable, but we don't do it. So this is a bit of a catch-up, and hopefully everything's going to work, he said, hopefully. Oh, there we go. Thank goodness for that. So we're a year on, and I'm a year further on in doing my MSc in facade engineers. Any MSc students out there? There was a few very quietly going, ooh. Yeah, I told my wife that I'm now half a master. I thought she'd be impressed, but I think she figured she was still married to the bit that was the un-half a master, I think. So she wasn't too impressed with that idea. But you know, when I stood here a year ago, I talked a little bit about this world that we live in and our concern about the world that we're creating, what we're leaving for our kids. I'm a grandparent. My daughter's got another one on the way, so her and her husband have been busy, which is good news. But you know, it's not even about that. It's actually about the fact that the people that are going to suffer most from global warming and all the consequences of it all are going to be the poorest people and the people who are most vulnerable. So, you know, there is an onus on us to do something. So, how much has changed in a year? Has much changed? And the answer is yes and no, to be honest with you. So much more dialogue has happened. I can't tell you, every week there's a meeting with a client, a main contractor, a facade consultant, a waste management company, a demolition company. You know, these meetings are going on all the time. And the reason these meetings are going on all the time is because it's extremely difficult to get end-of-life glass back. And unless you're extremely determined, it's not going to work. But anyway, it's great these discussions are going on. The other thing that we've learnt over the year is that there's 2 quite distinct markets. There's a domestic market, which is like single-family dwelling, where you've got glass that's quite easy to recover, but it's small quantities and very scattered, very difficult to get hold of. And then we've got construction glass, where we've got a lot of glass in a location, but it's either difficult to get to or it's difficult to reprocess. But there's a lot of it in one location. And we have to actually treat these 2 areas very differently. we won't talk about that too much. What else has happened over the year? Well, we've done trials with hydrogen. We've done trials in France, I think it was May, where we did 100% recycled content, making glass from 100% recycled content using biofuels. So I think we ran for about 3 days just to prove that we could do it. And then the other thing we did earlier this year was we launched a lower carbon glass. Now, when you see my slides, it will say low carbon glass, but I will call it lower carbon glass, and I will explain why, which probably our marketing department won't be very happy, but anyway. But the fact is, it's still really difficult, and that's why we get this kind of reaction is because if you want to take the easy route, you are just going to carry on putting end-of-life glass in the ground or crushing it as road covering. That's what you're going to do. And if we keep doing the same things, then we can't expect different results. So something has to change. Anyway, let's move on because I can see the clock ticking down very fast. So why are we doing it? Really quick recap. I showed this last year, but it's just an important refresher. So if we made 1 ton of glass from virgin materials, we're going to create 500 kgs of CO2 from 1 ton of glass. And 2/3 of that CO2 is made from the gas that we need. Okay, we can use renewables and all that sort of stuff, but you still need gas. Okay, so it's not such good news at the moment. But so 2/3 of the CO2 is that, and the other third is the chemical reaction of mixing the raw materials up. You get 200 kgs of CO2 from the chemical reaction. So introducing end-of-life glass into the recycling process, into the glass production process, means you do 2 things. You save the energy because it's a lower melt point for old glass, and you don't have the CO2 from the chemical reaction. So you can see my example there. So it's an important thing to do. We are still in a situation where the process is linear. So we run through this process. We sit there as the float glass makers. We sell the glass to people who make double glazed units, chop it up, but it's still predominantly linear. What we've become really good at, probably over about the last 10 years, is buying back all the scraps from the glass processors, so all their offcuts. And we call it clean cullet because it really is clean, it's very easy to use, and obviously everybody's now wised up to that. We've been doing it for 12 years, everybody's wised up to it, so there's a massive amount of competition now for this clean cullet because it's the perfect stuff to put back into your float plant. So that is becoming more difficult, so we obviously have to start going to the other end and make some changes, which is very much what we're doing at the moment. Average recycled content across Europe at the moment is about 34%. In the UK, it's 40% because we've got better at this bit, the post-consumer. But across Europe, the average is less than 1% post-consumer. Why is it important? Well, at the moment, and rightly so, there's been a huge focus on operational carbon, and that needs to continue. But what's happening is, as we're making the efficiencies and we're getting the gains from operational carbon, the emphasis is now shifting to look more at embodied carbon. And there's a report that says by 2050, 2/3 of the world's population will be living in cities. So what we're going to see is a massive urbanization and growth. So there's going to be more buildings happening at the same time as they're becoming more efficient. So the balance between operational carbon and embodied carbon is changing, and it will continue to change. So that's why the focus is there. So I think it was August last year, we started this study with Arups. I should look at my notes to remind me when it was. August 2021. Because we wanted to better understand where did glass sit within different facade types. So the Arup guys did a fabulous study, and I would encourage you to download it and have a read of it and just understand some of the stuff that was behind it. But obviously they looked at things like orientation, looked at bay width, geometry, window to wall ratios, glass type, double glazed, triple glazed, frame material, timber, aluminium, spandrel materials, different types of solar shading, and basically there's a whole output of data from that, which is fabulous. It was a challenge, but we had to narrow it down to 16 different facade types. We could have had 100, but we kind of had to do our best to try and cut it down. And Arup were fabulous at helping us do that. So numbers 1 to 6 are unitized. Number 7 to 9 are stick systems. 10 is double skin. 11 is CCF. 12 is precast. 13 to 16 are different iterations of rain screen. And just to say, we've got timber, which is number 9. Yeah, number 9. Number 1 is 100% glazed, unitized curtain wall. As I say, 11 is double skip. This is just embodied carbon, okay? Not operational, it's just embodied. But really interesting. So where does glass sit? So that was really our aim in working with these guys. Where does glass sit? So we're looking at between 26 to 60% of the embodied carbon in a facade is the responsibility of the glass. And what's interesting is these, I'm fairly sure, perhaps Aaron can correct me if I'm wrong, I think this is based on a high recycled content aluminium. If you look at a not so high recycled content, the figures are way higher. Graham's nodding at me, so I'm feeling comfortable now. So this is based on best case scenarios. Obviously, if you're using a high recycled content aluminium, it makes the glass stand out even more, quite obviously. I'm waiting for time. So anyway, let's keep going. So we were already on the route to do this, a lower carbon glass, because I hesitate to call it a low carbon glass because we're still burning an inordinate amount of gas to make it in general terms. So we have this product that we launched this year that I will probably not pronounce very well, but it's there, okay? We have it, we've been making it, we've done 3 campaigns already in making this product, 70% recycled content, I think you've heard these figures before, a bit earlier, you can see 40% reduction on the single glass figures. It gets a bit more sticky when we start talking about double glazed units, but I will get there. It's available on our standard sizes. At the moment, it's available with the triple silver solar control coatings. There are also a few low-E options as well, down here as well. So it's a kind of limited range. And obviously, for any glass manufacturer, we can't make this stuff all the time because we don't have enough end-of-life glass. We can't keep making it. So we're only going to make it in limited quantities, limited amounts. This is where it starts getting interesting. So take some typical double glazed units, not low iron glass, because that goes in the opposite direction in terms of carbon footprint. So you take your low carbon glass and you say, what's the best what we're getting today and what could we get with low carbon glass? I don't know if I was just taking a picture of me or the slide, but I'm going to assume it's me, okay? Just so you're all right with that. Okay, thank you. It helps me with my insecurity, but that's good. So, but when we start talking about the targets that we have to achieve in terms of low carbon glass, the most common glass type I see on a lot of projects today, we're already at 138 kgs of CO2 per square meter before we start. So interesting. Do we have to change the way we do things? Not my answer. So we've already got some projects because we already have the product. So we've got a number of projects where we're using it already. And we've been talking to clients about this for the whole year, but obviously we know it takes a bit of time to wrap through. EPD, we will have an EPD because we've been making it, surprisingly enough. So we've run 3 campaigns already. So you have to obviously run your production a certain amount of times before you can get an official EPD. So you'll have one shortly. We can give you a temporary one in the meantime. Right, I'm rapidly running out of time, but I'm going to just kind of keep going. So I used this slide last time, and this is just an appeal that, how do we change habits? Well, we need to start top down, not bottom up. But at the moment, most of the market is bottom up. It's like, well, we could crush it into road covering or we could put it in landfill. And that's kind of where we start. But we have to have a change of attitude where we set our sights on the highest standard. And if we can't achieve number 1, well, we go to number 2. And if we can't, so it's a top-down mentality, not a bottom-up mentality. But at the moment, we're predominantly a bottom-up mentality. And that's because of these factors: time, cost. Trying to explain to a client, well, I don't know how long it's going to take. We don't know what it's going to cost. Kills it pretty much straight off. So over this year, we've spent a lot of time starting to try and manage risk, starting to help people understand the benefits. We're seeing clients now putting carbon taxes internally within their businesses. So the maths is starting to add up now for these things to happen. The first thing we have to do, though, is this thing here. And obviously, it's really important that as a business, people start to step into this gap to go and see clients and say, we will do an audit on your building. Because I cannot tell you how many buildings I go to see where they say, we'd like to recover the end-of-life glass. I turn up on site and I say, what have you got? And can you guess what they say? Can you guess? They go, well, we don't really know. Well, who made it? Well, we don't really know. What's the coating on the glass? Well, we don't really know. What's that horrible film that somebody's put on the glass that we can't peel off? We don't really know. Can you put it back in? And we're like, no. It doesn't work. So this is a really important step that then the other things can follow from. So it's really important that we look at our building stock and decide what we can do with it. Anyway, let's finish with some good news, because everyone likes a bit of good news, don't they? So 4 or 5 years ago, I could name 2 projects in my lifetime where we recovered end-of-life glass. 2 projects in my lifetime, and as you can see, I'm quite old. So these are now, this is what's happened since. This is all fresh stuff. So we got this job in Greece. We got the head office of Scandinavian Airlines. We got projects in London, projects in Leeds, projects in Paris, more projects in Paris. It's happening. Slowly, small beginnings, but it is happening. A year ago, I showed you this fella. This is a guy called Ian Short, Morley Glass in Leeds. We bought him a new crush machine a year and a half ago. It was semi-automatic because he had a manual one. And a year ago, these were his figures from 4 years. For crushing glass for 4 years, one man, one business had returned 646 tons of cullet. Now, that's amazing in itself, right? We give him a new crush machine. 4 years, he suddenly upped it by 50%. Look at the difference in a year of what he's produced. And what we're seeing is, we're seeing entrepreneurs like Ian starting to rise up, saying, I can do something. Give me a crush machine. I'll give you some glass back. Obviously, we've got to sort these issues about clean cullet and everything else. All right, I'm nearly out of time, so thankfully I won't have to give away any secrets about where we're going. So if you want to buy me a drink afterwards in the pub, I'll tell you everything that we're doing, all right? But other than that, there's just, obviously if I told you, you'd say we'd keep it between the 2 of us, but I don't know if I really believe you. So there are so many things going on where there's investments happening. Obviously, we have to face this whole issue. We have this dirty cullet. And what are we going to do with dirty cullet? Are there things we can do with it? Lots of questions to be answered. But the counter says 6 seconds. So this is just an appeal. We've got to do better. Buzzer's about to go off any second now. We've got to do better. We've got to start with this top-down mentality rather than bottom-up mentality to say, can we do this? And if we can't do it, we step down. There's my ding. Let's make the world a better home. Thank you very much.
Thank you, David. Thank you very much. I don't think we have time for a question. I'm happy to introduce our next speaker, and I think there's some housekeeping that Ahmed will fill you on.
So our next speaker is from a company who's very sensitive to what data is being presented. So please do not record this presentation or take any photographs. They need to also present from their own laptop. So we are doing the change. So please do not take any photos. We worked very hard to get him over here. So don't take any photos. Don't share anything on social media. Adrian Betanzos. I will not mention the company name. You will obviously find out.
They might make things like this.
Yeah, absolutely. Okay. So while we get this set up, just wanted to add on to what David said. So a couple of weeks ago, I get a message early in the morning from Saverio saying that 3rd of November, the train strikes have been announced. I think we were very disappointed. We didn't know what to do. We got calls, emails, asking what is your plan, and you wanted to prepone by a day, postpone by a day. There was no opportunity to push it later. These were frightening days. I think God's been kind, and the train strike, and thanks to Poppy, we've been able to host this event the way we wanted to host it. It was very unfortunate, but this is where this is the world we are living in. It's so scary.
There was a moment of panic 2 weeks ago when we heard about the train strike, that this whole event may have to be either cancelled or shifted or cut back in some way. So as Ahmed said, the last minute cancellation of the train strike due to Poppy was a godsend. I think the message I got back from Ahmed said, God is great. Are we ready to run?
Yeah, we're good.
Okay. So our next speaker is a senior design manager with a very well-known tech company. His name is Adrian Betanzos, and he will talk to us about their process with design and materials.
Sorry about that. It's not me, it's them. So, following Dave is kind of hard because he's very energetic and happy and funny. Hopefully I'm not that funny, or maybe yes. But in the next 20, 25, 30 minutes, I want to talk about what we do as an innovation. Because Oxford knows everything, I just try to Google this, and they gave us this really smart definition of innovation. I'm not going to read it to you. But they also said that, they have similar words. One of them is, revolution, a change or something. Or a new method, a new idea, a new product. Innovation is a nice word that everybody uses, and it's really simple. Can you tell me what this is? A sofa? Couch? Potato? Somebody over there? Come on, just words. A bed? Sure. We're getting smarter. All right, it's a sofa. It was my favorite sofa. It's a green sofa, modernist. I bought it when I was single and I didn't think about having kids, so it was my investment of a sofa. Until my kid arrived and he made it into a racetrack of motocross. That is not a motocross motorcycle, but he believed it was motocross motorcycle, so it is. He also made it into monster truck pit. Luckily, he didn't put any mud on it. He's done many things to the sofa, but not mud. He also made it into an erupting volcano that he had his cars going in and saved the life of the trees. Then he made it into a wrestling arena for lucha libre, because we're Mexicans, so we do lucha libre. So the little one didn't like it that much, but it is that. So he also used it as a platform to jump out and be a hero and fly away, because he loves escape and he likes how it flies when he jumps. So is it a sofa? Or is it a trampoline? Or what is it? It's everything. It can be whatever you want. That's what we're thinking about. So innovation requires imagination. It wants us to be kids again. I was supposed to have my notes here, but I don't have my notes, so hopefully I'll remember everything I was going to say. So I was going to talk to you about the innovations as an owner's perspective. Oh, my notes are here. But then I have to be here. So I work for a small company, a garage company, that we make phones and computers, and I do like my job. So please, as Ahmed said, do not share any images. You want to take a picture of something, do it, keep it for yourself. Don't share it. They're very peculiar about these. It was very difficult for them to let me speak and show some images. Again, I like my job. Got it. You got the point. So it is a team that what we do is we try to figure out how we do the concept of all the future stores. We only work in retail. That's all we do. Find stores, find new places where we can go and sell more phones and make you happy when you walk into it. We have a lot of really good faces here that we just opened a couple of stores here in London. Go and see them. Buy more phones. It's good for my stocks. But it's all about the people. It's all about what we have inside. It's a fun group of people, a lot of creatives. We design, how the store sounds, feels, experience, but we also design the size and the screw and the color of that screw that goes on the side of the doorstop that holds the door open. I mean, we go into every single detail of the store. And then we work with all of our architects and interior and exterior designers so we can deliver what we've done. How we innovate, I wanted to show you some things, obviously, as much as I can, without telling too much about it. Is that a better picture? Good. Because otherwise you like speak. So I want to talk to you about two different projects, one in Macau, one close to you. What is this? Graham? Rain, yeah? Bubble? Water? Come on, be creative. We've been through this before. So, a bubble, yes. And that's what we thought so too. It is a bubble, and it's a nice bubble. And it didn't start like this. It was, we got into the Marina Bay Sands. We started this journey about 7 years ago, well, no, actually 9 years ago. Forget about the COVID years, so 9 years ago. We started this journey trying to get into this beautiful space, a market. We took over one of the pavilions, one of the Christus pavilions, and we said, let's go do this. We presented our design. This is one of the designs that we've been working on for a long time. We built many stores like this, very similar to our campus. We were going through the path of things, how we want to do it. But then it was rejected by the city. We were not allowed to do it because it was not crystal enough. So we tried again. We went to our architect, Lord Foster. You might hear of him. He went to a napkin and did some sketches, and he had some background of different projects that he worked on 40 years ago. And we had a sketch. And it got approved. Voila. Now, this is how it looks today. We went through a lot of iterations of many different design items, something in the top, something in the middle, which just did many things. But at the end, this is how it looks today. It is a 43-meter tunnel or basement tunnel that goes from B2 level of the mall into the store. We walk into a stainless steel mirror-cladded escalator, and then you go into this amazing structure of a glass dome, the first of its kind. We have solar sun shading, which is going surrounding the entire building. We have these concentric circles of shading because we are in the equator, so it's a lot of hot weather. They follow the shape of the glass in both directions, so it's a very difficult thing to do. The whole glass dome is held by 10 little tiny mullions of steel, curved, made in Germany by one of our partners. They are when I say incredible thing, is actually the size of this iPhone. This is the iPhone 14. If you go again, it's bigger. The iPhone 14 is bigger than what we have today. So they were an incredible thing, and so you have only 10 of these. They are cladded with mirror stainless steel double curve metal cladding, also made in Germany. It was very difficult to make to avoid any distortions because it's mirror, and the mirrors show a lot of things, sometimes things you don't want to see. The whole dome is cladded with glass. There's 114 pieces of glass. They are working structurally as well. If any questions about the structure, you can go to EOC and ask them about it. I will not pretend that I'm as smart as them. The glass was one of the biggest challenges. Again, we are in the equator, hot. We wanted to be very transparent and have a dome that you can see through, that you can see inside, and once you're inside, you can see outside with glass. Again, equator, hot, a lot of sun. And then we wanted to have some reflectivity to it, but the city does not allow us to have more than 21% reflectivity on the glass. So you cannot be reflective, you have to be transparent, you have to be crystal, you cannot be too hot, you cannot be too cold. I mean, you have everything against you. And then we want 10-meter piece of curved glass into an IGU with 3 coatings and frites. It was not easy. And then we have a gradual frit coverage from 0 at the beginning, so you can see everything, to 90%. So we started with mock-ups. The first one is on the left, is here in London. We did the first mock-ups of how we wanted the glass to look. It didn't look like we wanted it to look. We got the next set of mock-ups in Germany. We did 3 rows of mock-ups trying to figure out again with the glass, what are the options we have. It didn't work. So thanks to Henk here, he introduced us to this amazing company that do realistic renderings. And so we said, all right, let's try them, because we were going into a loop of not getting what we wanted, but wasting a lot of product, which we didn't want to continue doing that. So this company takes all the numerical data and the spectral data of the coatings and the glass, and then it renders it. It's not from a picture, it's just all from numerical data. So we took configuration of one, of different types of glass, the next configuration. So we just start playing with computers. How it would look with the configuration 456, if it's sunny, if it's cloudy, overcast. Then we start getting more granular about the design. We start putting the real 3D rendering of, not only rendering, but the model of all the furniture, the materials that we have. We have pictures of the entire, let's say the wood, the floors. I mean, we get really granular of the type of light of everything that we had inside, and start playing again with the coatings. And what are the options? This one option, another option. And so we went with options and options and options until we found what we wanted. We made a mock-up. We liked it. It was a 1 to 20. We approved. We reviewed it again in Germany. And then we sent it to Singapore to see how it started getting to look. The Oculus is a circular piece of glass. It's a very simple piece, double curved glass, triple laminated on the top, single laminated on the bottom. Also with coatings, with frit, but it gives us this dramatic array of light that goes through the entire store throughout the day. The glass, curved, cold bent, made in Germany. There's only 2 people that can do this type of things. One of them in Germany, one in China, made in Germany. This is how you lift it, how you've seen before. This is how you installed it. You've seen it before, nothing new about it. And more pretty pictures of the city. Now, the entire steel and glass weighs about 16 double-decker buses. Now, why is this important? It's not important. It's just somebody made a calculation and gave us the number. And I was yesterday walking through Regent Street and took a picture. And I wanted to show you a picture of Regent Street because it's in front of the Apple Store and it's pretty. This is how the drawings, and this is how it ended up looking. So get outside of the comfort zone, do things that you can, work together with people. This is a second project I want to talk to you about. It's in Macau. I have 16 minutes, so I'm on time. Macau is a crazy place, fun, the Vegas of Asia. I have not been there. I've just seen pictures because COVID happened. We opened in 2018, even though before COVID, but this is a stone laminated glass. It looks like simple, something that people have done before. You put stone, glass, and voila, you have a project. But actually, what we wanted to do is, with this stone laminated glass, we wanted to get a very tranquil space of the store, so it allows people to be in a more comfort space than in the strip with all the lights. We were looking for a lot of translucent, transparent materials. Well, not transparent, just translucent. But we could find nothing as pretty as what stone can do for you. So we wanted to have still the connection to the outside world, to the light, how things happen from the back, but yet still want to protect from that for the people and have, again, a very comfortable space. We wanted it to be a 15-meter piece of glass. Why not? But we couldn't, so we compromised. We did only 9 meters by 3 meters pieces of glass. And the bottom one is 6 meters by 3. The upper part of the bottom it has a stone. The inside doesn't have a stone. It's one single piece of glass. This is how you feel, how you experience the store inside. Again, you can see the outdoors. We were told many times that this was impossible to be done, that you could not do it, that it was difficult, that stone doesn't work really well with glass. The maximum you can do is 1 by 2 meters, that you have to protect the edges, that or you have to resist the stone, or that you cannot, there was lots and lots of excuses that this could not be done. But we did it. We were able to do that. And I was telling you about this. We have, this one piece of glass has, 2 pieces of material. Oh, and important thing, the corners, if you haven't seen in all the pictures, they are our structure. And again, hidden by a mirror-cladded stainless steel piece. So you have to take risks. We are an owner, and Dave said before, it's from the top down. Unfortunately, now we're in the top. We have to try to see what we can do. We need help from everybody. But we take risks, and but they have to be calculated. We do a lot of research and a lot of work to make sure that the risks that we take are taken well. We make mistakes. We have made a lot of mistakes. But we learn from them and we move on and we continue to try to innovate and put new things on the earth. We did, again, a lot of research. We worked with artists, scientists, factories, of course, our designers and at Foster's and our engineers at EOC, and the facade contractor and the builders. And you can see the picture down below. It's a mix of many backgrounds of people in just one little building in Switzerland, made by Swiss, to get to where we were. These were the last 5 mock-ups pieces that we wanted to do, because we've done a lot of things before this. This is the last day. We presented them. We were ready to go, and we turned the lights on, and we didn't like it. It was supposed to be the last one, so just to make it more difficult, it's 4 layers of glass with a stone laminated in the back. It was starting to look too green. So, and it didn't matter how many, what type of stones, because we used a lot of different types of stones. So we decided to add a second layer of stone. Why not? Make it more difficult for us. And so we did. We put a second layer of stone. And we did a lot of testing, everything that we could think of, and with all our consultants. And remember I told you we are a structural glass, now 5 layers of glass, 2 layers of stone. Each stone is about 3 meters by 1.5, all laminated within one single piece of glass. But we are in Macau. It's a typhoon path. So, the regular is 130 kilometers per hour wind of a typhoon. And the one before we started building this store in Macau, it had wind gusts of 215 kilometers per hour. So a lot of wind. And so we needed to make sure that it was safe, foremost. So far it is. So you need to trust. We worked with a lot of people. I've seen faces here before that we didn't know each other. We worked with a lot of people before that we knew, and sometimes you feel safe with them. But we need to start trusting other people, and we did. And we worked with different vendors, now partners, that we didn't know each other. We put this team together, we worked together, and we made it happen. So we need to make sure that you have to trust the people. I'm going to just let you, the sound, please. The stone was selected at quarry and then sent to Italy. We slabbed the stone, Then it was sent to Germany, where it was split in half. We have very small stone, and then polished down to a 1 millimeter thin stone. Every single stone was sourced and checked and reviewed and cataloged and archived, and that's a stone. Then from Germany it was sent to Switzerland, laminated, 2 layers of lamination. Swiss precision. Every single piece of glass, once it was laminated, was also reviewed, inspected, making sure there was no errors, mistakes, quality control. And not only for this project, for every project we do, we checked 100% of our material before it ships to factories. And then we work with our partners, local partners, to be able to install this. And on the way. And it's a very dramatic ending of the music. And that's it, because it takes forever. So it's just, this is the end of it. It's good. So let's find a way. Let's do work together. Let's innovate. Teamwork makes it much better than by ourselves. There was one very important thing, actually a few very important things that were mentioned by Dave in the previous chat. And this is one thing that I wanted to ask you about. So I'm not here only to show you some nice pictures and some pretty videos with dramatic music. I'm also here to ask you for help. Can you tell me where the recycles companies are? Yes, glass is infinitively recyclable. If I have a piece of glass in my hands and I break it, can I send it somewhere? Sure, you can. But unless you're a glass factory that gets the clean collets to the factories, it's very impossible for the 1,000 people of us or 100 people of us, 800, how many we are, to send a piece of glass to be recycled and be back to the Saint-Gobain, Guardian, Vitro, whomever. Difficult. Or even to a glass bottle company. So like here's one of them, is here in London. Just found out about them yesterday. They do glass recycling and glass recollection. But why can't we just get a database with all the different types of recycler companies that are in the world? Doesn't exist. So so this is my ask. One of them is, we're working with a couple of friends, because now they're friends, consultants, and people that we want to work with, because we need to make it easier for everybody to do more recycling. Yes, sure, we can recycle, but you know how difficult it is to do? And it shouldn't be that difficult. So imagine you were here in the UK and you find where they are, you have your project, something breaks, send it there, and off you go. At least you do it easily. Or what if, I took a picture outside last night before they noticed. But you have AGC, Vitro, any company of the world. How many of you have received a glass box with samples? 1, 2, only 3 people? And I've received hundreds of these before. And then once you select one for your project, what happens to the other 4? Right? Where does it go? Who knows? To the ether. It doesn't. It goes to dump. But it could be easily sent back to the vendor that gave it to us. What if they put a return label like Netflix used to do 20 years ago? They didn't exist 20 years ago, but anyway. They have a return label, send it back, I don't need it anymore. Sure, there's carbon intensive in sending back for the thing, but that's better than dump. Or what if now you know where the recycle company is, and then the same company gives you that label, and they don't use it anymore, you send it to that recycling company. Or to send it back to the representative in city, and then cleans it back, and then it's recycled and reused for somebody else, because somebody else is going to use a gold piece of glass. Not us, but somebody else will do. So, can you help me with that? We're interested in many, many things, and from this group, a lot of things to do with the facade and materials. So, thank you. Let's stay in touch.
Thank you so much, Adrian. Really fascinating stuff. And I know the process of design and design team building and supply chain is completely different to you, to most of us. It's a bit like watching fantasy football for us. But what you mentioned applies to us as well, in that you have to bring the right skills to the table at the right time. And you have to know what you want. And it's really impressive to see the number of trials and optioneering that you're doing. We do some of that in our normal business, but perhaps not enough sometimes.
There's always a better way to do things. You know? We can always improve it's one step at a time. I mean, we all recycle at home the beer can or the soda can or the glass bottles. We do put them in the bin, but again, if you break a piece of your window, it goes to the dumpster. Because really, there's no way to do it. So, but there is a way to do it, and let's just find it. And the projects, well, those are different things.
Great. Thank you so much. Thank
you.
you. Our next speaker is Gideon Maasland. Have I said it correct? Yeah. So Gideon is from MVRDV, and he's going to talk to us about future cities and how we might build in the years to come.
Thank you. Indeed, I'm Gideon, and this is where the complicated name is coming from, MVRDV. And the last speaker was talking about taking risks, and I could not imagine come here without being able to talk about Marble Arch, one of our most disastrous projects ever. What to say? No, it came. There was a history. It came from this. We had a stair, and we see that in an intense city there are a lot of spaces completely not used. And we see that these roofs, they have a very big potential. In Rotterdam last year, we did this, the rooftop days, where you could actually go there. You could have a stair to go up, and it literally gave you like a new perspective on the city. Some were programmed, just out of that. And from that, also in Seoul, we did such a thing, program these kind of things. And they are connected to what we feel, we call it the green dream that we have. And we also had it here. We were approached by Westminster City Council, like, hey, COVID is hopefully ending. Can you help to push a little bit? And we made this render. I'm sure that you saw it. This was the idea. Let's get Hyde Park. Let's pull it up. Let's make a viewpoint that you can overlook Oxford Street, overlook Hyde Park itself. And this was the result. That was completely unsuccessful. We're walking up. The part going up went okay. The climate was disaster in the first couple of weeks. It was first too dry, and then it was too warm, and then it was incredibly wet. But the result is this, and we're very much embarrassed. yet, no, yeah, you see this. What to say about this? No, this is me. My colleague took a picture. No, at a certain point, the black foil is done. No, what do? Yeah, I have some white stuff. Let me finish it off. No, there was even here. This was the most. There was simply water running out of the mount. It was a disaster. We're very much embarrassed. Like I said, we still have a green dream. We will do it better next time. But yeah, since we were here, I thought, yeah, we have to start talking about it. What about the future cities? I will come to Valley. This is a project, but it stands in a big history of what we are doing. No, the previous speaker also said, like, yeah, there's a big urbanization coming. This slide doesn't work. There we go. If we would look at our footprint, right? If we would all live like Americans, we would need 5 Earth, and this is quite problematic. The good thing is if we are more dense, then we have a much bigger chance of getting more sustainable. Because the urban sprawl, you know, this is a picture from the Netherlands where we try to fill up almost the whole green area with houses. Yet if we look at the densification, we get this image. This is not photoshopped, no, this is real, this is Hong Kong. And we get very much scared by that. And if we talk about what is your dream, what do you want? No, you get this pitched roof with a chimney. Still people draw a chimney. Front door, no window, car, tree, dog, these kind of things. And can we do that? If you want to densify, you know, can we, like we did, for example, in Hanover, can you stack different kinds of situations? And I took the porosity study we did at the Technical University in Delft, where we did a prototype of a tower. And a tower always looks like this, also here in London, right? And now all of a sudden I know where you want to live, right? Well, actually there are 2. You either live inside because you want to see the view, or you live on top because you like a big terrace. But nobody wants to live at the bottom left, right? And if there are so many pieces, so many possibilities where you can put the Lego, why do we always choose this? Why is there no creativity? No? So we were talking with the students and we developed various different types of concepts of making things more porous, more open, more accessible. And of course, depending on your location and on your budget, no, you can range from step 1, which is nothing, to all the way to step 12, right? And in step 12, you get this. Can you imagine a tower that has such a big pregnant belly? You know, wouldn't that be amazing? No, and they form some kind of army of possibilities. And no, you see polite towers making a bow. Here you see this pregnant tower. But can you imagine the difference when you live here in such a place? No, all of a sudden you know your neighbors again, right? Because currently we are in this elevator. And we go up and it kicks us out somewhere and then we're done. But no, yeah, when I was young, you always had this awkward moment. Do I say hi or not, right? Currently, we don't care that much anymore. We stand like this, but we don't even know our neighbors. They lay dead in their apartment for 3 weeks and we never knew. No, and we thought like, hey, the first part was very intuitive, and the second part, can we do it a bit more smart? No, can we, with all kinds of technology, with scripting and these kind of things, can we then make sliders that we say, like, for example, here, if you want to push the stairs all the way to the max, no? Like a stacked San Gimignano, but then super high. No, can you imagine this kind of place where you live? And again, it's about community. It's about being open and not this super closed off space that we see so often. And there are different possibilities, and of course, it depends a bit on the client. No, perhaps you have a client that says, like, yeah, until here, please. No, you get a very specific part where you can do architecture. And then people say, like, yeah, super nice, but the reality, of course, is different, right? But the technology is moving so fast. Just 5 minutes ago, I saw 1 millimeter thick natural stone. Well, I've never seen that before. And you can calculate, and of course, no, if this is the standard tower, then this one is more complicated. No, that is obvious, and this one even more. But if you combine certain technologies, no, if you wonder why does a bird fly, No, there are many reasons, but one of them is because it's extremely light. It has only tissue in the bone there where it's really needed. And if you think that, and you project that on buildings, no, and you combine that with technologies of printing, no, we can print steel nowadays, we can print concrete. Can you make slabs in which have concrete, no, less carbon concrete, of course, but which have concrete that only there at the positions where they really need it, right? And it gives also something. It gives the complete weird image that we've never seen before. Like here they tested at the ETH. And then again, the reality, right? This is Madrid, where we try to lift the courtyard block and make this space, make this openness, this community, make this street. No, this is at the top. No, you have this street, this community. There are barbecues in this space. Huh? No, that is not. Yeah, it works like that. This is the market hall in our hometown in Rotterdam, where the client said, like, yeah, can you make a market hall and then 2 slabs on top for the housing, please? And we said, yeah, that's a bit boring, right? And we flipped it. And then the structural engineer said, yeah, it will fall apart. And we said, like, let's do it as the Romans. Let's make an arch. And then the elevator guy said, the elevator doesn't do this. Okay, so here you have it. That's why we have the shape. And it's like a colorful explosion of food. And you make this space simply by the apartments that you needed anyway. And this is an example in Rotterdam as well, where we try to see if we can make a bit more differentiation. No, we talk a lot about inclusivity. If I look here I see so many different types of people, and every client that comes to me says, like, I want 600 of the same apartments, please. But for who? How can you find 600 people that are the same? No, shouldn't it be a little bit more different, a bit more special? Then we go to Valley. Valley is built in the central business district in Amsterdam. And it's at a pivoting point of work and living. No, after 10 years building only office towers, they figured out that it's a bit scary in the weekend and the evenings because there's nobody there. And so they wanted to add housing, and yeah, we were one of them. We studied a hell of a lot. I don't have time to go through all of them, so I will only bring you the last version that was built. This was the building envelope that we got, and like many times we get a project, like a program of a plinth and housing towers on top. And we said, like, yeah, let's at least make it like a bit contextual, like so this glass, shiny, mirroring facade that we see so often. The whole hallway is filled with them. Let's do that around, right, from the central business districts. But then, for the apartments, let's start to carve out, let's cut this human scale back in, right? If you want to have these apartments, if you want to be nice and friendly, no, let's cut it. And let's cut it all the way down. Let's make this publicly accessible valley, and let's do it. And we come to the facade because many people are interested, like, hey, how on earth did you do that? We of course started a bit more straight. We pushed a little bit, we pulled a little bit, and we added at certain points, we added what we call specials. The client allowed us financially to make 12 specials. In the end, we got 11 because the structural engineer said, like, yeah, this one is normal. And we do that because we want to create diversity and quality. We can steer the privacy with these things. We can orient to the sun or away from the sun. No, we are close to the ring road, so a lot of sound. So sometimes you need to push this shoulder a bit in so that there's a window you can open at night that doesn't have all of this sound pollution. And of course, we want to add the green, this green dream that we have for the city. No, can we make that? And of course, on the biggest special, you want to have a big tree there. And we had Piet Oudolf, the famous landscape architect, who made a fantastic concept with the different plants. And our client, Edge, they hang their buildings full of data. And what we have been saying as architects already for many, many years, that green really helps. Now the data from their sensors is proving that we're right? And you can say, like, okay, this is just 1 day of sick leave, so 1 day a year that I'm not sick. Well, who cares? Well, if you do the finance, you know, then you care. And we worked with the parametric model because the competition was a bit intuitive. And then the client said, but how do I know that we have the right one? right? If it's a bit like this or like that, or how do we do that? And we made these scripts, and we made different options and sliders depending on the size of the apartment, the size of the terrace, many apartments, these kind of things. And at a certain point, the client made the final decision on the sliders, and then we were there. And nowadays you can see with the sun load, the solar load, not too much sun, terrace check, daylight check, all these kind of things that are important nowadays. And people wonder, how on earth did you get this built? And the answer is quite simple. We had a very good structural engineer. So these are all the different plans. And what you see is actually quite simple. It's the base technology that we do in the Netherlands when we do housing. You have a concrete core and you have concrete walls that are going from there. It's like the hashtag. And simply the wall is slightly longer or slightly shorter, and that's it. That's the only thing that counts. Okay, there's a guy cutting a bit the floor edge, but for the rest, it's a fairly simple thing. It looks wild, yet if you see this, you see the lines, you see the walls. Even better on this one. You see them completely going from up to down. Fairly simple. And these are the specials that we had. They are sometimes additions to the structure. And then it also made sense, this picture I took various months before. And I had no idea what it was, but these are the connecting things to go into concrete. After winning the competition, it didn't take long, because when we ended up at failedarchitecture.com, and people, there was a guy writing an essay about us. He won the essay award that year for this article. And he said, this is exactly what we don't need in the world, right? Architects that make renders that promise everything, and in the end it will look like nothing. No, architectural porn, he called it. Yeah, so from the first project, like let's say we are used to getting bad publicity once in a while. No, the marble arch still hurts. But this was different, and this is the render with which we won the competition. No, so based on this, he wrote his essay. This is the Revit model that we had for the building permit and the matching render to go with it. And if you look very closely, you see that a couple of things have changed here and there, but I think the overall ambition and the quality are still there. And we took that all the way down to the delivery. No, we could not have made this without the 3D programs that we work with. And in the end, also the contractor came to us and said, I really have no idea how to do the paneling on the facade. No, it's going to take an age before we draw that. And we started first going from Revit to Rhino, and in Rhino we can do all of this kind of scripting, and we made this script that can generate patterns for us. No, so you see a little bit here and there that we try to get these kind of things, and this is not beautiful yet, so it takes a couple of sessions before it's okay. And then, of course, back to Revit, and in the end, these kind of things are then being put to the machines of the producing companies. And that these kind of technologies, they help us to build something which is, at least looks super complicated. And we work with scale models where we test certain patterns, where we test the green. No, and this is indeed this jacket floor edge getting somewhere, and then it started to be built, and it's finished. It's there, and you see this part, this rock, this different thing in this area with all of these office towers. No, and we still get a lot of complaints. Apparently, if you sit in the front, you get a lot of complaints. People are complaining about the green, that the green is not so green yet. That will come. It is every day. It's getting better. Every picture makes a difference already. It is deliberate. We need to plant small green in order to grow, and that simply takes time. And of course, we have what is a valley without some nice water? If you do a hike through the mountains, so we have a glass roof which has water on top, and that radiates down to the grotto, which is on at +1. And that is like the centerpiece where everything connects to. It's a nice place for the kids, to play outside, because if you want to densify and you open the door and a truck runs over your kid, then it's not so fun anymore. But are there places where you can actually be normal? These kind of things. Different types of patterns, different things in the night. Like one of the previous speakers said, they were super worried that there would be drug addicts, and well, you know the story about drugs in Amsterdam. So they were worried that would be here. Fortunately, it's not. And you see this space, you see this I don't know, biotope, this area where we see that we can make it more sustainable with densification and still have it open and green and in a human scale. And in the end, we feel that is absolutely necessary, that these buildings, they become a bit nicer to each other, And then, they might even kiss each other like this. A different dream that we have, completely different topic, different dream, is about transparency. If we densify these cities and everything blocks everything, then what? Can we imagine a city that is transparent and is not blocking? So if you need to build in front of the St. Paul's, it's fine? That's difficult, right? Yeah. So we started small in an office to say like, hey, can you make it more transparent? Can you see actually where all the piping is going and all that stuff? No, we start to make glass buildings that you can see through, that you can actually walk through also. Glass bridges that give you a different view on the nature. Glass kitchen, no? Yeah, and somebody comes to you and sees what you have. And what did you buy? Did you buy the biological stuff? No, the pre-package. Oh, with a lot of plastic around. Oh, yeah. Oh, allora, there we go. Crystal houses. This was. It used to be a quite regular street, but at a certain point, the big brands that we saw also before they entered this street. And our client has two of these parts, and it's in Amsterdam in the monumental area. And he had a different architect, and they made this plan. And then they went to the beauty commission, and they said, no, that's not a good idea. So they could make another plan. Beauty commission again said no. So they made a third plan. Guess what? No, also no. Then the client got a bit upset. They made a fourth plan, and then the beauty commission said like, yeah, whatever, just go. Fortunately, the client was already done, and he came to us, and he said like, hey, can you help us? And we said like, well, yeah, if this is what is there now, and this is what you can build, the volume is 1 floor higher, why don't we stretch what used to be there? Well, we stretch it, then how can any beauty commission be against that? So we combine that with our idea of having a transparent world. So can we make this park that is behind it, can we see that? Can we do something like this? And then we had to go back to the beauty commission. And the beauty commission said, well, it looks like this now. And we expected you to come with this. Yet you came with this. And that's for us completely not acceptable. It's a monumental area, and it's made out of brick, and it needs to be brick. And we say, yeah, it's glass brick. They say, no, it needs to be brick. Okay, so then we had a whole back and forth discussion about how much brick is in this part. No, what is the percentage of brick that is there, and how much glass is there, and difficult. Also complicated. Yeah, you need to do something. Trying to figure out something, right? And in the end, we compromised on this. So we start with glass, and then we vaporize into concrete, out of brick, something. Which was good, because by that time, the contractor already started, the building was gone, and there was one problem. We had no idea how to build it. So then the research started. So if you wanted glass, that's nice. How to do that? So plexi, a bit sensitive. You get scratches. Resin. not super transparent. This was a very interesting test to pour glass over bricks. But yeah, you get seams. And that was a bit complicated because yeah, the brick doesn't have seams normally. Then we ran into this somewhere and we ordered it online. And yeah, you can get it in many colors. But you can also get something that starts to look transparent. And it's coming from Poesia, an Italian producer. And mainly they do this. It's meant that you buy one or two as an interior like thing that you put somewhere nice. And we had to glue them together. That was challenging. So we started with this. We had a bit more transparent glue. The client. This is our client. Oh, no. And then I think of the previous speaker. He said, like, yeah, hang in there. No, keep pushing, just continue. And we continued. And together with the university in Delft, we found some kind of glue that hardens under UV light. And that actually has a structural working as well, right? And we went to the Poesia, and it's really old-fashioned still. No, they pour the glass in there, and they cut exactly at the right moment. And they sand it, and everything is measured. No, it's a 0.1 millimeter clearance tolerance, the difference. But still, the plus 0.1 goes in a different layer than the minus. We still have some air gaps, right, with to fill, and yeah, somebody came up with this mold to do exactly the right amount of glue, exactly on the right spot, so that it's whole covered. And not too much. No? And then finally we arrive here at this thing that also structurally really works. And it ends up to be, yeah, transparent, which was good because the building was done. No, they were simply waiting for us. No, come on, there we go. So then they went to the assembly. It was like in a sheltered place, and they literally started to lay the bricks one by one. Certain things were prefabricated with beautiful details like they had before and put together. And here is this part where one blends into the other. Of course, also the frameworks are out of glass, right? If you make glass facade, then yeah, then what you do? No, you get this. You get this, and then it was done. And we promised this. And it turned out to be this, and this is very nice. Chanel, everybody thinks we made it for Chanel. This was not the case. We were lucky because it went viral because of Chanel. And so we called Chanel and said, hey, shall we do business? No. Okay, sorry. Oh, 1 month later, they called us. Said, hey, shall we do business? Then they figured out that it went completely viral, but nice story. And you see here this part where inside and outside are really, merging, so to say. No, it's not blocking anymore, but it's becoming transparent. No, is this from the inside or from the outside? Which one is it? Yeah. And at night, when the light comes out, it turns into some kind of lantern and it radiates the streets. Yeah, and then you get the users. That's what we build for, right? Is it plastic? No, it's glass. It's real glass. No, and everybody comes there. And of course, everybody's testing and seeing, like, what is that? One of our founding partners, bike. We bike a lot in Amsterdam, of course. So yeah, everybody comes there, and that's the thing. The two projects I've shown have been designed already way before. No, so Valley is from 15, the design, and this one is even before that. And it is very complicated to talk about these projects in the current day society, because if you look at the carbon, if you look at the sustainability, they are not the best of the best we have now, right? Yet in 2015, when we designed Valley, it was by far top of everything there ever was. And now you see that it's changing really fast, right? So the next valley, and we are working on a couple, we will not do in that much concrete anymore. No? And the glass, and that's why I brought this one, we would look at the glass differently, because indeed, can you recycle the glass? Well, yeah, that's what we tried in the Bulgari. You know, can you have a couple these bottles that they have? No, can you break them? Can you do something with that? Like, can you melt them, but not to the point where everything becomes super homogeneous, right? Can you make it work? Their product, can they get it back and then? Yeah, they can. And you get this kind of glass with that. No? And that indeed, just like the Apple Store before, it is translucent and it radiates also in the evening, right? And you get this feeling of a different material while actually it's an old material. And these kind of things, no, with glass, they are getting more and more important. Also with one of the previous speakers, right? Can we find a method of having glass which consumes less energy? Something that I learned recently: we're running out of sand. Well, for me, it was completely weird. What do you mean we're running out of sand? Yeah, no, because the glass is made of a very specific river sand. And that's actually what ecologically is extremely important. No, we're digging and digging and digging and killing the whole ecology with that. But these kind of things are important. And then we talk about about reuse and about sustainability. But we have so many tons of glass that are not usable at this moment. And why? No, because it's laminated. It has this foil that we don't know what to do with, or we don't know what type of glass it is, and we cannot do that. So we're dreaming, and it is coming. Is there a bio-based type of glass? We think it is, and it's coming. Thank you.
Thank you very much, Gideon. That was really fascinating stuff. Absolutely fascinating stuff. And delivered beautifully, if I may say so, as well. You mentioned somebody wrote architectural porn about one of your projects. How was that received in your office? Was that seen as a criticism, or was it seen as a compliment?
No, that was seen as criticism.
It was seen as criticism.
Yeah. It was also meant as criticism. Okay. Because he said, like, yeah, well, in the end, it will be a straight tower, perhaps with one jump. And of course, it will not be green, right? Yeah. So it will be cuts and the budget cuts and everything. And you will never make this. Yeah. And yeah, we took it as something like, yeah, we're going to prove you wrong. And we're really, really going to build exactly as we promised. Yeah. Great stuff. I think, thank you very much, Gideon. Thank you. The hall will now be turned into 3 separate halls while we have lunch. So A over there, B in the middle, you can't go wrong with B, and C over there. And if we can have the speakers from the last session come back to stage, please, and Sean will put some germs onto you in a minute.
Right. Lunch is there at the Harvest Suite, so you can use these exits. Lunch is being served at the Harvest Suite. As Stephen said, the hall is going to split into 3 parts: track A, track B, track C. Please pick your tracks beforehand. You can switch between tracks if there is space and it's not closed. Once the event gets over, we have the Society of Facade Engineering Awards. Those who came in late, as I mentioned in the morning, we have a changing room, level 4, Nelson Suite. Okay, thank you. Shelja. Hello. Shelja, I need you here for the mementos. Yeah. Someone else, can we help me with the mementos? Can I have John Bushell? Can I have Gideon? Can I have David Entwistle? Adrian on stage, please?
Good afternoon, everyone. I'm Claire Tribe from McLaren. I am Pre-Construction Director of Façades. And firstly, I'd like to thank Ahmed and his team for putting this on together. Secondly, I'd like to start with a little observation. For those of you that were here last year, I spoke on a panel about women in the industry, and I must say this year it is a great delight to stand around and see so many women and a marked increase in our attendance in representing this industry. So thank you to everyone in the room for making that happen. And I would like to just start with a little bit of housekeeping. If any of the presenters could stay behind after for a small photo opportunity. And if you are speaking next, could you please make your way to the rear to be mic'd up for the next session if you are not already. So I would like to introduce today Amanda Whittington, partner, and Alina White, associate at Field & Clegg Bradley Studios, who are going to be talking to us today about beauty and material choice and taking us through the architectural principles of Battersea Exchange, Temple Square, and 3 Chamberlain Square. So I'll hand you over.
Hello, everybody. Thank you very much for having us here from to Zak Façades. So we're just going to talk for 20 minutes, hopefully, through on some projects that we've been working on. Oh, sorry, I'm Amanda Whittington. I'm partner at Field & Clegg Bradley Studios. This is my colleague, Alina White. She's an associate. We've worked together for a long time on a number of buildings and would like to talk through some of that work that we've done to date. Firstly, obviously, as architects, as alongside the sort of technical aspect of facades, there's many elements that we're looking for in terms of creating beautiful buildings. And obviously, aesthetics is the top of that, because every building we do, we want to make the best building we can. But there's obviously suitability to context, there's well-being, future-proof robustness, sustainability, what that build-up is, what that U-value provides, just the general detailing of it, natural ventilation, reducing overheating. There's all sorts of elements that put in to go together to make sure that when we're designing our facades, that not only are they going to be beautiful buildings, but they're going to be functioning and working buildings as well. What we Alina and I have spent a lot of time over the years is looking at in terms of the materiality that we're using in our buildings, and we're both sort of favouring towards more natural materials such as a terracotta, ceramic, and bricks. And I think some of the buildings we're going to focus on today are buildings that we've used those materials on and we think have been really successful. I'm not going to, because I'm probably out technologied by most people in this room, I'm not going to find, but in terms of, obviously there's many different ways we can build a robust rain screen with unitized rain screen, precast, and elements of sunshade. One of my passions, I guess, is bricks. And what I love about the brick is the element that it's a very sustainable and reusable thing, but there's so much you can do to it, and you can make it work really hard to get some really exciting finishes and facades by setting back, pushing forward, patternizing different bonds. And I think, it's a really traditional material that can be used in so many ways now, that not just traditional, being pushed to its limits as slips, as precast. And I think it's really exciting that there's sort of almost endless possibilities that you can do with the brick. And at the end of it, you can take it down and you can use it again. And so there's a process in terms of it being a really interesting project to work with. What I'd just like to focus on is a project we just recently completed in Leeds, which is a speculative office block in the Temple Quarter of Leeds. And this building is it's an office block set within a conservation area within Leeds that's a lot of links back to the textiles industry and manufacture. And what we wanted to do was make sure that the building that we did provided a really flexible, modern, grade A workspace, but also really spoke to the vernacular and spoke to the area that it was being built in, so it fitted in and became part of that area without, so we wanted to sort of avoid going for that glass box and really take the use of the brick and make it something that was a real nod to what was there, but also making it being able to stand alone. In terms of the principles of what's around there, we've obviously taken the element that you have the top, middle, and the bottom. On the top, in order to create mass, but not to make the building appear too dominant. We sort of went for a metal material on what we call the crown, which was set back. And then in the middle, we have an element of repeating facade, and on the ground floor, we have the arches and the large main entrance to create the active frontages and to bring people to the space with the idea that, you know, this is part of a wider master plan, so people will be coming and going. So it's to really bring people in, but to give a real sense of place. One of the key features of the building is the brick reveals. And in order to, there's an element of arches on the ground floor and the recess and the curvature of the nose. So what we wanted to do, where you come down Water Lane in Leeds, this is the first building that you see within part of the master plan. So it's quite a small building for an office building. And we wanted to make sure that it was really landmark in terms of doing that. So we've got this nose, which has a triple and double setback in the brick reveals, and then the curved glass in terms of that. Now, looking at that, initially when we were designing it, we was looking at it as a handset element. And the more we looked at it, in terms of having, what we were looking for was a really crisp, smart, and it had to be very tight in terms of that brickwork. So we went around in terms of order to get the curvatures and the setbacks, it reverted to a precast system, which I think has worked really, really well in terms of how, because there was a lot of way that we could be really, really keep a close eye on the quality, keep a close eye on how we worked with movement joints, how we did movement through that, and really sort of get a really strict line through in terms of that facade. And then, as you can see from these pictures, it's like in terms of how you've got that heavy set brick, you've got that linear and repetitive element that you expect within an office block, but obviously it's got that brick, it's got that industrial element to it, which gives it that sense. And then the profiled aluminium on the top just lightens those extra 2 stories slightly to help it fit in with its context and the scale of the surrounding buildings. So going back in terms of the precast, this is just one of my favourite photos, because I liked it in terms of walking on and going and seeing this building before it got put together. And I think one of the really exciting things, you know, in terms of going for that off-site construction, I think is a really positive aspect. And while there's always that argument that you're not using brick to its full, truly, I think maybe we've moved beyond that, and actually using brick in precast, I think, is a really quick and efficient way of getting buildings built. I think really having control and quality of that brickwork, and being able to get it on site, get it through, get the efflorescence out before it gets on site, and so that it all comes together really quickly to sort of create something really good. So just quickly on this is a couple of other projects where we've again used brick and sort of pushed it to its limits in terms of, this is a housing project we did a few years back in Vauxhall in London. And so this was quite a big sort of 4 separate block unit where we used different colours of brick and different textures of brick to create what's essentially one apartment block, but to give each apartment block its sense of self, so that it didn't feel like too larger unit, and everyone had a sense of which block they were in. And also in terms of sort of coming away from the going in, this one sort of has a top, middle and bottom, and the top there is because this is coming up within a huge master plan where everything's really tall, we wanted to make the tops the key element of this, because actually this is more a building that's seen from the railway and from afar and stuff. And so we had a lot of fun in terms of pushing physics for that in order to sort of have the brickwork cantilevering out and cantilevering up. And then just as a sort of slightly different thing in terms of University of Roehampton Library, which is a much smaller scale building, and again, using brick in a much more traditional form, but also doubling it up with elements of pressed precast to give something that's actually was, within the budget constraints of an educational building, but something that's really user-friendly, responds to what is quite a suburban context around there, and then just using that to really create what's been a really successful building. And then again, just Draper's Academy is a school where I think this is really interesting in terms of having lecture halls and games areas that you can use brick to really wake up what would be quite a dull facade otherwise. So when you've got unactivated facades, there's loads you can do in terms of pushing forward, and there was loads of fun had with working out how we were going to sort of make this facade a little less
you were going to animate the blank elevation by lapping these bricks out.
And I think that's worked really well in terms of how we do that. Okay, I'll pass over to Alina.
Another material that we like a lot is terracotta, coming out of the earth, and it's similar to brick. It's obviously come from the earth, gets fired, but the results and the visual appearance can be quite different and quite varied depending on the glaze, the techniques that have taken place in order to get the product. And I've got a couple of examples here of some buildings where we've had some fun. This is Warwick University, where we used a couple of different profiles, rotated them to get some variation. And then for the windows, what I particularly like is they're just kind of punched straight through it. I think that's a really nice example of using terracotta. And this is St Albans Place, also in Leeds. Here, we've used the terracotta. Again, we didn't use that many different profiles, but we've used 2 different glazes to create the different sections of the building. And it's a traditional rain screen way of hanging the terracotta, which has enabled us to weave through these profiles to get quite a varied elevation.
And this is Circle Square in Manchester, which is the former BBC site where there's been a master plan in terms of some it's a mixed-use master plan, residential, speculative offices, hotels, and car park, and a pavilion space in the middle. And again, this is again a nod to the language of industrial Manchester in terms of that, and having that. The idea is the colour terracotta, and the residential has the white on the inside because that was the inside colour, and then the brighter reds and the greens on the outside. And this is a unitised system, which again helped to sort of work out how to get those cruciforms and those matchings, and again being able to pull together the facade.
So the next example I have, this is 3 Chamberlain Square. This project is not yet started on site, and we're working in a very historical context here, next to the town hall, and we took inspiration from the base, middle, and top to form the facade language of our building. And where predominantly the language we're talking about is terracotta, but we didn't want floor-to-ceiling glazing because we wanted to reduce the area of glazing and reduce the solar gain and improve the U value of the wall. So we've used aluminium parts in between to help reduce the overall glazing area. At the base of the building here, we went through quite a discussion, and the design progressed. We started off with these florid forms, which are really sort of beautiful twisted forms, and we didn't feel that terracotta was going to work so well in that location. We thought about concrete, but actually, with discussions with the contractor, we've come to the conclusion that an aluminium facade will help create these shapes better. And they made some samples as well, which should be on the next slide. Yes, so we're experimenting and trying to work out the exact form of these parts. For the main body of the building, this is where the expression of the building is very terracotta. A lot of the views that you get of the building are quite oblique, so these projecting fins in terracotta should read very, very prominently. And then the recessed parts, we've used aluminium. So we've mixed materials here together to create the overall aesthetic that we were looking for the building. And then the final example I'm going to give you a couple of moments on is Battersea Exchange. And this project is a mix of residential at school and commercial areas at ground floor. It's bisected by 2 railways and was previously very fragmented. There are actually 11 buildings here, and we wanted to knit into the local context, whereas a lot of listed areas and heritage areas. So we've used a range of brick and terracotta to create this collection of buildings, going from gatehouse brick buildings that link into the local context through to the big brown warehouse type of style brick building, and then the tall terracotta buildings. And by using the one material that links 2 of the towers and the school together, it makes one urban block, which I think has worked quite well. But we've also mixed in some other things here. In the diamond-shaped tall building that we've got up there, we used 2 or 3 different terracotta profiles to create this sort of wave effect. But then where we have the aluminium parts that go up across the winter gardens, we had at first thought these would be terracotta, but actually an aluminium extrusion has worked much better in that location. So to create the whole elevation by slightly mixing different materials. And then for the brick buildings, we've taken inspiration again from the brick viaducts that run through the project and used the brick to twist and articulate it to give a good expression for these buildings.
And I think just sort of finally, I think one of the important things is the sustainability aspect of the facades that we're building now, and everything that we're building. We have to be really mindful of, should we be building and not reusing or refurbishing? And I think the importance is just making sure that in terms of the materiality that we're using, that we're making responsible choices. And I think, we've got to start designing with materials that we can either reuse, dismantle, and I think, elements like terracotta and brick provide that opportunity. Obviously, aluminium also provides that opportunity, but the process of making it. So we just need to start getting really mindful in terms of, I think in terms of the build-ups and performance and that aspect, we're getting really good at getting good air tightness, good ventilation, good U values, the right amount of light, we've named that, but I think the next step now is looking at that circular economy and looking at how we can create these beautiful buildings using these wonderful materials that will stand the test of time, but also making sure that we're not unnecessarily creating new materials and building things, and we're designing it in a way that we can dismantle, reuse, or that it's the longevity of it is that it will still be standing in 60 to 100 years' time, and those buildings have that last. So I think the lasting aspect is we can have so much fun with these materials, but we need to be really mindful of the impact of what we're doing in terms of building, in terms of that.
And on our role, we see as architects how we can choose, manipulate, and work with materials to their best ability to create buildings that will age well and last a long time, and then be reused and be loved.
Yeah, I think that's probably us done. Thank you for
Thank you for taking us through that. On to now the topic of sustainability and talking through the principles of a collaborative approach at the earliest stage of design is Ayman El-Hibri from WilkinsonEyre and Jonathan Wilson from Arup talking about 8 Bishopsgate and taking sustainability to scale in the city. And Will, if you don't already have a mic, can you please...
Thanks, everyone. Testing. Okay, it works. We got a very different scale to show you now. This is a tower in the city that Jonathan and I have been working on for a long time. Essentially, the project started almost in 2013, 10 years ago. We got planning in 2015 for a 40-story tower and went on hold for 2 years. The whole city changed. I won't spend the whole session talking about the planning and the whole process, but we ended up with a tower which was 50 stories tall that in many ways is better proportionally than what we had in the beginning. Then we went through a PCSA period with Scheldebau, developed the specification, refined the details, and then ever since it's been through construction. So we're going to show you the process from concept all the way to construction and show you the process that we went through. So one of the main constraints on this project is the site itself. The geometry of the footprint of the building is a very strange L-shaped building, not very conducive of a tower. But also the other constraint is the vertical kind of relationship with St. Paul's Cathedral. And like the Leadenhall building, which has this very kind of iconic triangular shape, our building had to fit within those constraints, and the planners were very adamant that we had to kind of respond to that in the same way. We didn't respond to it with a triangle. What we came up with, this is a sketch that Chris Wilkinson, he passed away last year, who was very involved in this job, came up with a series of volumes that kind of stepped away from the St. Paul's triangular shape that the Leadenhall defined. And each time those blocks shift and change, they change their materiality. And we wanted each one of those blocks to have a different character. We wanted it to respond to a different kind of datum within the city, and we kind of identified these 3 datums. So you've got the historic base with the Portland stone, and then you've got the more kind of metallic buildings like the Lloyds of London, Willis, and Tower 42. So we kind of borrowed some of those elements in the middle part of the building, but then we wanted the upper block to kind of be liberated of those elements and become a much more transparent and reflective element. So we mainly have 5 facade types. So, there's probably a lot of more subtypes in there that Jonathan will talk about in detail, but each one of those blocks, as I just explained, the lower part, it's got like the Portland stone effect at the base. And then we played with the subdivisions of the glazing to create different characters. So on the upper left corner, you can see the kind of diagonal bracing that then comes through these metal fins that accentuate the bracing of the cladding. And then the upper block changes its module. It's a multiple of it. It doubles in size and goes from 1.5 to 3 by 3.8. And then at the end, on the side, the vertical element that stitches the two together is a 750 module. We played a lot of tricks in terms of just the subtle changes between the glazing. So the upper block has got a reflective coating on it. That just helps it become a bit more reflective and a bit more distinctive, whereas lower elements have no coatings on them whatsoever.
Yeah. What's really interesting about these renders is the accuracy of them when we see the built pictures later on.
And these are some of the images that we did at the end of the design, just showing how it looks at Bishopsgate, the entrance off of Leadenhall with the stone cladding. This uses a precast system. I mean, we could spend quite a lot of time talking just about the precast, but we won't today.
But the stone on the corner building was meant to look like handset stone, and I think we've been quite successful as that, even though we panelized it with a precast system.
And then during the night, the kind of perception changes, and you can see the structure coming through, and the diagonal bracing then becomes a lot more apparent. And this is a view looking at the building from the west off of Bishopsgate, and you get the perception of the reception with the double height glazing. And one of the other things that we kind of developed is the soffits. We wanted to accentuate each one of these blocks and make them more distinctive. And we worked on this mirror stainless steel soffit design that had to be ±1 tolerance to keep it nice and reflective. And flat. So I'll hand over to Jonathan now to talk a bit about the design development of the cladding.
Thanks, Ayman. Once the massing had been set for 8 Bishopsgate, we started looking at the facade design and looking at what facade systems we could use for to meet the performance requirements, and also subsequently embodied carbon. And we also looked to really push the quality for the facade systems. As Ayman says, there are 4 or 5 key facade types, but mainly we're going to look at the when we're looking at facade systems, where we're looking at the vision glazing for the upper, mid, and lower block. At the beginning, we've considered a single skin facade with reduced glazing percentages and fins. So horizontal on the south and vertical on the east and west. And also we looked at a double skin facade system with interstitial blinds. So you've got a double glazed unit on the inside, a blind in the cavity, and then a laminated glass on the outside to protect the blinds.
I think it's important to say that performance was a key aspect here. This is a building that was designed 10 years ago, so embodied carbon wasn't really something we considered.
Yes. But subsequently, we have
looked at it in retrospect, but that was the performance, solar and new values, a key element in the development of the cladding.
Exactly. And when we were looking at when we were weighing up the different systems, as Ayman's pointed out earlier, actually seeing the diagonal bracing within especially within the lower block was key. So transparency through the facade was one of the key drivers. The adaptability of the facade. It's in the central cluster. It's a tall building where it's surrounded by the cheese grater to the east, and one Leadenhall is going up in front to the south. So the building that can actually respond to newer buildings on the site. Cost, obviously, we work very closely with Steve Moody at Alina.
Right, the audience.
Right, from the outset, making sure we're within the cost plan. And performance. So, as Ayman's mentioned, from the outset, performance was one of the key drivers for the facade. At the beginning, you've got to remember, this is 10 years ago. The solar gain target that the MEP consultant was focusing on was 100 watts per square metre of the first 4.5 metres of the floor area. But having an adaptive facade system, which allowed us to tweak the blinds and slightly just increase the usage, and looking at the reflectivity of the blinds, that helped us to go from 100 down to 50 watts per square metre in terms of solar gains. And this is a massive step. If we had a single skin, we wouldn't have been able to do this. And I'd say 50 watts per square metre is currently around about what people are targeting these days. And when we look at Letty and beyond, maybe a little bit beyond 50 watts. And this had a big impact on the kit that's needed for the cooling for the on-floor plant. In terms of cost, but also in terms of embodied carbon. The image on the screen, the image on the left is a reflected ceiling plan showing the cooling system that would have been needed for a 100 watts target, whereas on the right we've got a much smaller kit that was required. And I said that was a really big win that was only possible with an active system. From the early stages of the project, we used our Arab Solar software that really helped us focus in on solar performance. That is dynamic, which helps you play with the glazing percentages, the G values, and so on. And this was really helpful when we were looking at the systems to select. And the blinds, lots of discussions about blinds, perforated, not perforated, 80 mil, 60 mil. In the end, we went with 80 mil blinds. And the blinds within the double skin facade system, they only operate when they're needed. Unlike blinds in a typical office with a single skin facade. So when they're not needed, the blinds retract. And as you can see here with the diagrams on the left, they're very rarely down. Then we'd never have them closed. And when the sun is not on the facade or it goes behind a building, the blinds will either go horizontal or retract. And we've restricted them to 2 cycles per day. So
I think that's the main advantage with an active system, is that you can let in the daylight when you need it, and you keep the sun out when you don't. And I think that is a key element of a CCF, a closed cavity double skin, that has enabled this building to be quite energy efficient.
Definitely, yeah. And Ayman mentioned it, so we started with a double skin facade, and then as we went through the tendering process, and at the end of the tender, we switched it to a closed cavity system, a more modern version of the system. And then when we selected as a design team, we decided on which system to go with, we pulled together one of these matrices that we presented to the client and gave them the reasons behind the selection of that system.
So Jonathan, just on the G value, what do you achieve with a CCF facade?
An interesting question, Ayman. We originally we had 0.12, but we know with working very closely with Sheldon, we've managed to push that down to 0.08, which is a massive improvement. And that also helped us with pushing the kilowatt hours down to 50.
And the building is in the cluster, so it's kind of influenced by the local wind effects that I'm sure a lot of you have seen in the media recently. But we had to kind of go into the wind tunnel, not just to look at the local wind comfort at street level, but also look at the forces exerted on the cladding itself. And Jonathan, this is a drawing that Sheldon produced off of the data that we got out of the wind tunnel, but it shows how much effect it does have on the cladding.
Exactly, Ayman. Yeah, initially just designing to code, we had certain wind load figures, and we assumed that the wind loads would come down after we'd done a wind tunnel test. But in actual fact, they ended up going up quite considerably, and in some areas where we've got the red, it's nearly 4 kilopascals. So it's quite significant loads. But working with Scheldebow, we managed visually the glass is completely. You don't tell that one panel is slightly thicker than another, and maybe heat strengthened. And embodied carbon, so it's worth saying here that at the time when we designed it, embodied carbon wasn't such a key driver as it's become now. So subsequently, we have gone back and checked and looked at the options that we looked at the time, and to see how well the CCF CCF system performs when compared to the alternatives. And if we just look at the upper, mid, and lower blocks, so I think Ayman described earlier, the upper block is a 3-meter panel with no central mullion, so really lean. The middle block's got 1.5 with an external feature to differentiate it from the other panels, from the other blocks. And then the eastern block has got a 1.5 meter module with a fin, 750 fin. And then if we just looked at when we compared the original single skin notional facade that we drew up, and with external fins and the opaque spandrels, compared it to the middle block with its external fin, and as you can see, the CCF does have more carbon within it. But generally, it's got because of more glass and so on. But when you look at the area of each of the different facade types, and you compare it against the single skin, because of the leanness of the upper block and the fact that the single skin's got external features, it is comparable. So so the CCF is in the end was quite comparable to the.
I think the takeaway here is that make bigger panels; they're more efficient.
Yeah,
I think that really is, and you might do a 4.5 meter module in the future.
Yeah. And as a whole, the whole building is for a tall building and a very constrained site. Obviously, the taller you go, the more embodied carbon you get. But it performs really well. And when we looked at A1 to A5, it's 750, which I think is. I know buildings that are going through planning at the moment, which are higher than that, which are of comparable size. And then when you look at A to C, which is whole life carbon, which we should be looking at, is still under 1,000.
And I mean, we won't go into all the nitty-gritties about the sustainability on the building, but the cladding really helped us get BREEAM outstanding and really pushed the energy performance quite a lot. And it is one of the first towers in the city to achieve that. But that's not just down to the cladding, but the whole sustainability story permeates throughout the tower in terms of the structure and how we've kind of developed that to work as efficient as it can be. Every member is different and just doing exactly what it needs to do. But also the MEP systems, we got the on-floor air handling units and how we've kind of broken it down. Really a subject for another day. And just kind of finishing the loop, like you can design something at the early stages, specify it, but really making it come to life, and controlling the quality is a key thing. So we made sure that in the Arab spec that there's a lot of emphasis on visual mock-ups, samples, actual one-to-one mock-ups of the prototypes of the cladding, in order to make sure that going from A to Z that everything is kind of captured.
Sorry. Yeah. And yeah, so we also did visual mock-ups of the stone building, looking at the visual mock-up for the CCF. One of the decisions that was made there and then was whether to go with a solid blind or a perforated blind. In the end, the client really wanted the perforated blind, and I think that's the right choice. And once we'd agreed with the visual mock-ups and we'd agreed on the extrusions, we made a technical visual mock-up just to make sure everybody was happy with the manufacturing of the CCF, and making sure we didn't get any visual distortions on the outer skin or the inner skin. And this, as you can see, we lifted it up at Sheldabow's facility and rotated it round, and there was very, very little distortion.
It was a very overcast sky, so the
It
pictures
looks-
don't do it
yeah,
justice.
They're not great photos, but and also weather testing and the whole remit.
So we're just going to finish off with a few images of the building as it nears completion. You know, we're quite proud of the end result. You know, the flatness of the glass is a key thing that Jonathan just touched on, because the building is such a you know, it's a series of very simple shapes. The glass really has to be as perfect as it can be, I guess.
And you can see there, just with the that's a much better picture there, with just the reflection of the clouds on the facade, on the lower block there, with the cantilevers, where I think imminently about to install the stainless steel soffits.
That's right, yeah.
Hopefully put some insulation in there.
Yeah, and just these are just a selection of images going through around the building. This is looking off of the junction, close up of the fins, cantilevers at the very top, and how the building changes, you know, with the weather is quite remarkable. You know,
yeah.
At least I don't get bored of looking at it from different angles at different days.
I see it every day on the train from South London, and it's and I think it's nearly finished just before Christmas, isn't it? It's
hopefully,
due to be.
fingers crossed.
And these amazing views that you get out over towards St. Paul's, and that view is never going to be interrupted, because that's as Ayman mentioned earlier, that viewing corridor is protected.
This is why we push for the transparency, because you get these amazing views out to around the city, and the cladding is not just about what you see from the inside, but how you perceive it from the inside.
Definitely.
So every great project has to have a great client, and we want to thank Mitsubishi and Stanhope, but also Alina, that have been a big part of making the cladding come together. But also Sheldabou, you know, we've worked really collaboratively as a team. You're not just getting the architect today, you're getting the engineer that's worked on it. So hopefully we've given you a taste of what the project's been about.
Yeah, and I'd say behind every great project is a great team, a great client. And the one thing I've noted over the last 10 years, it's gone through the whole project, is the collaborative nature of the team and the projects. And that is instilled in us by Mitsubishi and Stanhope.
So thank you, everyone.
Thank you.
And continuing on the theme of sustainability, we have Will Stevens from Interface Facade Engineering talking about embodied carbon reduction and innovating a design tool for maximum impact.
Good afternoon. It's all working all right? Good, yes. Thank you very much for coming along. Just to give a little bit of a background. Oh, there we go. So about 3.5 years ago, we started to look at embodied carbon seriously and to see what we could do for a metric for this and how we could measure it. Well, before there was an awful lot available, but we could see that the need was coming. So what I'm going to talk about today is an early stage design tool. So this is something that we've focused on, and really just wanted why we reduced this tool. So obviously we wanted to reduce the embodied carbon on our projects. At the time, there was very lack of regulatory or government input, but there was a growing awareness with our clients and with industry that this was coming. We had identified sort of the way we think we could achieve things, but there wasn't really any implementation route, so there was just nothing around for it. And this was continuing. We could see the rise of this embodied carbon and the importance of it to our clients, and also this key aspect of the decarbonisation of our electricity grid. So effectively, embodied carbon was coming up the scale by standing still. So we knew that it was going to come to the importance and therefore needed acting. Where are we going to go? There we go. At the time we started this, data was the real problem. So doing an analysis without data is pretty difficult. We haven't got embodied carbon data on things at the time, so it was very difficult to put anything together. But we persevered because we knew it was coming. The point was also the data quality was a real issue. We were lucky enough to have a project where the driven clients that really wanted to know about the embodied carbon early stage on, which really made us look at what why an early stage tool was so important. So what we really saw through this project was that when you're in a stage 2 of a project and the thing is not fixed, nobody knows quite what it is, every week you go to your design meeting and it's something else. It wasn't the same last week. But at that stage is when the greatest influence can be made on the embodied carbon of your facade, because you can change things. You can actually give people data, but there's no data to give. So we persevered and developed a tool in order to try and push that through. What that meant was that at that stage, because you're having to iterate this very fast, and in fact, everything you produce is already out of date and is all a bit of a waste of time, right? So speed is well and more important than accuracy. Fast response is required. We need that input, and we need it into the design team. But there was a low accuracy of the input data anyway. So you couldn't be accurate, okay? And I don't think you can be any accuracy at all at the moment. And we also limited ourselves to literally just products. Given that we were at stage 2, knowing where the product is going to come from and the transport, the construction methodologies was all way beyond that. So we really could not go beyond A1 to A4. And if this goes over there. So then we looked at what output do we need? What do we need at that point? Well, we need to know what are the opportunities with this design? It's not important whether it's 15 and 8, it's whether this one's better than that. And so we were concentrated on really just looking at, obviously there's values and there's numbers behind it, but we're really looking at what are the relative benefits of each option. And I think that the graph is really simplistic, but it's very true. At the early stage of a project, you can actually really influence that design very, very fundamentally. Once you get beyond planning, we're locked in a lot of ways. There's not much room to maneuver. And that's very early on. So we felt that the early stage tool was the place to go. We also identified that there was risks and accuracy had to be taken to the team and to the client. So if we're pushing forward with data that's rubbish, we have to tell people the data's rubbish. Luckily, we could put it slightly better. The data's rubbish, but it's the best we've got. And actually, we're better to work with what we've got than not to do anything. And also, it's also, when we're looking at it, it's also looking at the options and highlighting the risks that are associated with certain options. And as you look to different materials, risks and mitigations become more important. So we didn't really have we had to look at the process to go through to get this from an idea to a tool, something we could use. And we went through the normal methodologies of looking at what was out there, looking at tools that were available-ish, but didn't really focus on facades or were just whole life and not focused on design, which we needed, or took about 3 years to actually implement. We also looked at the barriers and how we could push those. And there was a massive amount of data collection. So the main thing was to look for EPDs. What could we get from an EPD? And they were so varied and frustrating. The EPDs are still frustrating. If we could have even just the units being the same, it would be helpful. So we developed an outline for the tool. We then threw that away and tried again and developed something else. And then we tested it out, but it was pretty much live. We still have this EPD issue. We couldn't find a specific tool. No early stage project tools. So we're looking at early stage, this fast design period where if you don't keep up with the design, you're not actually providing any value. And then how to integrate that with our team in the projects. How do you actually get the team to engage with this and actually take it on part with the design? Let's go over there. Here we go. So we focused on the EPDs for products stage A1 to A3. We had a whole areas that were just not there. And no data ranges. So effectively you might have a material, but what is the sort of reasonable range of carbon emissions for that material? Albion Stone, Michael Poultney was really helpful on that matter. We were looking at bricks, whereas Michael had done a lot of work on his EBD and actually really worked at it. He put PVs on the factory and was really engaged in it. But we had bricks which had a lower embodied carbon than his stone. And you're just looking at this going like, well, this is obviously errors and incorrect things. And these are EPDs that were on recognized databases and we felt should have been vetted, but were absolutely useless. And so we were into this position of garbage in, garbage out, where really it was very difficult to verify the data. And once you get beyond A1 to A3, it gets even harder. So construction process gets harder to be really any sort of interesting. When you're at stage 2 and 3, you don't know where the products are going to come from. So to start looking at transport really just beyond factory is really not worth it. C1 to C5 end of life, we felt there is an opportunity there. At the time, it wasn't something that we can do, and it's sitting on our desk to start to integrate that end of life into an early stage tool, because once you know what the material is, you know where roughly your end of life is. But I think we've all heard today that end of life is still a really big problem. So integrating into the process. So really it's just about what are we designing? Looking at the materials that are being selected, the opportunities to use other materials and pushing those forward. So not being a passive facade engineer, architects wants to use something here, some terracotta or some brick or some aluminium, but actually saying, well, what are the alternatives? And the tool gave us that really as an opportunity to broach those topics. And then to actually look at the construction methodology and see if we could drive any embodied carbon reduction with method rather than material. So identifying the different solutions was a key aspect. Identifying the mitigation options and identifying the consequential benefits and risks. So I'll come on to that a bit more. And then looking at how you can reduce this. So effectively, we start with a design, and we then look at the materials that we would get for a standard design. And then look at how we can mitigate those. And how do we present that back to a client and to an architect so they can understand the mitigation that's gone on, the impact of that mitigation, and so on. But when you're talking about every material in your facade, it gets a little bit complicated. So I'll just take you through a little example. It's really just a word example, though. It's not very pretty pictures. But so we're looking at these drawings here, and these are where we're at in this. So within a week of receiving some rough sketches and maybe a rough CAD model, we're having to produce the design sketches out of that. This shows something fairly simple. Plan sections, elevation of to pull out the materials. We're then itemizing the key components. So there's no point in looking at the gaskets or the fiddly bits that aren't really going to make a difference, that we aren't going to change, and they can be changed, at the end of the design period in stage 5. What we've got to look at is the big picture numbers and how that can be itemized. So mullions and transoms, in this case, panels, skins, insulation, glazing, the key numbers that we know and we can see are going to make the difference. And then assignment of dimensions and materials. It sounds so easy, but it's really very complicated. So effectively, we've actually got to put in every product, its dimensions, so that we can actually get a value out. What we worked with the EPDs and the fact that we had all this varied data that was, some of it was linear length of extrusion, of a particular extrusion you got an embodied carbon for, which was absolutely useless. But we could actually then look at doing volumetrics. So we did per cubic meter of product throughout, so transferring that back into cubic meters. And that allows us then to analyze the facade and get the cubic meter of each material and get the carbon density and then produce the embodied carbon in each item and then total it all up. That was a pretty picture. I didn't think I had any. So We then work through the standard option, which is just gives you what you do if you go out on the market and just buy the product without the care in the world. Then we looked at an improved one, which to start to bring the embodied carbon down, and then the enhanced option, where we made bigger moves. The output, we didn't do it by embodied carbon numbers, because we didn't feel there was the data to actually justify it or the accuracy to justify it. We literally looked at the percentage improvement, highlighting the changes we made, and then highlighting further options or actually mitigations. So key opportunities identified, key risks captured, and the risks mitigated were absolutely key. Oh, cool. Okay, so this is what it sort of looks like. And we would do the three versions of that to give us the embodied carbon numbers out of that. Now, you can't really present that because it's not really going to be helpful to anybody. So it gives us our donuts, which are much more easy to understand, with each material highlighted through it. And then we're going down through the options. We're actually switching out different materials and gradually reducing the embodied carbon of the solution that we've got. I think the next one has the rules. Okay, so this standard option gives us our baseline. The improved option, we sort of put some rules down after a while that the improved option should have basically the things where we can get a client to just say yes to it. So low cost or no cost. There's quite a lot of no cost opportunities out there, which can be taken, which are great, and they're really good for getting your client buy-in. But it shouldn't impact the architectural intent. So we're basically playing this back as first option, this is what you've got. Second option, this is what you've got, what you could have, and it's still the same. But it focuses the mind on these are the areas where there's still opportunities. And then we have the enhanced where we let loose, and we look for significant, maybe low cost, but we'll also have high cost items, but also higher risk items. And what was really good about the higher risk items, when you've got the improved option already on the table, if you then switch out something for a higher risk option, you've already got your mitigation there. And that mitigation can often run right the way through. So for instance, if you're looking at going down to the 75R aluminium from hydro, well, there might be a risk there that that's not going to be available or you're not going to be able to procure it. But you could still go to an aluminium smelted using 100% renewable energy. So your mitigation is already there in your standard one, but you've got your enhanced there as well. And that allows clients to not only say, let's go for the best, right? Let's go enhanced, because they know they've got a fallback and they can hold on to that through the design process well after this tool has done its job. And also the enhanced option allows us to impact the design intent. So we said that this we can't do too much of that, but we should be doing that. We should be putting forward the timber where they haven't put the timber in. We should be saying, well, we shouldn't be using this product. We could use that product, which will actually itemize the material changes and how those have impacted it. So from that, we then work up the type overall the project. So we're literally looking at just one little bay in that, which is useful, but it's not the whole picture, because we might have a hell of a lot of type A and hardly any of type E. So this, we then work through the whole project, looking at each type and how they all work together. Go on. And therefore, we then look at the overall project. Now, that sort of helps. It doesn't really help in the types too much, because we've done the work on the types. But it does actually tell us where the focus should be. Should we focus on type A? Should we focus on type B? It's relatively straightforward, but it's definitely worth doing it. The other one that's slightly more interesting is the overall facade materials, where you're collating all the data out of the types and pushing it into just a simple 3 donuts. And there you can look at the different materials we have got throughout the project and their opportunities and mitigations. And it stacks up as a whole. So you end up starting with a little diagram. Now, obviously, we can't do all of this in 1 week, because that's a massive job on any building of any size. So as the facades generally develop one at a time, and you're you're working on one and then working on the next and working on. So we gradually introduced them into the project until we got the whole map, which has been really helpful. So data is still a problem. Anybody that says they've got great EPDs, I'd love to meet you, because they're not there as far as I can work it out, despite databases being built. We need a range of, it would be great to have some ranges, like, you know, these are the range for this product and that's the range for another product, would be great. They don't exist as far as I'm aware. Construction process, we'd like to get to grips with that, and end of life data would be really good to start to feed that in at the beginning, because that's where we really need to be. We need to know what we're doing at the end. The standard improved enhance, it works really well. It brings engagement. People have to understand it. It's simple to understand. And the no cost is absolutely superb. If you've got a no cost option, everybody buys in. It's just a wonderful thing. And it allows the pick and mix. So effectively, it allows you to go to enhance and say, well, actually, we'll take that one, but not this one, which I think is really useful, because it gets clients and architects and team to actually engage with the process and be part of that, designing the embodied carbon, if you like. We've still got a lot to do. It's very early stage, really, for it, despite being used for quite a while. And I think really just to put a plug in for the CWCT guidance that's come out, I don't know if you've all seen that over the last year, really. So how to read an EPD, just start from the beginning, came out in December 21, and right through to the last one, how to calculate embodied carbon of facades worked example. So this is really helpful. I think we're still digesting some of these into the tool to backtrack it, feed it in, but it's great to have something out there that sort of gives us a basis of where to start. Thank you very much.
So we'd now like to invite Jannick Roth, who is the Head of Building Performance Engineering at Window Master International, to give his presentation on smart and intelligent automated facades as key to achieving sustainable and indoor climate targets. And Dan, if you haven't already, can you go and get a mic, please? Thanks.
Okay, can you hear me? Yes, thank you. Yeah, my name is Jannick Roth. I work for Window Master, and we have done a lot of incredible projects throughout the years, throughout the last 30 years, actually. These are some of them I have highlighted here. So, Window Master, we do not do anything with windows, except we automate them. So I want to briefly talk about the next 15 minutes about this intelligent window automation, also called natural ventilation. So we automate facade and roof openings. Yeah. That's, you can say, one part of it. We provide the actuator, but we also provide the control. So we provide the control for the natural system, for the mixed mode hybrid systems, but also for the smoke ventilation systems. And then people can actually interact these systems with this app, as you see here. Besides this, we also do, which is very important, also the control of the solar shading, cooling in the building, the heating, the light, but also the mechanical systems. And I think we have seen this figure quite a few times today, but I think I still want to elaborate a little bit on this one, because I think my presentation, I will focusing on, you can say, the embodied carbon and how we can reduce this, but also the operational carbon and how this can be reduced in these buildings going forward. So, of course, sustainability is a driver to finding the best solution and also to find the right solutions. And of course, natural ventilation can be a part of it, but in many cases, we actually have to collaborate with other kind of technologies and other kind of solutions. So just to say, of course, we need to focus on cutting this CO2 emissions, as we already know. But on the other hand, we also need, in the sustainability agenda, to have improved indoor air quality and thermal comfort and so on, because we have, you can say, a huge building envelope, 90% of it, which is quite old. Then, of course, we need to reduce the energy, the operational energy, but also we need to reduce the cost of these systems so they can be reliable and they can also be purchased. Yeah, and then we have a lot of other things also to consider, safety, of course. So I want to give you some examples here. some real examples we have done in the past. Some of them are quite new, some of them are a little bit older. The first one is a project in Norway called Cupertino. So this is a multiple, you can say, residential building. It's also an office building, but at the bottom we also have restaurants and cafes. It's placed in Oslo. And the aim was to, you can say, have 0 kilowatt-hour purchased energy for ventilation, for heating, but also for cooling. So here's the layout and the office environment here. As you see, it's 100% natural ventilated spaces. We have a floor-to-ceiling height of 3.5 meters. We don't have any suspended ceiling. We don't have any ductworks. And as you can see here, we have these high-level openings, mainly for the automated natural ventilation systems in this environment. What we can also see is that when we look at, you can say, embodied carbon for the ventilation solutions, we can see that natural ventilation scheme has the lowest embodied carbon impact. Then comes the hybrid ventilation solution. Here we combine, you can say, a smaller mechanical ventilation system in the colder conditions in the winter time with the natural ventilation scheme. And then at the end, we can say that the highest embodied carbon impact is the purely mechanical ventilation scheme, which is around 17%, 17 times higher compared to a pure natural ventilation systems. So of course, this is also something the building owner needs to consider when doing these kind of projects. And then, of course, we say we have controlled natural ventilation, but this is a rather tall building, so we have a taller building in a second. But this, for this project, we did, you can say, external CFD calculations to estimate how much should we open and close these openings. Because as you can see, the higher up we go, the higher is the pressure on this facade. And this means when we have natural ventilations, that the openings at the very top should not open that much compared to the openings at the bottom. So these, you can say, we can also do some other simulations, but these CFD simulations is actually, you can say, entered in the control algorithm. So the control knows that when the wind comes from this northeast direction, then these openings located in the red section should only open 5% in order to have the right amount of airflow coming to that building. Whereas, you can say, openings at the very lower level should open, for instance, 20% in order to have the same amount of air coming into that particular building. So you can say this CFD simulations is actually a part of the control solution. Yeah, so the next one is also a very tall building. This one is PNC Plaza in Pittsburgh, US. And here we have these, you can say, pop-out windows, where we have, you can say, 4 actuators on each of these pop-out windows. We have 700 parallel openings, you can say, in the outer skin facade, and we have around, you can say, 1,500 automated vents going from the, you can say, the inner facade into the double skin facade. So here you actually see the pop-out windows, which provide the fresh air into the cavity, the double skin facade. And then in a moment, you can actually see the, you can say, the smaller internal vents, which is located at floor level, which provide the air entering those rooms, is those you see down here. And actually for this project, we calculated that we can actually use natural ventilation for 45% of the time. So we can actually turn off the mechanical ventilation system throughout this period of time. So we can actually save a huge amount of energy in this, you can say, environment still using natural ventilation. Yeah, so this is just some nice images from inside and from outside. So you can say, why did they choose us, or why did they choose, you can say, the natural ventilation part? Is because you can say our actuators has some features. For instance, when we run them in, you can say, automatic mode, we only run them at so low speed that you cannot hear them below 25 dB. And also when you have, you can say these kind of parallel openings, one important feature is these synchronized, that all of these actuators are synchronized, so you don't twist, you can say, the profile, and also so you make sure that you can close these, that the facade is still airtight. Another example here, so this is a 3,000 square meter office building. We can place this in London. And as you can see on your far right side, if this building were to be ventilated with a mechanical ventilation system, the size of this was around 44,000 cubic meter per hour. If we then think of, let's combine, you can say, the mechanical part with a natural part, then we can actually downscale the mechanical ventilation system down to 25%, and then the natural ventilation scheme can actually handle, you can say, the summertime situation, but also the spring and autumn situation. So we can actually downscale the mechanical ventilation size and have this running at the, you can say, wintertime situation. So when we do this, we can actually see we can have some primary energy consumption and some cost for these different kind of ventilation schemes. So NV, that stands for natural ventilation, MV stands for mechanical ventilation, and HV, that's the hybrid ventilation solutions. So you can actually see that with natural ventilation system, we can actually reduce, you can say, the energy, primary energy consumptions with 25% compared to the pure mechanical ventilation system. If we then go to the hybrid part, where we have a smaller mechanical ventilation system to handle the wintertime situation, we can actually decrease the energy consumption with 50% compared to the pure mechanical ventilation system. When we then go to the cost, then we have divided these into capital costs. This is the blue one, operational and maintenance also. And what we actually see that the pure natural ventilation scheme, which is controlled here, is 4 times cheaper compared to the pure mechanical system. But also what you see here is actually that the hybrid system, where we combine the mechanical part and we combine it with the natural part, is actually cheaper, 25% cheaper compared to the full mechanical ventilation system, due to the fact that we have downscaled the mechanical part. So, of course, we also have a UK project. We have quite a lot of those. This one is the MECD, which has a pure natural ventilation solution. We have around 2,000 openings in the facade and also in the roof for this project. And we have, you can say, installed this and it's up and running. Another project, which is very close to here, is the UCL Student Center. You might know it, but here we also have, you can say, in the facade and in the roof, we have automated natural ventilation scheme. This is a BREEAM Outstanding project we have done a few years ago, and we can actually see now when we're looking at the data for the indoor climate that this has been performing very well throughout the last couple of springs and summers also. So, of course, we have all our solutions, and I think we have been talking about how are the solutions, but we also need, as a company, to recognize that we also have to do something in relation to, you can say, making an impact for, you can say, the future. So as our CEO says, that every company, no matter its size, has an impact on the environment and should be, you can say, a good global citizens. So what does that mean? That this means for us that we have some, you can say, goals we need to achieve and fulfill by 25 and also by 2030. So by 2030, we want to become 100% emission-free in scope 1 and 2, meaning that you can say our production and our solutions should be sustainable and shouldn't give any, you can say, burden to the environment. So this is very important also for us, that we can say that we can have products, but we also have, you can say, our Window Master Corporation still has, you can say, this impact on the environment going forward. I think the last slide here is that, as I also have shown, we have many projects around the world, but we also have many projects in the UK. So if you want to have a discussion about the natural ventilation scheme, you're more than welcome to meet us at the exhibition area, where we can have, you can say, further discussion about these different kind of projects and what we can do in these kind of different kind of environments with natural ventilation. I think that was my 15 minutes, and any questions, I'm more than happy to answer them later or now.
So next up is Dan Norman, who is Specification Advisor for OBEX Protection, who is going to be giving us a presentation on helping construction create safer, higher performance buildings with structural integrity.
Okay, thank you. Good afternoon all. I'll start with an introduction of myself. I'm Dan Norman from OBEX, Specification Advisor. We're manufacturers and providers of fire classified membranes, EPDM, alternatives, breather membranes, VCL, and also sheathing boards, cementitious sheathing boards. As an integral and trusted partner to many in the facade industry, today I'll be presenting a topic which is very important to us all in this particular sector of construction. The topic of our presentation today is how we at OBEX can help the construction industry create safer, higher performance buildings with structural integrity. Our vision ties in with our company core belief, which is our reason for being, which is creating safer buildings. So today we'll cover off three main areas relating to the only complete, tested and certified through-wall construction available for one supplier on the market. These will be the statutory and regulatory compliance relating to the construction and implementation of materials used within an SFS wall build-up. The rigorous standards and testing required to meet the current and future building performance requirements, and finally, safe, certified, and real-world through-wall solutions. As you'd all be aware, Approved Document B, Regulation 7, is the core guidance and governance around fire safety for facades and the external wall. I'd like to draw your attention to three main points that relate directly to the current implementation of membranes included within the external wall. First, Regulation 7, Section 2, Paragraph 3. This outlines the requirement for all membranes which become part of an external wall or specified attachment of a relevant building need to attain to a minimum fire classification of Class A2, S1, D0 or A1. Secondly, paragraph 3 provides some exemptions, and I'd like to draw your attention to the second point on the slide, which specifies the membranes are exempt from the A2 minimum requirement. However, as per point 3, this doesn't exclude them altogether. Clause 10.15a makes it very clear that membranes used as part of the external wall construction above ground level should achieve a minimum fire classification of BS3 D0. This has become the bedrock of our development programme and has governed our decisions on what advice we provide to the facade and construction industry in relation to membranes systems, including adhesives. As we touch on standards and testing, I firmly believe that we should be very thankful for the developments in the industry that have led to safer buildings, and the UK has been at the forefront of these safety improvements. We've included the standards that have specific importance to our elements of the through-wall construction, and we'd recommend that everybody familiarises themselves with these standards to ensure that your through-wall build-up meets these performance requirements, as well as fire compliance. All components used in our EI60 through-wall test conform to the relevant harmonised standards. In conjunction with performance testing, components must also be tested to determine their individual fire classification. This seems to be changing of its own accord. Having individually tested each component to EN 1395501-1 and together under EN 1364-1 to EI60, we now have a complete, tested and certified through-wall system. The incredible added value of this test is that you can now be certain that all of our products and the components used to create a through wall have been individually tested in isolation and will, without any element of doubt, provide a truly compliant construction which meets building performance standards. OBEX are very, very happy to present here today the very first fire-classified complete through-wall system. The first three products shown on the slide are included in the EI60 test. All of these OBEX Cortex components, the 0270 score and snap cement sheathing board, the 0223 FR breather membrane, and the 0230 FR VCL membrane have a fire classification of Class A. The EI60 test was completed with the use of Mexec SFS framing, rock wall insulation, and gypsum plasterboard. The final product in this slide shows the only true Class B fire-classified EPDM alternative. This product has been extensively tested and surpassed all performance and fire requirements, making it one of the integral elements of a fire-classified facade. Finally, in addition to what we have already presented, we have some exciting news to share, and are thrilled to announce we have received Kiwa BDA agreements for 4 more of our membranes, as shown on the screen, with 02230 or 0220 FR breather membrane being available in black and white, unprinted. Please feel free to come across to the stand just outside the auditorium doors for a chat and to discuss these unique solutions in further detail, and also for the opportunity to enter our competition to win 2 tickets to a Premier League football match of your choice and a genuine Premier League football. I'd like to finish off by saying a big thank you to the audience. Together we can create safer buildings.
Now, to conclude this session, we now have a panel discussion on the King's Cross redevelopment and the story so far. I think a lot of people in the room have been at some point involved in the development at King's Cross. As a contractor, we recently topped out R8 for Argent only a few weeks ago. I'd also like to say this is a panel discussion, so if anyone has any questions, please feel free to put your hand up to get a microphone to ask, and I will go ahead and introduce Duncan Richards, the founding director of FMDC, to introduce his panel.
Come on, guys. So, my glamorous panel. I'd like to introduce, please, Mark and Kemi, who are Argent people, development managers. Mark is, go on, sit down, guys, sit down, please. So Mark was the development manager on S1 and S2 projects that are now built. And Jack is the project lead from HMM on S3, which is a project at the moment that's coming to the end of construction on site. Kemi is the development manager for S3 and S4, and Angie is the lead director for S4, which is a housing management project on site at the moment. So, thank you. So I was asked in the summer by the Zak guys, would I moderate a panel? Yes, of course I'd moderate a panel. That was the easy bit. So then what am I going to do now? Oh, I don't know. I was thinking that events like this can be a bit themed. So, we're all talking about carbon one year, or we're talking about fire, or we're talking about information. And I thought, let's do something different. So the idea of just discussing the King's Cross site, the success that King's Cross I thought was a good thing to do. When I first moved to London in the late 80s, King's Cross was a disaster. You would not go anywhere near King's Cross, particularly after dark. It was not a good place. And now it's amazing. I mean, I was walking around there a few weeks ago, walking around the estate, and so many brilliant buildings, all different, all built to a really high standard of quality. A great mix of residential buildings, retail, office buildings, public spaces. Just a really, really nice place to be. And I thought that this is fantastic, but it clearly didn't happen by accident and didn't happen easily. So I thought it would be a really good story. Invite some guys along to just give us an insight in what happened and why. So my first question is to Mark and Kemi. So it'd be great, please, if you could give us a sort of a brief overview of the vision for the development. Any sort of key milestones, any game-changing things that happened, and also a little insight in why has it been so successful? Who wants to go first? Mark.
Good questions. I guess for the benefit of people who don't know King's Cross, it's a kind of big 67-acre site. It sits between King's Cross and St Pancras Station. It's sort of teardrop shaped. It's kind of bounded either side by High Speed 1 and the northeast kind of main line, crossed by canals, loads of tunnels. It's got it was the old kind of railway lands and kind of goods sheds, so it was the kind of marshalling lands of the Industrial Revolution, so incredibly physically challenging site. And that's kind of without the kind of complexity of all the kind of social and economic challenges and stakeholders that were kind of involved originally. And I guess when we got involved, we did so by kind of an expression of interest. It was a kind of short letter which really tried to kind of set out the aspirations for what this place could be, rather than kind of try to physically determine what it should be on day one. And that tried to kind of put relationships and engagement as the kind of core theme of what we were trying to do. I guess in terms of how that developed, in 2001 we wrote a kind of manifesto called, manifesto that kind of set out the principles of the place. It was entirely non-spatial. It tried to examine, what a city should be for people and what it should feel like to be there. And it was really a set of pledges that kind of looked at how we'd communicate, how we would try and invest for the long term, how we would kind of promote accessibility, promote sustainability in all its forms, try and use the heritage of what was already there, and try and make it as inclusive as possible. And that document has kind of been the guiding kind of manifesto for the development over the last 20 years. And there were quite big questions. It was all kind of pretty broad stuff. And it took us nearly 6 years to put anything in for planning. So you can see how long we were kind of wrestling with a lot of those questions. But in the end, we developed a set of things called the parameter plans, which really kind of underpin the entire development. And they were sufficiently detailed, so it kind of worked on an urban kind of social and economic level, but flexible enough, knowing that this kind of development was going to continue to evolve over 20, 30 years. And that was with Eliza Morrison, who kind of guided a lot of those parameter plans as part of the master plan.
I think the secret to the magic of King's Cross really is collaboration in terms of the way we work with our designers, the architects, the supply chain, the main contractors really. I think over the years, Eliza Morrison, you guys have been working on King's Cross for like 20 years. Jack, you've been working on King's Cross for like 10 years. And just working together, delivering building after building with, the same set of design teams and the same set of main contractors, supply chain as well. You start, alongside the delivery partners, we start developing the brief and, constantly improving as well. I think outside of that, you end up building a lot of relationship on a one-to-one basis with people, both in meetings and outside of meetings as well. And I think these allows, designers like yourself, Duncan, that flexibility and gives you that creative space, really, to bring us your best innovative solutions. And I think when you walk around King's Cross, you really can see that it's a place that is centered around people, not just the end users, but, like you guys, Angie and Jack, that help us create the space as well. And I think that's one piece that is unique about King's Cross and the way the development has come along over the years.
I totally understand the collaboration bit. The Argent model of having a limited supply chain, so having 3 main contractors they work with, a number of architects, but not thousands, a sort of chosen, selected group of consultants and main contractors and subcontractors. That also, it works really well. You know the people, all good. And another thing that you told me ages ago, Mark, one of the key milestones, I believe, was landing the University of the Arts as an anchor tenant. Is that right?
Yeah, there's one or two things that sort of sticks in my mind. Like, you can plan, and it can be, there's obviously a massive logistical challenge to delivery, but you also need a lot of luck. And like 2 of the things that stick out for me are, 1, winning the Olympics, or London winning the Olympics, was huge in terms of allowing the kind of redevelopment of King's Cross Station, the McCasland kind of ticket hall, and that changing the way that people move through the station between King's Cross and St Pancras, essentially created the front door for what King's Cross became. There was no way of knowing that would happen. And the second one was, the discussions with the UAL about moving St Martin's, moving into King's Cross and taking over the kind of first building that we did, which was the kind of the University of the Arts and Granary Square. And the UAL are a phenomenal kind of partner. They, this kind of desire to bring and unite all kind of aspects of design and art together in one space. They kind of, at a kind of really basic level, it kind of brings 1,500 of the kind of coolest people that you'd ever imagine to King's Cross, right to the middle of an estate. But I guess on a more serious note, they kind of, they shout the very essence of the culture about inclusivity and kind of creativity, and they absolutely pervade everything that we do. They are such an important kind of relationship. It's it really does kind of set the tone for the place.
Yeah, I totally understood that. It's you've got 1,500 young people walking around being arty and gorgeous. Who wouldn't want to be?
Yeah, it's
who
really
wouldn't want to work near them? Or, it's amazing. It's amazing. So that's all. Completely understand that. So my next question is to Jack and Angie. So you're both, or you're delivering buildings in the S zone at the moment, S3 and S4. So it'd be great if you could just tell us a little bit about them, please. How did you respond to the brief? What's a bit different? How do they relate to each other? Who wants to go first? Jack.
Sure. So AHMM designed S3, which I think is on some of the slides here. It's the blue one. We responded to a number of things in the brief. I think for the sake of time and maybe just kind of honing in on a couple of pieces, your question was brief and how we respond. It's an office building. There are a number of facets of that coming from Argent's brief. I think in terms of how did we respond to neighbouring buildings, which I know was something we discussed coming into this panel, it's kind of tricky because in a master plan like that, they may have been designed, some of them weren't, such as S4 at the time. None of them were built, really. Most of them were finishing off or starting. So how do you respond to something that isn't there? And I think we responded really mainly to the public realm as a starting point. And I think the public realm, the master plan, has really been the greatest success for King's Cross. And so in some ways we started by saying how are we going to respond to that and be a polite, or maybe a bit of a cheeky, impolite, bright blue backdrop to that public realm. So we thought about the curve of Canal Reach. That's obviously pretty evident in our response and how that manifests as a design. We thought about how buildings are entered. There was a nominal location for the entry for the building on that curved street. We didn't feel like that was right, so we had discussions with Kemi about moving that onto Cascady Square and really marking and anchoring an address. And we thought about where to put the core in the building and how to manifest that as part of how the building would speak to the next building across, knowing that S4 was going to be coming forward, so hoping there'd be a bit of a dialogue about that. And I guess amongst many other last little things, we thought about how the two would work together, and that was a really pleasurable discussion. And as dry and as boring as it was, lorries and how you get them into a building was quite important. So we drove a tunnel through our building so that we could get the loading bay around the back, and so we didn't ruin Keskety Square and Chiltern Square and Canal Reach, and so that both those buildings could work well together. So of many, those were things we did. But I don't know.
Okay, thank you.
I guess what was, back to Mark's point and the question that relates to, the question you asked us, Duncan, really, what was really important part of the master plan is the network of streets and spaces. And the master plan, if you looked at it 15 years ago, Zone S was very different. It was orthogonal blocks with fronts and backs. And Argent had, a huge aspiration to animate that network of spaces. And so had a very challenging brief for both of us, both Jack and I, and our respective practices, to make many fronts. And many fronts are great, for people that are experiencing the streets and the spaces, but how do you actually facilitate the functions of the building? Where are the backs? Where are the messy lorries? And so Jack and ourselves, we had this discussion about what is the nature and the character of that yard space. That servicing tunnel that comes through underneath S3 now, is also at grade. We had economic pressures not to build the huge basements. So, having that being a tidy, nice urban space, a dignified urban space that many residents and visitors to King's Cross can still enjoy, but still service the buildings was the biggest challenge. And as designers of buildings and of the facade, there's a huge, pressure on us to actually make sure that that is actually detailed well. And so I guess everybody here participates in that, and making sure that the quality of the buildings that are on King's Cross now is actually well detailed. That was part of the brief. The other thing is the brief for the building itself changed. For Zone S has changed, 3-4 folds. It was residential use, then it was commercial use, back to residential use. And so the building, as you see, if you go up to S3 and see it, is actually quite a big behemoth footprint. And the resultant site is actually S4, which is a kind of L-shaped triangular site. And so having to actually respond to those challenges in terms of getting an envelope to wrap around what is residential use. And Kemi gave us this really challenging brief of more units, we've got to meet the viability. In fact, actually getting that repetition in the facades, as you see here, is really key. It worked out, didn't it?
That's great, thank you. Right, so the next question is to Mark and Kemi. So it'd be great to have an insight into the sort of key challenges that you faced in delivery of the S-Zone buildings. So stuff that occurs to me, springs to my mind. So Carillion went bust in the middle of building S2, so that was helpful, I imagine.
Well, everything's exciting, isn't it? I mean, there's always going to be big challenges like that. I mean, Carillion, you mentioned earlier about the kind of relatively small cluster of kind of contractors that we work again and again with. Carillion were one of those. We'd worked with them across King's Cross since the inception, first building that we built, and it was it was really difficult. It was really difficult from a perspective of a lot of Carillion, a lot of people that worked at Carillion have been there a very, very long time, and they were heavily invested in that business in terms of their lives, and like the relationships are really important when things are going well, and my God, they're really important when things are going wrong. And it is those individual kind of connections that you make with people that kind of stick in your mind. And we tried to do everything that we could, because a lot of those people now work for the business. They were really talented people. We tried to keep them going as much as we could. yeah, it was very challenging, and the kind of, I guess, you know, probably everybody in this room's felt some impact from that in some way, shape, or form. But yeah, it was that was quite a tough period.
So what else? Brexit, that must have been helpful, I would have thought. That was just
well, they just keep coming, don't they?
Yeah. So that's
yeah, I mean I guess we're still feeling that now as well. But I guess in terms of Zone S specifically, there was a kind of perceptual challenge around Zone S as much as there was a physical challenge of kind of all the usual constraints, in that life didn't really exist beyond Granary Square. So one of the first kind of urban challenges was, how do you actually get people to make the next leap? And the kind of first buildings that we brought forward were two office buildings, S1 and S2, and both won at competition by Maasland and Partners. Oh yeah, on screen at the moment.
There you go. Seamless.
It's absolutely perfectly timed. And I guess one of the things that I really liked about, or was really kind of convincing about the kind of the design response, is that the massing is trying to solve some of that kind of the desire to draw people up through the estate at a really passive level. So it's kind of two buildings, single kind of composition, a single kind of uniting facade, one language on the outside, and then a second kind of language where the massing kind of pulls apart. And kind of Michel Maasland, who's a kind of brilliantly, helpfully here. I was about to say he was supremely talented, but I'll obviously keep that.
He's here now, you can't say it now.
But absolutely, you know, design obsessed. Like the key moves in that were really kind of. There was a triple height kind of volume on the corner that drew people up through the square, which led into a colonnade, which defines the entrance for the office building, punched through and extended into the second building, and kind of articulated for people at really tacit level how to move through the estate. And then the void between the two buildings is this really incredible kind of sculptural space, a kind of negative implied architectural space where the push and the pull of one building kind of respond to each other. And that eventually drew through to the kind of public square at the back that Allies and Morrison and HMM have been responding to. But yeah, the architecture was really trying to solve some of the master planning issues that we kind of face with.
And so for you, Kemi, so the inflation's mad. It's how do you manage to, you know, grab the tiger by the tail and deliver these amazing buildings to a very, you know, aggressive cost plan when the world's gone mad? I mean, that must have been really hard.
I mean, you know yourself, Duncan, with S3 and S4, aside from, you know, the current cost pressure and inflationary pressures that we're all feeling now, but also there is that desire in King's Cross that every building has to be better than the last building. You know, you have to take on lessons learned from the last building. You have to constantly improve the quality. The aspiration just keeps getting higher and higher, you know, which again, reason why we kind of continue to work with the same design team. So we are all on this journey together. But then there is also that time pressure because S3 and S4 are the last two big builds on the estate. So, you know, those are the last two buildings that completes, you know, the whole regeneration of King's Cross. So there is that time pressure to complete King's Cross from being a development to now being an asset and, you know, an operational asset as well. So again, the perfect trial of time, quality, cost pressure. And I think what we've had to do very early on, you know, on S3, at stage 2, we had to rely heavily on, you know, our relationships with, you know, the designers, the main contractors, the subcontractors. I can remember working with Fawcett at stage 2, even before we submitted planning to talk about the buildability of the facade, you know, providing design input into, okay, we have time pressure, so we need to manage time program, we need to think about crane time, we need to think about the size of the facade, you know, where do we limit the size of the facade so that it kind of comes through the hoist. This is our budget. By the way, we want beautiful blue terracotta. We want it to be double fired, you know, all those aspirations that we had. But then again, working with the supply chain very early on, even before submitting planning, we were able to kind of manage all those possible cost pressures that, you know, could have run away from us. This was way back in February 2019, you know, before the Brexit event happened, before I ever heard of the word COVID. You know, we didn't know what was coming down the line that we were going to be facing. And I think just because of that strong relationship we have with, you know, the design team, we started working with BAM before we submitted planning on this building to kind of validate the buildability, to validate the cost, you know, to validate the program as well. Because of these relationships, I think when the hard times came, you know, when we were buying S3, steel prices was going up every day. You know, we had to kind of work with a subcontractor to kind of agree the steel package before we actually even went into main contract. But that's because of the trusting relationship with the supply chain. So we were, in a way, in a very fortunate position, just purely because of those relationships, to be able to deal with a lot of those cost pressure, time pressure. We never went back for any RMA. You know, if you look at the CGIs of S3, what you see on the CGI is actually what you actually see on site. You know, we hadn't had to make any changes, any concession, managing it within cost as well. And I think it's just that big buying, bringing the supply chain into, you know, into the journey very, very early on and giving them ownership of that process as well. Same thing for building S4. Building S4 is locked. So we started building S3 before S4. S4 faces onto Lewis Cubic Park, which is like the biggest piece of green park in King's Cross. So that's kind of like a customer-facing area. You have all the residential buildings. And then on S3, you know, in terms of logistics and challenges, which, you know, drove us to DFMA because we had to think, how do we get trucks in? How do we deliver materials? Again, working very early on at stage 1 with Langer Rook and twin tracking the design, thinking about how we're going to build this, how we're going to deliver it, you know, getting the supply chain to actually solve the problems for us quite early on meant we've been able to do that.
Remember, we had a buying session with Ray at Focky early, and it was desperately hot, and it was in our office, and you managed to click your fingers and summon up some ice creams and everything, and suddenly everything was
Life's always good with ice cream.
Yeah, exactly. That's all good. So another question now for Jack and Angie. So the S-Zone buildings, they were designed to respond to a brief of 5 years ago, more than that, and the world is changing super fast and continues to change. So, you know, carbon used to be a word that, you know, it's a lot of talk, never happened. Now it's massively important. COVID will have changed things. Be interesting to get your view on, you know, what different drivers now, and you know, would it have been a different architectural response? What might have been different? Jack, do you want to lead?
Sure. More ice creams.
Yes, always more ice creams.
Yeah, no, it's on a serious topic. I think it probably won't come too much of a surprise, really, in terms of our thinking. Those who are looking at the CGIs and the photos we see there will note that at the time of design, and it was very much a collaborative process with both Adrian and also the end occupier, the driving out of that was not an uncommon situation at the time, where the end occupier had a very set brief with regard to what they needed for M&E, for how they occupy those spaces. So they required a sealed building. I think, frankly and candidly, it's just a thing that we're seeing an awful lot more of now. Never mind the regulations, never mind the obligation that we have to work towards that lower carbon target now, which, as you say, like, those conversations weren't quite the same then. I would undoubtedly expect to be talking about natural ventilation, talking about working in opening windows within a facade like that at the minimum. Don't necessarily think it would have changed a whole lot else in our design process, maybe a few things here or there, but I think the challenges we had at the time, which Kemi kind of touched on, which ended up becoming opportunities, you know, particularly that time driver. I think that drove a really smart design in terms of how we wanted to leave, hopefully, what is a very memorable piece of architecture, which kind of touches on Mark's point of creating inertia. How do you draw people right up to the northern end of this site? And so by chunking that facade down, frankly, into something that can go into a hoist, so you can build it on time, build it on money, we ended up with a design which responded to that and then worked in that terracotta so that you don't notice those joints, or at least as much as possible. I think we'd do that again. I think it would have open windows. I think you'd have fresh air. Maybe not, but it's more than likely.
There's a big push now for UK procurement. So, you know, now you look at where's a subcontractor, how far away is he from my site?
Yeah.
You know, so then it was just Fockey, yep, right, that's his Fockey, fine. Now you'd be looking, oh, you know, can a UK contractor do it? Can we detail a facade to be built in a different way that suits UK procurement? So that's a different question that's sort of relatively new.
Yeah, we're looking at that quite a lot on a lot of our projects. I mean, I think it's an open field, but those sorts of questions of how we can drive, ideally, the entire kind of design process into the smallest, tightest supply chain in terms of geography as possible. But of course, we need to be mindful of smartest ways to do that. It won't always be someone up in Leeds. It may be someone elsewhere, but we will be working those different ways. We do look at facades as obviously unitized is on S3.
Yep.
You know, S4 is a different methodology altogether. We're often looking at punch windows within systems again. It seems to be a more common trend, which does actually enable us to think about facade systems in a lower carbon, procure from the closest way.
So that leads on beautifully to Angie.
So, well, we worked with you, Duncan, and your team and LEF, and we very early on spoke about, you know, Passivhaus and preempted measures, you know, to get the fabric to perform as best as it can. But ultimately, as the last plot on the King's Cross master plan, we were constrained. We were constrained to respond to others. And, you know, in many respects, architecturally, it gave us a lot of opportunities. You know, we had to respond to different datums, you know, aligning with the Messessian buildings, and, you know, being deferential to S5 for the Alison Brooks building, but also responding to S3. And because it's a triangular site, in many respects, its geometry, its massing geometry, had to be articulated. And so things like form factor, you know, wouldn't be possible, you know, to achieve a good Passivhaus building, and, you know, let alone the cost. So we did have that early kind of foresight in order to actually anticipate. We've had, you know, several meetings for that, but in the end, because of the constrained site, you know, being able to bring panels on site in the short program, we opted for, you know, a high quality kind of precast panel as part of the facade. And now we probably will delve more into actually look at concrete replacements, you know, maybe looking at the structure, albeit for residential use is quite challenging, looking at mass timber, try to reduce the embodied carbon more.
But you've got timber composite windows, which
is exactly,
good.
Which we have.
A lot of good things already. Yeah.
So there's a lot of kind of foresight and, you know, deep reviews in order to actually have that solar shading. But, you know, of course we can do more.
You've got the green concrete, so it's green.
Yeah,
green concrete rather than
literally green
terracotta
concrete on the facade. Yes. Yeah. But yeah, you know, you learn more every time you do a project, right? And yeah, hopefully you would take these lessons on into the next project.
Very good. Now, Mark, so I must have Mark talking about the stone on S2 because it's a fantastic story. So please.
Yeah, so I mean, I think it was probably the first ever meeting that we had with Michel.
Yeah.
He
look at it there. Yeah.
He brought along a piece of stone and placed it on the table and said, "You have to build a building out of this." I mean, there was absolutely no choice. we definitely had to do that. And look, the facade is kind of, it's a rain screen system. It's the stone on the outside is a black tough stone, which is a volcanic kind of ash stone. You find it a lot in kind of Italy, in Armenia. It was kind of always in kind of load-bearing construction, going back to kind of the Romans used it a lot. But Michel was so passionate about this stone. We kind of set about investigating how we might possibly do this, and there was loads of technical challenges around the stone and how it might work as a rain screen. But working with kind of Carillion very, very early on as kind of stage 2, kind of really early doors, we brought McMullen in, We brought a kind of stone specialist in. We worked with you guys in your technical stone department, and tried to look at where we could source this thing from. And it turned out there was basically one quarry in just outside Yerevan in Armenia that was open for 2 months of the year that supplied black tough stone.
Yeah.
There was everything else is pink, and it pink goes through all the different colours, but the black was essentially had to be this facade, and it's it massively contributes obviously to the kind of you have this dichotomy between the black on the outside and this kind of white facade everywhere the mass is cut. So it was really important. It is not a luxe product in any way, shape, or form. It's not a granite. It doesn't have it doesn't have that kind of sheen to it. It's a pretty cheap material, but and I say that in the nicest possible way. It's cheap from a position. It's kind of it's like the kind of black satin dinner jacket, but at the end of the night, not at the start of the night. And it's kind of it has inclusions. It has kind of depth and texture to it, and it's incredibly responsive to like the weather and light and things like that. So
that's great.
But yeah, that was we lots of conversations with businesses and kind of administrative kind of contacts through like the Armenian embassy, and then we actually took somebody out to basically sit in a factory in Armenia to kind of cut the stone and worked out the balance of how it was processed over there versus how it was processed over here. And then I spent about sort of 2 months just watching this website called Vessel Finder, and watching the ships do the deliveries and praying that the Z coordinates stayed like 0 or above. So it was an amazing thing to go and do, and I think the building really kind of benefits from not being this kind of shiny object.
Yeah. It's a great story, and I love every time I saw you, you would, so where's the ship? Well, it's here, knew it all. Yeah, great fun, great fun. Right, so we're almost done. So just for a bit of fun, I thought I'd ask the panel to pick their favourite building on the estate. So I'll go first because I'm the moderator. So I'm going to go for S2, which I think is brilliant. I walked around the estate, a few weeks ago, and it really leapt out of this because your two aren't finished yet. That's why. But I thought, it's beautiful, finished beautifully, detailed beautifully, great story, great journey, great working with Michel and his team, great fun. That's my favourite. Kemi.
I'll go for 4 Pancras Square. I can remember the first time walking to King's Cross, and I'm a structural engineer, so I was stunned that you could have a building clad in steel in its raw form. My favorite materials are concrete and steel, really. So I thought that was really, really, really bold and brave. And I think that was the moment where I decided I needed to be part of the King's Cross story, because you can just do what you want, really.
Yeah, very good. Yeah, it's a beauty. Angie.
I think it's the Central St. Martin building, mainly because it was one of the first buildings to be occupied. It has a remarkable ability to actually draw people in the way it's planned. I mean, you walk through some of the more hidden areas underneath the canopy market, and you reveal all the creative uses like the fashion dressmaking and woodworking, and it also is the first one to actually be a catalyst to draw people away from the station into the center of the master plan. So I think it's remarkable in that respect, and architecturally, Stanton Williams did a fantastic job as well.
Very good. Mark?
From a building perspective, I totally agree with that. I think that said, my kind of favourite place in the estate is actually is Granary Square. So a bit of a cheat, but I think there's not that many places that I've been to that are quite so sensory. It's got the fountains. It's kind of light, sound, water. It feels very kind of simple, but it's actually incredibly sophisticated. It works so hard for what it does for people and for the place. Yeah, so I'd go Granary Square.
Very good. Jack? It's almost a bit of a stitch-up, isn't it? We didn't talk about this, so
what have you got left?
I picked the same one. No, I'm a big admirer of Eric Parry's work at number 4 Pancras Square as well. I think there's something beautiful about the expression of the structure in the architecture there. That I think there's a lot to admire, but likewise, I think, you know, of many to pick from, the success of King's Cross is that fabric, is that stitching of buildings and public realm together, and really Granary Square is the king of those spaces, and that and the Granary building, that was that anchor. That's the trendy, young, fashionable people that we might not be, but made the space work, right? So, yeah, timeless architecture.
Thank you. So I think we're done. I think we have 29 seconds. So, anyone got any questions? 36 seconds. If you get more. Anything else? Done?
We could just leave.
Thank you very much, guys.
He's the principal and practice leader for SOM work in Europe and a former chair of the RIBA's large practice expert group. He enjoys solving complex problems and elegant solutions. Ladies and gentlemen, please be allowed to introduce Peter Jackson, who will be presenting for us today Frontier Facades.
Perfect. Thank you very much. We've seen some fantastic material today, interesting projects, interesting technologies, and there's a lot to reflect on. I wanted to take a moment both to look backwards at where we've been and forwards in terms of what SOM thinks emerging trends in facades might be. It's always the case that technology constrains us. These guys spinning glass and blowing glass, full of iron, full of inclusions, unstable, impossible to work with. But of course, human ingenuity to the fore. We have the pink mosque in Nawaz in Shiraz in Iran. We have Chartres Cathedral or York Minster, things of beauty which have lasted for many, many centuries. So the technology could be overcome, and that is always the case. So I wanted to go back 90 years or so to the Maison de Verre and to talk about the work of Pierre Charot and of Bernard Bivoud, the Dutch architect that he worked with, who doesn't get a lot of traction in the story. This is perhaps the first project that took mechanized systems and really got to a facade that we might recognize. And it's partly about the client. Jean d'Alsace was a doctor who ran his practice from home, and he was a thinker. He was a member of the French Communist Party, and this salon, this kind of industrial space that he proposed, saw Picasso and Jean Cocteau come through it. It was a fascinating place to be, and I think the architecture had a part to play in that. But if you pick apart the architecture and start to look at the details of it, we see things here which are the beginnings of a very familiar set of elements within our industry. Different glass types coming forward to signify different things or perform in different ways. The suspended screen to the stairs. He ran his medical practice from home, so this can be configured to provide privacy or access depending on the time of day. And more glass details coming through that we would recognize, including kind of around the doors and windows, very simple setup extrusions that are the beginnings of our modern practice. And we had a hand in that modern practice too. Rolling forward 20 or so years later to 1952, SOM worked on Lever House. Lever House on Park Avenue set a new kind of pattern of practice for the taller buildings, and again, it was about the client. Charles Luckman was the president of Lever Brothers at the time. An architect by training, he saw himself as something of an iconoclast, and he was looking for what the future of the workplace might be. and also thinking about how the workplace could inform his workforce and what he could get from them. So there was self-enlightened interest in this. And of course, Lever, as a firm, had some form in this. When they formed their own headquarters up near Liverpool in the UK, they set out a model factory with model worker housing, the idea being that if they provided a better quality of environment for their workforce, they could clearly get more from them. Less absenteeism through health, more productivity. It was a win for them as a developer, as a manufacturer. And the context of Park Avenue at the time was defined largely by these mostly residential buildings that defined their blocks, filled their blocks entirely, and were driven by a variety of planning codes that forced them to have this sort of Art Deco-esque flavour, very different to what we now think of as Manhattan. And when Luckman came to speak to Gordon Bunshaft and Nathalie Deblois at SOM at the time, they actually asked a different set of questions. Not how do you fill this site, not how much can you get in there, but how can you make the most out of this site? And Luckman clearly was all ears for this intervention. So taking that zoning plan that you can see in the dark background here, which established setbacks at every floor above 10 stories, what Bunshaft and Deblois really offered was something which was fit for purpose as a modern office, and said, how much space do you need to build? What do you need to do with that space? How can we respond? And they responded with something which is now very familiar to anybody who's been in Manhattan or anybody really in our industry. One of the first full facade buildings, about 70% glass on a typical floor, the sealed box, perhaps something that we wouldn't do today, but a suite of technologies that we certainly see as very recognizable. And you can see Bunshaft's thoughts on what he had achieved on the screen. I really like this project as an architect because working on the kind of complex buildings that we do, I just see our drawing sets become thicker and thicker and thicker. And we test them by dropping them on the floor and seeing what kind of noise they make. But this, as an architectural construction document set, was 55 sheets of A1 paper. And of that, the exterior wall was less than 10 pages. So what was actually achieved was an early example of really good collaboration between design team and industry through procurement and through construction. And from that, we got something quite extraordinary. And SOM has been very proud to stay involved in this project. 45 years on from its completion, we were involved in refurbishment of the facade, working with new sections, working with better performing glass to maintain the exact appearance of the building, but to bring it up to current standards in the US at that time. And we don't often hand letter our drawings today, but this is a listed building, a landmark building in the US language. So that was part of the submission pack that you see there. And you can see, again, how simple the drawings were. And we continue now, just this year, to be working on the project. So that's a 70-year relationship with a single building. And I think it's important to look at that and understand what it means, because I want to talk about carbon too, and maintaining a building, maintaining as much of the spent carbon that's already embodied in the structure is really critical. If you look at where we're going in London today, the London Energy Transformation Initiative, LETI, are pushing us to really think hard about what we can do with buildings, and their standards are broadly aligned with the RIBA's 2030 goals, which are broadly aligned with what is coming through in code. So they say that the facade should represent about 16% of a typical building for an office. Other typologies vary a little bit, and they are looking at us to take each and every one of the systems in a building and reduce the embodied carbon by more than 50%, which is a huge challenge. And we are certainly seeing that it's easy to do it with the superstructure. You can bring a timber frame in. There are challenges in that in the UK with fire at the moment, but there are good ways of resolving those issues that if insurers, mortgage lenders and others come together, we could actually fix quite readily as an industry. But some of the other systems are lagging, and we see that the facade is a system which is still lagging a little bit. And there's been some great work done on it today, fewer projects coming through that really reflect on that. So we've found in our practice that our government clients are often those who are willing to take more of a flexible approach, and working with the United Nations, their Geneva headquarters, as a suite of wider projects. We've delivered a building which is a hybrid structure. It looks quite conventional, but when you come inside, you can see that we have a mass timber and precast concrete structure for the slabs, precast concrete columns, but we also use a hybrid system in the facade. So the aluminium and glass are as you would expect them to be. They're doing the hard work in terms of retention, climatic control, etc. But this is a system that's floor-to-ceiling glass. Perhaps it's one of our last glass boxes, I don't know. It certainly feels like it's at the tail end of that approach, but by using a timber element to deal with the lateral strength in this system, we can take a lot of embodied carbon out by not having the aluminium that a deep member would bring. We're also looking at how we can take these same thought processes through our work on existing buildings. Corso Italia is a Geoponti building, Milan. A local boy made very good as an architect, and we were tasked with retaining both the structure and as much of the character of the building as possible. Not all of that building could be retained. On the left, you see a facade which was past even refurbishment or retention, but we were asked still to follow the pattern of Geoponti's architecture where it was appropriate. So we moved to something which I hope if you squint, you see is a very similar treatment in our refurbishment work. And what we did was to adopt a very simple facade system, as simple as we could be in terms of doing all the climatic controls that it needed to be, and this is a non-operable facade in this particular instance, but working with silicon jointed glazing so that we were able to remove as much aluminium, again, as part of the story. The glass works better from an embodied carbon standpoint, we find, than the aluminium, and it also works better because of the lesser cold bridging, so we know collectively that if we put a silicon joint in there, the facade will perform better. But to retain Ponti's architectural theme, we took the red granite from the original, and we were able to recycle it for a circular approach and use that as part of this screaming element. In this project, we had to take the granite away to be processed. We're anticipating from what we've learned here that it will be possible in the future to recycle more and more materials on site. There's always a logistics problem somewhere, and that will be one of them, but it will get to a point where we can do more on site to force the circular economy. And in the same space, we're also looking at how we can move towards carbon sequestering technologies. BioBrick is being co-developed between us and an American company, Prometheus, and it is an algae-based product which uses algae and whatever aggregates are available. We've certainly tested it with sand. We know that sand will become one of the next prescribed materials because of marine habitat issues, so it can be worked upon with crushed aggregate from existing projects. What it does, it's a room temperature drying and curing product. The algae is mixed with water and aggregate and cast. It can be done by kids. I mean, we've actually tested it with children in the classroom and got workable blocks that we could take to site. So it's a very, very simple, low technology product that can be made at the point of construction, which works with its carbon credentials, and it sequesters carbon. So over time, it draws more carbon in than it's used, and it's also infinitely recyclable, because once you have the mix of algae and aggregate, you can crush and reform as you need to. So we're taking parts of these various ideas, and we've actually brought together a principle of something that we refer to as urban sequoia, looking at how we could draw different technologies together holistically, whether that's the frame, the facade, the plant, other elements of the project as a whole, to build something that could actually actively sequester more carbon than it requires in building. So we launched Urban Sequoia last year at COP26, and our objective was really to test the water with industry, test the water with government, and see where we could get to, and what the appetite for something which, from the image you just saw, is perhaps out there in terms of its appearance, but as a proof of concept, what could it deliver?
this point on absorbing carbon is hugely important. At the moment, we're looking to offset. We cannot build enough trees to offset the carbon we're using in any one year, let alone in the buildings that we'll build next year and the year after. So we have to find better solutions to address that and reduce our reliance on offsetting, although it's been attractive in the near past. Here we're looking at direct air capture so that we can actually harness some of the carbon that's in the atmosphere and reutilize it. And at the moment, if you are offsetting, you know the cost of carbon per tonne. It's anticipated that that will grow exponentially as an opportunity to offset. So finding ways to address carbon harvesting and carbon capture more effectively is clearly critical to avoid the need to pay for offsets and pay carbon taxes. But actually we also recognise that there is a growing carbon economy, and the opportunity to recycle carbon through some of the opportunities that we list out here will provide developers, owners, occupiers with a potential revenue stream from carbon rather than a cost. So, as I said, we presented this at COP last year. It's an ideal project in many ways because it can be deployed anywhere in the world. The technologies are simple, they're available, they're not reliant on sophisticated manufacturing in the local locations, so it is a universal approach. I think that in terms of its appearance, it's possibly out there, but the technology is very available, and this year at COP27 in Egypt, we're about to launch a second approach to this project, which I can't show you yet, obviously, but to see how we can deliver something which can be more conventional in appearance and ultimately move all of our building systems, including facades, obviously, into a point of carbon capture and carbon absorption. And that is where we believe the industry can move to. Thank you.
Yeah, very inspiring presentation, Peter. Thank you so much. I really appreciate starting from the Maison de Verre. That was about the audacity of using new material in new forms and unconventional ways, and the metaphor with the hybrid timber office building like the urban sequoia. So thank you so much, Peter. So our next speaker is associate and project leader at Heatherwick Studio, joining the firm in 2014. As project leader, he has led various projects at the firm, including Google's Bay View headquarters, and large-scale competition. Ladies and gentlemen, please allow me to introduce on the stage Kyriakos Chatziparaskevas.
Thank you, Giovanni.
Thank you.
Very nice.
Who will be presenting for us today, Workplace of the Future, Google's Bayview Canopies Transform Solar Energy Harvesting to an Innovating Design Future. Please, let's give a warm welcome. Thank you.
Thank you, Giovanni, for the nice intro, and thanks everyone for being here today. There's a very strong synergy between solar harvesting and architecture, and many architects, designers, engineers, manufacturers work together and come up with solutions that integrate photovoltaic panels on various building elements such as facades, roofs, shading structures. This is what we started designing in 2014, and we delivered a couple of months ago. It's Google's new headquarters in Silicon Valley, and we worked on this project with BIG, so that our London team with their New York team, and we both had teams working in California on this project. And we think this project delivers a very, very pioneering solution in terms of integrating photovoltaic panels on that scale. So we're talking about 50,000 photovoltaic panels, and this is something that comes, let's say, in line with the vision that Google has for 2030 to operate 24/7 completely on carbon-free energy. So we're in the heart of Silicon Valley in Mountain View, where Google was founded and where their current headquarters are. And we were always, when visiting the site, we were always very, very excited about all these very heroic airship hangars that exist nearby. And many of them have been leased by Google, and there is something about them in terms of the efficiency of the space, the volume of the space they create, the lightweightedness that captured our attention from the very beginning. And we really wanted to explore that kind of large span structure that provides a maximum level of flexibility and openness. And the client, of course, has a lot of experience on converting existing buildings into their workplace, and they do it very, very well and very efficiently. But that project was supposed to be the first purpose-built project for them. So it was a very unique moment for us to take on this journey. And of course, we were presented with a set of values that we see throughout all of their workspaces, and they have to do with connectivity. They have to do with how they perceive that people feel better at their working environment. They work together better. They invent better ideas. So we're talking about spaces to experiment, spaces that make you feel healthier. They create calmness. They're efficient. And of course, the focus started from the user. Their principle is that when the user feels so right and is at a space that he feels welcomed and very, very encouraged to come up with new ideas, that everything else will just follow. So before talking about the canopy and what that does for the building and the experience of the building, we just trying to understand about let's say, the magnitude of the workforce that they were trying to put under one roof. And that has to do really with how the client organizes their teams. So we're talking about 3,000 Googles under one roof on each one of these structures. And there was always the notion, like, okay, if we have like a building with large span, let's just maybe, in many cases, it was filled with floors, and then the floors were filled with desks, and there was always the challenge of who is going to have the best space, or who is going to have the space where it kind of has a focal point. This is a photograph of our studio in King's Cross, and we have the skylight, and below that we have a round table, and we always feel that this kind of synergy between the light of the skylight and surrounded by all these cabinet of curiosities around us, it creates this a perfect setting for us to come up with new ideas. And this is Sundar, the CEO of Google, sitting at his desk. There is also something about being connected to nature and having everybody enjoying that kind of proximity to the window. Many times when we go to the office, we say, oh, this guy has the seat by the window. And there is a kind of privilege attached to that. We wanted something that like everybody could feel that kind of experience of being close to nature and close to the window. So we started from a quite large area. We're talking about, let's say, a grid of 500 feet long. And we started looking at the team sizes. The team sizes, they mostly operate very well between 20 and 40 people, according to their experience. And we started creating villages and neighborhoods of those teams that they maintain the visual connectivity between those teams, and in that way they feel, let's say, that with the people they work, they feel more connected, and organize courtyards around those neighborhoods that form plates, and by doing that and creating a kind of pinwheel configuration, we end up with a large. It's like a collection of villages, floor plate, that it has perforations that create courtyards. Again, the 3,000 Googles and the floor plate that is a single floor, basically lifted. So instead of stacking different floors, we're just trying to create an expansive space, and beneath that, place all the amenities, all of the spaces where you go, where you want to have an informal hangout, all the kind of restaurants, cafes, meeting spaces. So they go underneath, and then that whole thing creates, it's almost like a piece of a city where the courtyards establish those focal moments where also help with orienting yourself, because it's a very large floor plate, about 500 feet long, as I said. So these moments were like fun moments where people can gather and socialize. And that generated the grid of the canopy. So the columns were dropped at the centers of these courtyards. And then a kind of, it's almost like a handkerchief, like a very, very gentle handkerchief that was draped above those pin columns, and with 4 landing points on the corners. We created that kind of geometry that we called squome, because it's like a square dome. That was the kind of term we came up with, and Google loved it. And then we started creating incisions that they form clerestories, and they let the light, the natural light, come in. That entire canopy was covered by photovoltaic panels, 50,000 for each one of these. So it's almost like a kind of like a tablecloth of photovoltaic panels. Those bays were then optimized in terms of curvature to harvest as much stormwater and rainwater possible. And that whole system was deployed along different sites. So it's the Bayview site is the one that we delivered first. There is another one in Charleston East that is being built at the moment, and you see close by the Googleplex, the kind of iconic headquarters of Google. But speaking about what the canopy does, and in terms of the overall sustainability vision of the company and of the brief of the project, is Google's vision to operate by 2030 100% on carbon-free energy was something that we wanted also to declare with a canopy. So those 50,000 photovoltaic panels generate 40% of the energy that the building requires. This is about 7 megawatts per hour, and this is enough to power 2,300 homes in California. It's almost like a kind of photovoltaic farm scale application, and of course it has the capacity to export power. So it's the curvature of the base help a lot capturing the sun at the low angle. So there is something about the form, the drapiness of the form, and the fact that it's covered with photovoltaic shingles. But the building features many kind of sustainability attributes. I would say it's the canopy that is a rainwater harvesting device, and in combination with a whole landscape treatment that consists of open water ponds and water retention ponds. That whole system enables us to basically to cover the entire non-potable demands, water demands for the building with on-site water generation. So we don't need really to import any water from the grid for like things like toilets or irrigation, whatever you could possibly imagine. Plus those ponds create a very nice system that supports the natural habitat like meadows, wetlands, the local flora and fauna, with the irrigation needs covered by water produced locally on site and harvested from the roof. And the last thing is that, again, is a result of the geometry of the canopy and the section of the whole building. We're having a really big void. We're talking about 80 feet above this single level office to the top of the building. And that creates a stack effect that allows the warm air to naturally move upwards and have that kind of ventilation. And that, again, in combination with what happens under the building, we're having a geothermal plant, which is the biggest in North America. It helps a lot in reducing the demand for water for cooling the air in the building, and that really goes up to 90% reduction of water needs for cooling the air within the building. And of course, because of the geo-exchange, we have other benefits that lead to reducing the carbon emissions of the building by 48%. That, of course, has to do with the well-being of Googlers, because that system is very efficient. It makes sure that you have fresh air. The air is always healthy, and it ties again with a big vision that the founders of Google have about that kind of that the air is always clean and is part of the well-being and a system that supports people to feel better and work better there. This is again from the geothermal piles. We have 2,000, and they're all integrated into the foundation of the building and the canopy. But in terms of let's say the forming of the geometry of the canopy and the structure that we deployed, it was a big question how we can efficiently cover this and make sure also we reduce the tonnage, the steel tonnage. It was supposed to be a very, very lightweight structure. So we worked with fantastic engineers, with Thornton Tomasetti in Los Angeles, and we came up with a hybrid of many different systems. But it really came from that necessity of the very strict seismic regulation that exists in California. It's a seismic area. And by that, we came up with these two large arches that are kind of diagonally positioned. And then we came up with a catenary structure that bridges it, and a grid of columns that kind of subdivides the span. And then in two directions, we have those lines that are, again, running diagonally, which are stiffened by the clerestory trusses. And then there is what we call the tubenet structure that supports the metal deck. And together with the deck, it creates a flexible system, but also rigid at the same time. And it was deployed in that manner on this particular project. The two large structures are office space, and the small one is a tech talk space where they're having their meetings. We went through an exhaustive series of curvature analysis and optimization, so that we create that kind of almost like a leaf, that there is this ridge in the middle and the water goes towards the center, and then it flows towards the lowest point to collect with the surfaces that are integrated on the columns at the intersection points of these bays. And these are all the systems coming together. It's a fairly simple system. One could easily think of how it would work on a flat surface, but here all the surfaces are doubly curved. So moving from the steel structure to the metal deck and to the racking system of the PV system, we worked with various consultants, and it all started, of course, from the steel. It's again, all the connections are exposed. We didn't have a soffit. It's it has this kind of industrial look, but as architects, we were confronted with the challenge that we had to push really the boundaries of coordinating all of these details, as it's the largest surface of the building. This underside of the canopy is very, very visible. You can see here the metal deck that comes on top of it, and then we came up with a construction sequence where the clerestories and the eyebrows, those very nice metal trims that were assembled in factory, and then they were brought as one piece, and then they were lifted in place with the kind of all the layers of the insulation and the halters. You see here the standing seam with the central gutter and some of the finish elements. Then we had to integrate all the kind of infrastructure for the PVs and the racking system, as well as all the kind of maintenance equipment, which was quite challenging on this project, just because of the ever-changing kind of curvature of the bays that forced us to come up with a perimeter walkway, but people should still be able to walk on the PVs themselves, and that had a quite interesting way of how to resolve the fall arrest system and the climb assist system, and this is how it was put together at the end, with those cleats that help people to climb up, and it was quite. We wanted to achieve something where everything looks like an architectural finish, that it doesn't give the kind of stuck-on thing that the PV came later or something else came first, that all fell into the place at the same time. This is from the steel factory. You can see the scale of those trusses put together, and the construction, the erection method we used for the structure was quite interesting, because most of this tubelet structure was assembled in like large segments on factory, but then we came up with this idea that it should be strand jacked all together as one piece, just because of the pressure on site and the time. But that gave us an opportunity to express the erection sequence of all the steel details. So that's, according to our steel contractors, the biggest strand jack in North America ever done. And you can see how the steel trusses were slided on the columns with those sled structures, almost like sleeves wrapping around the steel. And all of the steel connections were kind of expressing that moment of the lifting, which we quite enjoyed at the beginning. We were quite skeptical about how we would arrange all the bolts. How is it going to read? Is it going to read messy? But we went through really, really detailed modeling, so that the entire building is modeled to that level. So we could really even dictate the direction of the bolt heads, so that it looks how we wanted to have it, and all the surfaces were integrated in collaboration with architects and all the trades and ourselves and our team. So we were very involved on all the resolution of the services integration. And of course, what we enjoy the most is this kind of cathedral feeling that it gives when you're inside. It's almost like the light that comes from above almost dissolves the kind of the structure and the weight of it. These are of our press photographs. And it lets the space below to be like a small city where people can have more focused conversations in kind of demountable units. But that anticipates a lot of change because the neighborhoods below the canopy, who knows, maybe Google wants to build spaceships in this envelope in 20 years. So in a way, the canopy and the envelope was thought with that in mind. Again, some of the more kind of human scale photographs looking up and seeing the sun coming through. Our studio puts a lot of emphasis on human experience, and those courtyards are really a manifestation of people coming together, socializing. So it kind of naturally drags your eyes up. And of course, to study the photovoltaic panels and how all the systems come together, we went through many mock-ups. This is just one segment of the canopy where we're testing how the array of the PVs flows on the surface and creates this sweeping geometry. But we had, of course, challenges that had to do with glare. So we had to really put together here nine PVs and studying them, like do many lapse time photographies and like in different angles to make sure we're not blinding anyone. And also investigate the finish of it, which you can see it's silver. It's not like black or blue. They're black or dark gray, and then most of the times they reflect the sky, they become blue. With this one, we went with a kind of lamination method that allowed us to use a kind of more architectural finish like film that doesn't compromise the output of the PVs. You can see here the installation. And the glass is nano-textured so that people can walk on it, but also it provides a kind of self-cleaning property. Some photographs here where the light goes into the kind of sweeping geometry and it kind of accentuates it. And some of the natural elements and the water retention ponds around the building. Here again, some really nice photographs in dusk, showing the inside world of the building and how that canopy creates that shell of life, and the clerestory is allowing some of the light from inside coming outside. But we really enjoyed also the juxtaposition between the shape of the buildings and the natural landscape of Mountain View, and how also it kind of plays with the height of the historical hangars on the back on the NASA airfield. Some photographs of the natural trails that surround the buildings and how people who jog every day there can get a glimpse of the complexity of space and interactions that happen under this canopy. Again here showing a little bit the bullnose details that integrate the gutters and the tensile elements on the structure, those cables. We have also some spaces where the vertical facade is a bit more broken down, and these are the faces, the facades facing inwards towards the plaza. So we have what we call pop-outs there. There are smaller spaces that poke through the large curtain wall, and they break down the scale. You can see here the vertical facade, which it's a fairly standard system. I mean, the panels are quite tall, about 16 feet high, and the purpose of that was to create as much transparency as possible, so that we celebrate from outside the underside of the canopy. And of course, because of the very big overhang that the building has, we didn't have to do a lot of glare control at the top of the vertical facade. So that allowed us to to have the upper row of roller blinds deployed from the bottom to the top. That means that most of the people who work like towards the center of the dome, they can still see through the sky, through the glass at the sky, even when there is strong sun and low sun. Also, we had to work a lot on protecting the local habitat because of light pollution, because of bird protection. So the whole glazing system and the lighting of the surroundings were kind of tuned with that. We used ceramic frites for the birds, and we made sure that the glass is 16% reflective, not more than that, so that it doesn't reflect the natural environment around, and it doesn't feel like inviting the birds to crash on it. And that's the last slide I have. It just shows a close-up of the sweeping geometry and the level of integration between all the different systems that creates this very gentle, very smooth geometry, which we hope it shows in a way the way of how architects could use photovoltaics in such a large scale without being afraid that it's something that is more of an afterthought or something like this. It can really be part of the design process and make a difference as let's say the main design feature of a building. And that's what we really, really enjoyed about this project. Thank you very much.
Very inspiring presentation, Kyriakos. I take one of your last words, integration. It's a great example of integration in between passive and active design strategies, as well as a clever structural scheme. Thank you so much. So let's move on. Our next speaker is the Associate Fire Engineer at OFR Consultant. He will present the role of facades in fire safety for timber buildings. Please welcome Steven Ferreira.
Afternoon, everybody. So, as you can see, the name on the screen there is Sam Liptrott from OFR. He's one of our directors. He unfortunately couldn't make it today, and he has given me the last-minute tag-in. So let's hope I can give the presentation the justice that it deserves, and I can convey the same thoughts that Sam wanted to give over to you guys today. So essentially, there's a key word in this statement, and the role of facade in preventing vertical fire spread in a typical office building. So that if you just stick with the word preventing, I'll largely clarify that as we go along. So there's a very simple answer to this seemingly complicated question, and then the explanation is much longer than the simple answer. But the simple answer is nothing. So there is no role in the facade actually preventing fire spreading floor to floor. So if we move on, so we have different time frames in where obviously people looked at fire safety within buildings, and we have the original designs of buildings, and then the post-war studies, and then there was a very big event there was a series of tests that happened or studies that underwent in 1966. So we've got two images on the screen over here. So when they did the post-war studies and looked at the buildings, they decided that the facade should prevent fire spreading floor to floor. And that's where you got into putting spandrel panels into your building, so robust spandrel panels or the projections. And the feeling was that those two elements will prevent a fire spreading from one floor to the other floor via the outside of the building. And that's, again, the key word, prevent or re-enter through the facade. So post-1966, Margaret Law undertook a couple of studies where they evaluated and tested and tried to figure out how effective these two elements in buildings would be in preventing fire spreading floor to floor. And what was found was that re-entrance of the fire onto a different floor plate via the facade was prevalent. And they owned these two, the aprons and the spandrels, at the specific dimensions that you can see there in terms of 3 foot for the spandrel or 2 feet for the apron, only delayed fire spreading floor to floor. It never prevented it. So that takes us to post-1960, 1966, where they started to have a really good look at what did the regulations say and what was the objective of, let's say, vertical fire spread for buildings. So it was always understood that building, like furniture, fittings, all that sort of stuff, the combustible stuff in our buildings are going to catch fire. And limiting the window sizes on the facades was pretty irrelevant because we're only delaying igniting the furniture and fixtures and the combustible materials on another floor. We're never preventing it. So pretty much the restrictions of those two elements in our buildings fell out of building regs. So that's where pretty much the modern day curtain walling system started becoming more prevalent in building designs. And one of the key things that went into that was that it inherently became a presumption that the structure of the building was not going to contribute to a fire scenario. And that's vitally important to understand today while we are looking at timber buildings in the context of the building regulations, guidance documents, and the underlying presumptions that led to those elements becoming essentially the law. So that's quite important to know. So we only delay fire spread floor to floor in any building type. Now with something like timber, if we move on, okay, so why does timber matter? And this is a really good image and where we probably can speak about some of the myths about engineered timber, is that sometimes you will see or hear things like engineered timber doesn't burn, or it is a better product in a fire condition than metal because metal melts, timber does only chars, all that sort of stuff. And that's pretty much false. If you sustain enough energy onto a timber structure, it is going to ignite itself at some point in time. How much energy is put into that is obviously a key variable. But as you can see, you've got, when at the facade, if the glazing breaks, you're going to entrain oxygen into the space, and oxygen is obviously one of the key factors that you need. And you've got a lot of heat at the facade going out. And then we've got two images on the side where we've undertaken some CFD modeling in comparing, for instance, in the top image, what you'll see, that is more of that's a traditional office type with a concrete floor, essentially. You would always still, at the facade where the glazing has failed, get heat outside the building and projecting up the side and potentially radiating heat back onto the combustible products within the building. And you might not be able to see it that clearly, but essentially you don't have any flaming outside the building. There's no flames that project beyond the facade. But in the second image, you can see there's a spandrel panel on the bottom end, and that's a timber building, but you can see that there's a different heating profile within the compartment where the fire is. There's a lot more heat re-radiating back on itself because you've got multiple surfaces burning at the same time, radiating heat towards each other. And that ends up in a more severe fire scenario. So what the spandrel does in this instance is it brings the radiative effect on the facade on the upper level back down to within reasonable limits, or what's comparative to that of a normal steel and concrete building. So if we move on, so we've got 3 video clips that of testing regimes that have undergone. So 2 of them are effectively the same test, and 1 is a different test. So this first one is it's a timber build-up, but this is quite early on in the fire duration, and what we're showing here in terms of that flaming is on the type of fuel load that you could get in an office. There's a range and of fuel loads that you can perceive, and this is what we've subject this test to is on the 95th percentile of the higher end of the curve of type of fuel loads. So, for interest sake, you could have 250 megajoules per second type of fire load, or in this instance, I think this was 750 megajoules. So we're on the upper end and really conservative in how we are subjecting these tests to. So that was the first one. So you could see that all the flaming happens within the compartment. So if we go back to this image, that is representative of the top image of the CFD model. So if we go back to the screen, so there is going to be hot gases escaping through the opening. And just by the way, the reason why we don't have openings on multiple sides is that we accept that some of the glazing system is going to break on the facade. It's going to break, it's going to allow air to be entrained in those particular instances, but we accept that the entire facade is not just going to fall out and then contribute to the fire. So it's going to be localized in areas, and that's why we only have an opening on one side. If we had openings on multiple sides, obviously the fire behavior and how this test is going to roll out is going to be completely different, especially also when we get to the timber test. So this is representative of a typical office, and then this is representative of a hybrid structure. So what you can see here is that you actually have external flaming at the facade. So you're leading to a higher temperature range outside your building. And part of that is because in the initial phases when the CLT starts to ignite, there's hot unburnt gases that escape out the opening. And once it gets into an oxygen-rich environment, it starts to ignite. And that happens, or that event doesn't last for a huge amount of time. And at some point in the fire duration, the flames are effectively going to get back into the compartment. So we've not necessarily shown that, but you can kind of see that event happening at about halfway through. So that's where the flame starts escaping, and there's an instance where the screen switch. So this is running at about twice the pace, just so we can obviously see. So you could see, so there's where the flames essentially start to, now it's not going to continuously to burn outside, it's going to essentially only burn. So now this is a full timber frame, and you can see the change in severity of the fire, especially when the flames start to escape outside. Now, in both instances, you have flaming outside the window. The key difference here is in the glulam / so the mass timber building, not the hybrid, that event is going to be sustained for a much longer period. And therefore, you have a much higher likelihood that fire could essentially re-enter itself on another floor plate. So, you can see there how severe that is. So that happened, I think that lasted for about 30 minutes, something like that. And that's very severe fire. So, vertical fire spread. So what we do know, so on the left, let's say typical office floor plate, that's just got, well, that's CLT with no spandrel on the side, essentially. So we know the timber is going to contribute to the fire scenario. You're going to get a much higher heat fluxes exposed onto the upper floor. So, for instance, if we're looking at a steel and concrete building, we know on the upper level, we're going to experience some form of heat flux, some radiation. And that graph shows the levels of essentially heat flux that you're going to receive in the facade. So just to contextualize the value, so the pilot ignition of wood, dried wood, is about 12.6 kilowatts per meter squared. So if you subject a piece of wood to that, it will self-ignite. So that's the context of what that means. So pretty much in a steel and concrete building, it's kind of irrelevant because, well, we know we just need to delay. It's not going to, most products within offices nowadays aren't untreated wood or, let's say, just dried timber. Office furniture nowadays, all pretty much non-combustible stuff. So it's pretty immaterial that that sort of heat fluxes. However, once we start to add like a CLT floor plate, that graph spikes really early. So what we need to do when we're looking at the facades for the building is we need to ensure that we are putting something in place to essentially flatten this curve back to something that's comparable to a traditional steel and concrete building. And that's where you can see it's like almost like a bit of a cartoonified version of a spandrel panel. It's obviously very oversized, but in this scenario, you can see what we're showing is that we're having an equivalent heat profile outside the building, radiating heat back onto the, and then we would consider that to satisfy the functional objective of building regs by only being obligated to delay fire spread floor to floor. So, the purpose of the next couple of slides is to show a couple of the projects where we've been involved in with different facade types. And it's not to say that this is what your slab edge detail needs to look like. It is just the solutions that we arrived on the project-specific basis. But there's a number of examples I can show you, which pretty much from our perspective, you're not locked into a certain facade type that's going to satisfy the functional objectives of building regs. Most facade systems that we're seeing nowadays have all the various components in place to facilitate you to get something robust at the slab edge that you can actually implement timber into your design. So this one's, you can see you've got the GRC panels at every second floor, and every third floor you have more like a unitized panel at the slab edge, and you can see that's fixed back onto a concrete edge beam, essentially. So the reason why that was done is that you kind of end up in a more traditional sort of slab edge detail and trying to fix essentially fire stopping details and that sort of stuff back onto timber is always a point of discussion, where this is fixing back onto concrete. It's a more like traditional installation. Then this ultra high performing, before I move on, so if we can just refer back to when we were speaking about spandrels and aprons, the overall objective is to get height and depth around the slab, or height and depth, let's call it like that, height and depth at the slab edge. So you pretty much can flatten that curve of the heat flux that we saw in the previous slides. So again here, ultra high performance concrete in the facade. We have again height and depth at the slab edge. You've always got the projection, which is acting in some manner as a an apron, all that sort of stuff. And then it's just a traditional sort of window installation. And again, with ceramic rain screen panels, very similar in detail. Nothing unique. You also get the height and depth by the build-up, which is great. And here's quite a unique one. You almost have a sawtooth. Well, you have a sawtooth facade. So you have the combination of a spandrel and a projection, and you can see kind of the values that we arrived at in terms of the depth and the height that we needed to achieve for those two elements to work in conjunction with each other. To get the height and depth, we need to flatten that curve. And then the last one, metal screen with curtain walling. Again, quite interesting with this one is that typically when we're designing spandrels or when we fix them back on, we're not designing them to never fall off, especially in the fire case. So sometimes we just accept that those elements are going to fail. This one in particular has been designed to remain in place for the full duration of the fire event. And that was quite important because of the mass timber nature of the building. And when we say mass timber compared to hybrid, all the other versions were more hybrid type structures, so you have a less severe fire case, if I can put it like that. Asking me how they actually made it to never fall off. I wasn't involved, so I don't know the answer to that question, but it's definitely credible. So one of the really important things to note is that there's dimensions shown on these elements. Now, the dimension is not a standard dimension. Each situation, each building, each slab edge detail is going to have to be calculated. You have to prove that you have a flattening of the curve to something that is comparable. There is no standard one size fits all for these elements. So it's vitally important that you, obviously for this facade, for the makeup during the planning processes, that sort of stuff is figured out early in the project program, because if you leave it too late, you're going to have to change or might have to change the facade build-up, all that sort of stuff. So yeah, I think that's it. Oh, this one, Google. Well, Google's quite an interesting one. This is the headquarters in King's Cross that we were involved in, and this is often used as a benchmarking exercise for timber buildings. It's not really comparable to timber buildings because it's unique in the fact that you've got massive spandrels and also projections at the major floor plates, and everywhere where you've got essentially a compartment floor, it is a full concrete floor. And what you have is in between those two concrete floors, you have a mass timber build inbound of the facade. So all the conditions we were speaking about now, about the facade failing, all that is brought into the design. So it's not really a comparable exercise to go and say, for instance, there's timber in the facade at Google, and therefore all that sort of stuff. They had the mechanisms in place to deal with those sort of events, and it's not really a comparable study to go and say, that's what Google did, so let's just do the same. Slight different dynamic for that type of building. So yeah, that's it from us, and thank you very much.
Thank you so much, Steven. Thank you. Thank you for giving practical example to critical questions that we have in our everyday life as architects, facade engineer, and so on. And the fact that the solutions are project-specific is why we need clever people as Steven. Thank you so much. So our next speaker is the Director of Global Sales at SE Control. Please welcome on stage with a warm welcome, Martin Oates. Thank you.
Good afternoon, everybody. This time last year, our Managing Director, Will Perkins, presented here at Zak, and he presented how the digitalization of life safety products can meet the requirements of the forthcoming Golden Thread initiative, which, as we all know, is a large outcome of the Hackett report post the Grenfell tragedy. Now that that is now becoming legislation and will be mandated forthcoming, we'll now produce an update of how that regulation is moving and what our involvement is to achieve it and our involvement as people within the industry to achieve it. Unfortunately, at the 11th hour, COVID has struck. So Will is not with us today. He's extremely disappointed not to be here with you to continue his story. So what we have done and decided as the optimum way to get that message through and continue the message from last year and beyond is Will has produced a recording for you to watch and run through that presentation for you. Any questions that you have later on, please come and see us. We're upstairs exhibiting, but I'll pass you over to Will remotely. Thanks, everybody.
Good afternoon, everybody. Apologies I can't be with you in person this afternoon. I've been struck down by the dreaded COVID. So next 15 minutes, I'm going to be talking about the Building Safety Act and the digital golden thread. In particular, looking at when the legislation is going to affect us, who it's going to affect, and by using a case study of a facade fire safety product, namely an automatic opening vent, a smoke vent, going to use that to walk us through the stages and identify the touch points with the digital golden thread to put it into a better context of understanding. So the when. Last year, when I was actually stood in the auditorium, then I was talking about the Building Safety Bill. That is now a Building Safety Act, and it became legislation in April this year. It received royal assent in April this year. So the primary legislation is enacted, is in place. Importantly, the secondary legislation, which is the Golden Thread, Gateways 1 and 2, and various other spin-offs, which I'll mention, the consultation on that concluded in October, 2 weeks ago, and that will become legislation in October 23, so less than 12 months. So it's on its way, it's coming down its track. So hopefully this will give you an insight. The who. This is important because, as the name suggests, it's the Building Safety Act. Therefore, anybody involved in building safety, including manufacturers, including designers, installers, and including building operators, it includes everybody who influences safety. I mentioned building operators because that's really good, because in terms of understanding the concept of this digital golden thread, it's actually quite good to put yourselves in the shoes of a building operator and think, what is the information I need to be able to operate my building safely and efficiently? And a really simple way of thinking about this is we're all facing an energy cost crisis, and I'm probably no dissimilar to everybody in the room. I've gone, okay, where's our heating controller at home? I want to get my head around it. I want to optimize, switch off, optimize the energy consumption in our household, and so off I went and I found it, and it's a 20-year-old analog controller, bit of an LCD display on there, a lot of buttons and writings. Okay, I'm not a technophobe. It's going to take me 10 minutes and a bit of trial and error to get my head around that. And hopefully what I do is going to improve get me to an outcome I want. Compare that to a modern house or apartment, and chances are the heating controller in there is digital. It's probably controlled via an app on your phone. The information is intuitive, it's instant, there's feedback from it, and the chances of me achieving an outcome I want via that is much stronger than my analog technology because the user experience is better. And in terms of an analogy, that kind of sums up where we are as an industry over the last 20 years, last 40 years, sorry. We've been delivering buildings which haven't got the level of information necessary to provide that user experience for all the reasons why. But in terms of thinking about the digital golden thread, what we can do is we can see what we can experience today and try and create that for buildings moving forward. Okay, mentioned Building Safety Act received royal assent. In terms of the data, an important development, and it was published in summer, is a new British standard, BS 8644. It's the grey band at the bottom, and that is all about management of digital fire safety information for a building. Great piece of work. It sets out it's got templates in there. It's the type of data, but importantly, it has these things, IEPs, these information exchange points at the different stages of construction, and it sets out the type of information that needs to be exchanged and therefore captured as part of the golden thread. The Building Safety Act sets out legally recognised duty holders in the process, including the client, including the principal designer, principal contractor, and importantly, the building management function through the responsible person. And in addition to that, there are designers who work under the principal designers, manufacturers, and contractors. Okay, from the digital golden thread point of view, the important point to recognise here is through that construction process, those interactions, potentially through those IEPs, those decisions need to be captured and recorded in a central database, the golden thread, because those are the bits of information that that responsible person, the consumer of the information, needs to have half a chance of operating their building efficiently, optimally, and safely. So, okay, in terms of the how, so we're working through my my worked example. I've worked, if those of you know me, I've worked most of my life in smoke ventilation, involved in various working groups and committees. So, in terms of the worked example, it makes sense to use this example, facade fire safety products, an AOV, an automatic opening vent. And that product is covered by a harmonized European standard. Why is that important? Or it's a harmonized standard. Why is that important? Because under the CPR, the use of that harmonized standard is mandatory. And this standard isn't new. It's been around actually since 2003, and the blue box on the right-hand side gives you an indication of the systems out there, the products out there who are able to satisfy this requirement. Because it's a life safety product, it has quite a high level of certification. Can't self-certify, third-party certification that is underwritten by what was an approved body before Brexit, and now in the UK it's called. It was a notified body and is under UKCA is called an approved body. And the important point here, I think, to remember for me to point out, is the process of developing that European standard. Experts sit in a room and we go, okay, for all intents and purposes, here's a window and an actuator together. What turns those two products into a single product, an automatic smoke vent, and what are the characteristics of that product that need to be transparent and transferable across all of those smoke vent products. So things like temperature, performance at high temperature, operational reliability, those kind of things. So those become a series of characteristics which are attached, the performance requirements for that vent. Interestingly, the European standards were built around encouraging competition, not necessarily safety, because by having a kind of baseline of functional requirements, it's actually easier to compare more products and therefore arguably become more competitive. Also, very important, underneath the UKCA mark in the middle there, something called the National Construction Products Regulator. This is a new position that has been formed as a direct result of Grenfell and Hackett, and that is the enforcement arm of product safety to make sure A, products that should be used are being used, and B, products that are making declarations are exactly what they say they are. This isn't something that's going to happen down the line. This is happening now. I literally only yesterday, my company is in touch with these guys to give them training on the products and the certification for our specific industry. Those guys have got legal powers, so it's coming. There's less room for movement. Okay, if we take our example building, we're at Gateway 1 in the design. We understand we need some smoke ventilation in our means of escape. Gateway 1, we're going to use the approved document as our fire strategy. So it's quite straightforward, quite prescriptive. So let's have a look what approved document B says about our automatic opening vent. Okay, guess what? It's called up straight away that harmonized standard. This isn't new. It's called up the harmonized standard, and it says it's got a functional performance requirement of 1.5 square meters, which is the equivalent of 0.9 square meters of aerodynamic free area, which, guess what, is one of those essential characteristics from the harmonized standard. So even going through the route of ADB, we've got an audit trail of functional requirements that needs to be captured in the golden thread. Okay, if we move into our construction phase through to occupation now, anybody tendering for this project and they want to put forward their proposal for a product that's got to satisfy that site, that elevation, that floor, which has got specific functional requirements for an individual product, they can demonstrate that through what's called a Declaration of Performance, a DOP. And that is underwritten by that approved body I wrote about earlier on, with all the audit trail behind that. Won the order, we're moving into manufacture. This is where it gets really exciting, because we have a physical product is born, and we can start to attach digital information to that product. And this is where the innovation starts to come in. It gets really quite interesting, because we know that product has got to go on that site, that elevation, that floor, and it needs these characteristics. We can attach that digitally to that product, so it sits with it throughout its history. Importantly, when that product reaches site and it's got to be installed, competence is a huge takeaway from Grenfell and Hackett, to the extent there is a series of British standards, the 8670 series, which deal with competence from the top down. So starting with competence of principal designers, competence of principal contractors, BS 8673 prints for building operators. So there's templates for building operators. Apologies, I'm having to rush along. So looking at the technology and innovation, it is really quite straightforward for the person installing that product, through digital interactions with the product, can say who they are, when they installed it, and record their competence completely seamlessly digitally, and that is attached to the product again in the cloud. Okay, let's assume the building has gone swimmingly well. It's now handed over and it's occupied. So obviously, as soon as that building's occupied, these are life safety systems. They need to be regularly checked, obviously, and maintained. But the importance of embedding this technology into products moving forward is every time that product is operated by a house manager as part of the weekly check, not only can we tell its status of being healthy or in fault, we can also validate the operation, not that it opened, but that it opened to meet the functional requirements that were designed all the way back in approved document B for that specific application. And that can be done seamlessly, shared with the cloud seamlessly, and consumed by the end user's asset management platform. So think of the cost savings and efficiencies by effectively a machine talking to a machine. There's no, other than the pressing the button, there's no human intervention of that. So it's exciting because the opportunities in front of us to use technology to improve that user experience are really quite significant, and that will drive the cost down, and that will make our buildings safer. So I'm conscious I've only got a few seconds left. Final slide, I could have said why, but then look, we all know why we're having to have this discussion and what's going on and why we're doing what we're doing. It's incumbent. There's significant legislation coming down the track with enforcement, and so it's incumbent on all of us in this room, including the designers, including the manufacturers, contractors, installers, all of us, to adopt, be these early adopters who want to encourage using technology, using data, because the benefits are there. It's clear for everybody. So wrapping up, thank you very much for your time. Please, please, please engage with organizations who want to make a change, want to improve things, and want to move it forward. Okay, thank you for your time. Hopefully I'll see you in person next year, and have a jolly evening. Cheers now.
Well, thank you, Will, for the presentation. It would have been great, of course, to have him here. And thanks, Martin, for introducing Will. A very nice presentation about live compliance and smoke ventilation. So as we progress, our next speaker is the head of specification at Ephesus. He will present future-proofing your project with A1 fire-rated membrane. Please give a warm welcome on stage to Miguel. Thank you. Thank you.
Thank you, Giovanni. What a coincidence. Yeah, I don't know if it's, what a coincidence, Giovanni, to be here on stage at the same time. So, good afternoon to all. It's really a pleasure to be here on stage again. And my name is Miguel. I'm Ephesus, and today we'll be speaking about future-proof your projects. So we'll be speaking about breather and airtight vapor control layer membranes systems, class A1. We'll give an overview on solutions fully tested, approved, and installed in UK applications. And in the end of the presentation, we'll have really a big news to share. And this is real. This is, if you notice, 2022. So we have last month, Turkey, last August, China, January, 17 deaths, New York City. Last year, October, Thailand, Norway, Milan in Italy, almost a big, big disaster, residential. And to be honest with you, I believe we, as a facade community, we need to close, we need to find a solution to minimize, to close this issue. And being positive, there are solutions, the regulations are pushing. So, and what we, Ephesus, what we did it, and how can we help? And since 2011, we're pioneering and bringing a technology since 2011, 11 years, quite a lot, to be honest, and with one component of the system. And 2019, we close internally with VCL, and it's possible with confidence to control water, air, and water vapor using non-combustible solution, because this is really important that obviously that it's really, really important, but I could not compromise the end-use application of the product. And with confidence, we are able to control water outside, as you could see, Ephesus breather FR externally, a section on the right side, a standard range screen cladding section, on the bottom, we see a VCL application. And again, with confidence, we are able to meet first water, air, and water vapor using non-combustible solution and minimizing vertical connectivity and horizontal connectivity. Here it shows a picture of the products, not only the membrane, but all the membrane with the fixing and sealing accessories. And now, a little bit specifically in terms of the product, we changed the technology that was made of polypropylene and polyethylene to a pure fiberglass technology that allow us to achieve a waterproofing vapor permeable, combining Class A1 and Class A2 along the full system, including the membrane accessories. And one of a big advantage, we are able to achieve high tensile and tear resistance, especially on the breather membranes. It is a must. So we want to avoid a tear or a crack in our membrane, and we have this increment of quality. UV resistance, fully backed with CE marking and UKCA. The same on the airtight vapor control layer. We are able to build an airtight system and also vapor, blocking the water vapor transmission, Class A1 and Class A2S1D0, combining all the fixing and sealing accessories. And the big advantage, the second big advantage is sustainability. Such a great topic today, and it's obvious that we need to change the way that we behave, especially on the construction. And the products has achieved BREEAM exemplary level, AMI code, and LEED 4.1. Now, as a whole, because this is not coming on the technical data sheets, DOPs, and particularly documents, but it's an advantage that having externally and internally a big advantage of having fully compatibilities assessed. So, and again, it's a matter of simplification, predictability. We are using the same methodology, the same fixing accessories inside and outside. Then it allows us in a project that we are one source, comparing with different sources, but because this is real. Sometimes on an interface, we have 3 products applied from 3 different companies. But this allows us to have one source. We are able to have one weatherproofing design with architects working on the Riva stage 3 and 4. Then we follow all the tender process, and we are able to, sometimes 1 year and a half, sometimes more, to have one quality control. We are able to have a benchmark quality control and integration at site. And then resulting in bill insurers, one project warranty, and resulting in one future-proof solution. This slide is really important because it gives us an overall summary about what we believe that we need to meet the requirements. We need to have a product, a system that it's complete. We need to be well tested, approved by independent organizations, certification bodies, and needs to work in the end of the day. And what means complete for us? Means that we have all items necessary to meet my application. So we do need to have not only a membrane. To be honest with you, a membrane is a small piece of a big puzzle. So our experience shows that we'll have a lack of efficiency not on the membrane, it will be on the details. So it's really, really important that we have the membrane along with all the fixing and sealing accessories fully compatible with different substrates and UK different products. A little bit more visually, we need to have a reliable sealant on EPDM membranes. We need to have different types of solutions depending on the perforation that we have on facades. We need this is a VCL application. As you could see here, we have rainwater pipe, mechanical, electrical, plumbing on the bottom. We have ventilation, and by the way, we have concrete on the bottom of the slab and on the top of the slab. And concrete, as you know, it's one of the most difficult substrates to adhere. Especially on the bottom is rough, is porous, and it's irregular shape. And as you know, we have the slab deflection, we will have differential movements. Then we, for sure, will have a peel-out adhesion failure in these locations. And then on the connections between the membrane and the slab on the bottom and on the top, we will lose efficiency. This is why this is so important that we have a complete system that again is tested, is reconfirmed. It's a matter of confidence. And on fire, EN 13501, and again, it's not the membrane, it is the overall picture. We felt that we need to assess the performance on fire, fixing tapes. We need to have completely exposed to the fire. We need to have perimeter sealing tapes. You know, we have a membrane overlap at sites. We need to expose. And by the way, as you see, we have plenty of perforations on our facades. What we did on the last slide, we exposed 2 bits horizontally, 2 bits vertically, in order to understand, do we have propagation? Do we have propagation horizontally or vertically? And with confidence, no, we have achieved the worst case scenario, the most important, replicating the end use application, class A2 S1 D0. And it's important, I'd like to highlight this to you. EN 13501, it's a classification report. So it's where it's mentioned the fire class of the products, but please, when you are choosing a project, when you are specifying a project, when you are installing a project, ask always for the complementary test report. This is where you are able to assess and you are able to understand if the products are replicating your end-use application. It's also important, we decided to bring this slide. It's all important to have data and fire tests. It's American standard test. It's a steel tunnel, half a meter, 7.5 meter long. It's replicated a fire, and we have achieved the highest class again. So as you could see on the left side picture, the fire black on the part that it's replicated. On the bottom, we have no propagation. And I think this is what is most important when we are in a fire. So if the fire happens in a flat, on a balcony, it will be there. It's a matter of compartmentation. And again, sometimes we are involved on full-scale BS 8414, and a picture that shows, this test measured the capacity that a fire in a specific level or a floor will re-enter in the next level, okay? So, but you know, as a summary, what I believe that it's really important is to test and retest and collecting data and make sure that our facade will behave, that our facade will perform in case of a fire. It's also, it looks like basic, and it is, but it's really important that as independent organizations, here there are some of them that assess the testing, that they are independent certification bodies. And we'd like to say that we are still the product that we have, that we combine externally a breather FR membrane system, the overall system, and internally the airtight vapor control system, UK CA as well. Really, really important in 2023. And then in the end, we have this confidence that the material works. We could be complete, tested and approved and certified, but then it doesn't work. But we have this confidence, London, UK North, that the material behaves, so the material perform. And wrapping up today, we need complete systems that they are well tested, replicating my application, my project. It's approved by independent organizations, and it works in the end of the day. And today, it's really now good news and a little bit of action. We Ephesus, I'd like to say this today, and it's really a proud to say that. We developed Ephesus Breather FR externally, is done. We have developed internally Ephesus Vapor FR membrane system, and now we have the solution. We close the system. We have the solution for interfaces, construction joints, and again, the technology is ready, is available. So if you allow me.
There is a major incident, Grenfell Tower, W11-1WH at the moment. The entire emergency staircase is alight.
What I'd like to say today is you don't need to compromise anymore your project, your design. And we will be soon, we'll be doing a private event, and for further information, please register yourself outside. And to finalize, I'd like to say that, and to be honest with you, so if there will be always architects and engineers that will choose something, there will be always, and then there will be professionals that will choose future-proof, that will choose protect the end users and protect your and your company liability. Thank you so much. Have a nice day, and share your views outside. Thank you so much.
Thank you, Miguel. Thank you, Miguel. Yeah, very informative presentation. Thank you, and great range of products. So we are ending the track B this afternoon with a great panel discussion. It's about Passivhaus project in Battersea. He doesn't need any introduction. He's going to be the moderator, Thomas Henriksen, and who will introduce then the rest of the panelists. Welcome.
Thank you very much.
Thank you.
Thank you. So thank you for taking time to come tonight. Thank you for Zak to allow us to come and speak today. I wanted to introduce the panel really quickly. First, Angus Kieran from Urban Est. He's the developer developing this project. Building it. Does it work?
Try that now. Thomas, do you want one of these? This does work.
No, it's the same one. Can you hear me?
No. Okay. So I'm going to swap it out for this one. That's okay.
No, I'm just taking it out. Yeah, I'm sure. You can hear me now. Okay.
He's always delaying the projects.
Sorry?
You're always delaying the projects.
Yeah, I know that, Angus. Thank you very much. and then Megan from our studio. Before we start, I just wanted to maybe introduce the project, and also one thing I want to say to everyone is that we are in the midst of building the building at the moment, and the reason why Zak has allowed us to come and present today, of course, is because it's so important to show that you can build energy efficient buildings. Yeah? So just a bit about. Can you see it? Yeah, so this is the Urbanest Battersea project. It's being built very close to the Battersea power station. And it consists of 4 buildings, and 3 of them are student accommodation and 1 of them are offices. As you can see them here, and I think Laura will maybe explain better about the intent of the facades, but just to give you an idea of what we're dealing with and the sizes of them. This is the main entrance. It's all clad in terracotta. And you can see a lot of work has gone into have a very important architectural expression. This is a bit of the footprint. Then I will leave it on to the panelists. Can we maybe get back to the other slide? To them that maybe is unfamiliar with passive houses, it's about building very energy efficient buildings with a focus on low heat requirement in the buildings. And I think we will go through this a bit. I'll start with the first question, Angus. Why do you want a passive house?
I don't know why you're asking me that, because you told me to do it, but it was... it's a bit of a whirlwind when we found this project. It's 860 students. The drive in our company is to go for sort of net zero, like it should be for all of us, and it seemed to be one of the ways to do that. At the same time as thinking about all that, I was actually coming back from Spain, and there's an article was saying that London's going to be the same as Barcelona heat-wise in 10 years' time. So we had to think about the comfort of our students in buildings. I don't know if anyone's been in student or understood student accommodation, but it does get very hot because there's just so many people there. And students do have 25 computers in their room heating up the building. So we also at Urbanest drive to sort of re-educate the students to not think about waste, but we try and get them to think about recycling. And I think that was a massive drive, because actually the biggest waste that we all do, certainly in student accommodation we chuck all this heat away and all this energy away out through the facade. So let's stop doing that. So that all came together, and I mentioned this to Thomas over a beer, and he mentioned, well, that sounds a bit like Passive House in bringing comfort to the student or our tenants, but also trying to drive to that net zero target that we're trying to get to, and making the building much more robust, really. And yes, and then I got a little bit of a heart attack when the cost came in, but that was driving it. But I do look very clever now, because obviously with the energy prices going up, my investors are pretty happy that we're going for this approach. But that was really why we thought about it. And I think we're very looking forward to it opening in 2024.
Thank you, Angus. And I think it's some very important comments, to make about also, the importance of meeting net zero carbon. Just going to Laura, you being the architect, we sit as engineers, and trying to force this requirement, on the architecture. So, when you have this passive house aspiration, how did that influence your early designs? And also, how does it tie in with the brief? Because there's a client brief as well, which needs to be met, at the same time as meeting these very stringent requirements from Passive House.
Well, sorry, it really does impact the early stages, Passive House, because we need to think in a slightly different way. So we need to bring forward a little bit the details to the early stages. We need to start thinking of all the requirements, all the performance we're going to need to achieve. And it's very important that we are all on board and we are all taking that into account from day one. So when we were designing, for example, the facade, we were considering all the performance we need to achieve in terms of like having a very thick facade. We had to do a lot of research on how to play with the depth of the facade, where to place the glazing, how to work with the shading, how to protect the rooms depending in which orientation they were. So all those ingredients were taken in board like since early days. So I think that had a big impact, as well as, for example, how to tie with the client brief. I think we have tried different projects to do Passivhaus in the office, so we had a little bit of experience, but we thought it was actually the right moment to do it for this project. Like there was an appetite in the market, the students were really demanding these sort of standards for their buildings. They are more and more aware. So yeah, I think it all tied on really well, but I think the key thing for us, it was to have everybody on board and on the same page since day one, because there was a lot of collaboration with yourselves, and for every little decision, there was like a round of like consultations and agreeing everything before going to the step after. So yeah.
Do you think you had to compromise your architecture, or do you think the architecture?
No, not at all. I think it was just we had more ingredients to play with, but it actually helped to inform the design. So it was not at all a compromise.
But I think that's very important, you know, that you can actually build architecturally pleasing buildings at the same time as putting very high energy requirements on buildings, you know, because, you know, this has always been, you know, you can't build a passive house as a square box, you know, but I think combining these two things, and we'll see more and more of this in the future. Just moving on to the next question, and this is, you know, the commitment, and how do you think that, maybe to both of you, did that influence the planning decision, you think? Did that help get it through planning? And where are the councils in London at the moment? And also the next one, which is more difficult, and maybe I mentioned TM59, you know, the challenges there is in the current legislation, the BREEAM, which is a planning, how do you say, requirement, and some of the things that counteracts what we are trying to do.
I think Passivhaus isn't. I mean, everyone. I mean, I think it's in the press and people know about it in the planners. But when we went with the word Passivhaus, it wasn't necessarily a condition that they wanted to put onto the building. But Passivhaus is more than just the word Passivhaus. It's all the parts coming into it. So certainly the energy assessment blew them away. You know, there's no carbon offset payment here, because I think I don't know what it is, but we're sort of 40 or 50% down from that. So we're way down from anywhere we would have been. So I don't necessarily think it was the word Passivhaus necessarily. I think the Passivhaus Institute have got to do a little bit more marketing for themselves within the planning departments, but certainly everything that came out of Passivhaus. And I was sitting at actually presenting at Battersea Power Station to some local tenants a couple of weeks ago. And I was sitting next to the local councillor. You might have seen him on telly complaining about Battersea a couple of weeks ago when it opened. But he was saying, look, if I knew about all of this, you know, really technical detail, which I'd been talking to him over a cup of tea, he would have been absolutely much more supportive of the scheme. And I think the Passivhaus Institute need to up their game a little bit, marketing within the councils. But so I'm not sure the word Passivhaus Institute, but the actual design principles absolutely did along the way. So it's the right thing to do. I think the borough now are extremely proud of that. You know, it's going to be one of their first carbon neutral in operation buildings. So I think they're very much looking forward to it.
Do you have a comment, Laura, in terms of, you know, because you were sitting there and discussing with the council and making sure that they're getting the message across to them, you know, what are we trying to do?
No, I think it was very well received. So as Angus was saying, once they understood what we were trying to achieve, they were all very positive. And actually it changed a little bit their mindset, because they realized we were delivering a high quality building and they were really on board with it. So I think it was all positive. It was also the first building of a series of developments that would happen in the area. So for them to set up a precedent was very important as well, because then the buildings following our building will kind of follow as well on the high sustainability standard. So I think that was also a key element.
Yeah, please, Agnes.
Sorry, you asked about TM59 as well, which is, you know, I got quite upset about. But I think somehow the GLA need to change that, because the drive to zero carbon, i.e. closing the facade off and having no heat go out of it, or no energy goes out of it. Obviously, it does heat up with the energy coming into it. But the way this building works, we have air conditioning, but the air conditioning pumps all of that energy back into the hot water. So actually the heating up of the building is a good thing for us, and it saves a lot of energy. So you know, that's the comfort we're giving back to our students. So it's quite important. And I think once this technology sort of gets, and it's going to be everywhere, certainly in residential, I think the GLA and different authorities need to start thinking about that, because there's a lot of head scratching there, as you know.
And maybe just to explain to everyone, TM59 goes in and predict how hot London's going to be in the future, and put restriction on, you know, how many days you can have where it's above, I think, 26 degrees. And that, if you build traditionally, you would put low G values on your windows, whereas what we're doing the opposite. We are dealing with the heat by actively cooling, but very short amount, and then we get the heat gain in the winter. So we're switching the windows, but the TM59 kind of fights against passive house, and what you really want is like the heat gain in the winter. Just let me move on and ask you, Daniel, about this is your first big passive house project. I'm sure you've been on other smaller projects, but how have you approached the passive house requirements, and what measures do you have to put in place to kind of try to meet these requirements?
Yeah. Okay. So I think, from a contractor's point of view, it was a really steep learning curve. I think that's evident in the conversations we've had in the past. I think we've had to consider how we procure all of our packages, including design and design services from our consultants. We've had to put additional resource into the project, particularly a passive house champion, and that's something that we spoke about very early on. So we've taken a lot of advice from you guys and from others in that regard. We've had to undertake almost an independent kind of verification of the design to make sure that we are satisfied that the work that's coming out of the design team meets the requirements, because it's new to us. We've got no kind of internal expertise, or we had no internal expertise when we started. We've had to reconsider how we procure things like testing. We've seen scope increases in terms of the quantum of testing. We've had to think about additional training for our team, for the designers. I know you guys have got that knowledge already, but we've had to share that across the wider team. We've had to increase the training or add training requirements in for our supply chain and delivery partners. We've had to bring resource in to help monitor and manage the quality on site. So that's different from kind of our dedicated passive house champion, but it means upskilling our whole team to make sure that we can, find potential problems with quality on site before it becomes a genuine problem in terms of overall performance. We've also had to consider the extent of temporary works associated with the additional testing requirements as we test as we go, to ensure that we are achieving the performance before we do the whole building test. So look, it's been quite a challenge, I would say, and I think we've learned a lot from it, and we will continue to learn a lot from it as we deliver the job. So ask me in a year's time, there'll be more to add to that answer, I'm sure, but at the moment it's been quite a significant change for us.
Just a quick one, maybe. Can you see, delivering a project like this? Can you see how does your team members, are they proud of this, and how do you make sure that you kind of, because it is tough, and we all know this, and we come with all the compliance requirements, but how do you make sure that you keep engaging and put positive into your team?
I think, as Mace, I think we have a bit of a reputation of delivering difficult projects and challenging projects. And I think this, not just because of the passive house, but generally I think this kind of falls into that category anyway. I think all of our team were really excited when this project landed with us. And we've talked about other projects as well in the past. And to try to deliver Passivhaus and to achieve Passivhaus, that's the objective, right? On a project of this scale, fits our profile anyway. It's where the business was founded, actually, 25 years ago, whatever it was. All the people I know on the project are committed to delivering the outcome. There will be challenges along the way, and I'm sure we will have conversations about how that plays out. There will be, I think, discussions to have with different approving authorities, or we know that already, in terms of potential conflict with BREEAM, for example, and other planning conditions that we've identified. But I think the whole team are committed to it. It's an exciting opportunity, and I think you mentioned at the beginning, Thomas, we've got probably a moral duty to deliver better quality buildings for all the reasons that we know about, and this is an opportunity to start on that journey. And I also think that actually, I know we're seeing other clients come to us who are asking the question about Passivhaus. They're not necessarily committed to it yet, but they're asking the question. And the fact that we're going through this process now means, I think, that we have more knowledge that we can offer them during those early stages.
Thank you. The next question I want to, this is because we are in the midst of delivery, so most of the things, it has been ordered, it's being started to be produced. And I think, so my next question to both you and Megan is about, how do you deliver a Passivhaus project at this scale in terms of compliance? What do we need to do to make sure that we meet the requirements in terms of this compliance? Because it's not just, and I think maybe to say this is the most important thing about Passivhaus is that we really built what we designed, and we need to prove that we built, that we deliver what we designed.
So my answer to that would be to check with Megan that we're doing it right.
That is the correct answer. No, as the Passivhaus consultant, it's really about getting organized. As I say, Passivhaus, what it does is it minimizes the performance gap between design and build by a very rigorous collection of information, both as design stage, and then when you build, you do a very rigorous evidence collection to make sure you have built what you've designed. So on a building of this scale, that means getting really organized, and we've done actually a lot of automation where possible, say how we analyze thermal bridges. We've done some great work with Mace about how they might collect evidence in a smarter way. So that's definitely an element. And we've already mentioned airtightness is really the big one on Passivhaus, and getting organized and ahead of the game on that. And lastly, I'd say it's getting down to the detail while keeping an eye on the bigger picture. You always have to keep coming back and looking at the building as a whole. We know we have to be practical. This building has to be built, and we have to find solutions for that. Things will change, but we've got to be always going back and looking at the overall building and seeing where we are.
There's a piece you touched on there in terms of getting into the detail. I think one of the things we need to do is understand the detail much sooner than perhaps we might on, I was going to say traditional design and build job. This is D&B, but that really affects the way we procure our design, I think. And if any of you have kind of worked with me in the past, you'll know I bang on about this stuff quite a lot. But the devil really is in the detail, and the earlier you understand that, the better, because it's easy for a contractor to defer the appointment, particularly of CDP packages, but that's counterproductive to getting the design to evolve at the right time to ensure compliance at the right stage. And one of the things we did quite intensively at the beginning was understand the scope of how we procure the design services and from whom we need to get those services. So in terms of focusing on kind of design responsibility matrices and appointments for designers across both consultants and subcontractors, I think a really kind of forensic focus on that to make sure you've got that balance right with specialists to understand what the Passivhaus requirements are is fundamental.
Thank you. And I think it's an ongoing process. This about, how do we check? How much do we need to check? And I think especially for the airtightness, how much do we need to airtightness test? We are learning more and more. The more we do test, we get more and more experience. And I think this is the work in progress. But maybe to say this to all of you is that airtightness is really a big thing, and thinking in airtightness early on is really important. We did together with the facade contractor and also the system supplier a very good performance mock-up test, and it came in significantly lower than what we anticipated. But I think it's very, very positive. Just another question is this about and then this to all of you. what are the biggest challenges in delivery? Maybe both from your side, Angus, but also from the rest of the team. And what do you see as a client that you kind of,
I think challenges, it's new, and getting everyone to buy into that new. I have to say we picked the right contractor. We picked Mace, and Daniel is actually head of all design at Mace, not just project director. But so that was pick the right person as well. But you need the right contractor to buy into it. But everyone's got a little bit of nervousness, so there was a lot of discussions around the appointments and bits and bobs like that, and with yourselves, with everyone to take responsibility for it. But I think what you just have to have is a team who want to do it. I mean, given what Daniel said, and the team on site are really getting into it. If it doesn't quite get there, then we'll work through that together as a team, and you have to have that. And once that sort of bit more trust got into the team, it sort of everything flowed really well. So I think that was up front. It was just that just getting everyone on board, which was certainly my challenging bit, frustrating at times.
And for your side, Laura, the architectural side.
Yeah, I think for us it was a little bit, as you mentioned, it's something which is relatively new. So there was not a knowledge within the team in particular about what did it mean specifically to achieve Passivhaus. So we were lucky that we got like we have a sustainability team within the practice, but we also have a Passivhaus champion within the team that was giving us some training at the beginning. And I think that was really very positive, because once everybody is on board and know what they are doing, it's much easier to achieve the goals. But I think for us, the main challenge at the beginning was a little bit, that was like the first project we were delivering in Passivhaus. So it was quite new to all of us. So I think it's probably very important to, I mean, not only for the architect, but for everybody to get a little bit of a specific training at the beginning and understand what are we trying to achieve.
Yeah, I think to echo kind of what Angus was saying, I think from our perspective, the biggest thing is making sure people understand. And when I say that, what I mean is, I think everyone understands the principles that apply to Passivhaus. You say airtightness to someone, they know what that means. But the way the standard has to be applied to a Passivhaus is a little bit different. So understanding the flow of information that's required and getting everyone to collaborate in the right way, rather than assume they can defer their involvement, or if you, heaven forbid, get an MEP designer that doesn't think he's got an interest in kind of airtightness, for example, even though he's got a connection at penetration in the facade, getting all those people to the table at the same time, understanding the flow of information, getting that collaborative environment to work properly is a challenge, but it's probably really important as well.
And maybe just to say this, on a large scale Passivhaus, the airtightness need to be, at least, I don't know what you are delivering at the moment, depends on what the building you are, but we need to deliver 0.6 meter cube per hour per meter squared. The current, as I understand, the current building regulation says 8. So there's a quite far distance to get from there and then down to what the requirement is on this building. And Megan, what do you see as the challenges, and the biggest challenges?
Yeah, I definitely second everyone saying it's about everyone having the mindset. Having a Passivhaus consultant, we won't be able to see everything on a building of this size. There'll be conversations wanted in. We need everyone to be on the lookout for things that could affect the Passivhaus certification. And I'd say also Passivhaus, we're doing one of the largest ones, I think definitely in Europe potentially. So we also have to push the Passivhaus standard. It hasn't always been used in this way before. So there's work we're doing with the certifier as well to push the standard further.
And to speak to the PHP, the Passivhaus organization, and because exactly there's very few buildings of this size. Yeah. Just a question to you, Angus. Maybe we can get the mic down to, and this is what everybody asks for is probably what are the key benefits compared to your existing buildings?
Costs a lot more.
Does it really?
Yeah, I mean, I think it's hard to know about. I mean, we've got nearly 4,000 beds already. If you compare it to that, the cost did. Certainly, the facade is more expensive, without any doubt. But the benefits really, I mean, it's the obvious one, isn't it? It's energy. I mean, every building that we're in is having problems at the moment with energy. I mean, one of the things we've all got a problem with is these models that we have to do, these energy models. We don't really know whether they work or not. We don't really know. You compare them to what you're actually building, so you don't know. But the models are telling us that we're going to have an 80% reduction in energy usage in the building. On the top of that, we're getting air conditioning for our tenants. So, and that will be the only air-conditioned building in the UK for students. It's an extraordinarily environmentally friendly building. So we believe that this, schools, I'm sure everyone's children here are being taught about green issues within their schools, and as they come out of the schools, from a marketing perspective, I think parents and the children will want to come to our building. So that's a massive advantage from that perspective for filling this building. And you've got to remember, we have to fill this every year. For the rest of its life, we keep our buildings. We don't sell them off. This building will be in Urbanest's company for the next 100 years, whatever it is designed to do. So the benefits just really comes down to the energy costs. And again, it was I think when we started the building, it was 28p a unit, and now it's up to God knows what a unit we haven't spent. So that's the big, and that comes directly off the value. Or puts the value up effectively, because cost of a building that goes into appraisals, and that's difficult. But that's the big one. But I think the other one is the marketing of people. They're going to want to be the kids of 16, 17, 18 that come to the building will want to be in this building over other student accommodation, and that goes to the universities. I mean, we've got 5 of the best universities in the world in London. On the league tables, and they want to know that they're going to the best unit. They want the best accommodation for their students, and they want that, and it really does bring their reputation forward. So there's some big bonuses, and I think the older student accommodation in the country will have to change. I mean, it'll have to change because the universities and the children just won't want it.
But can you see the change in energy prices? The change in energy prices, does that influence your return on investment, for example? And it must have an influence.
Oh, it's direct influence. I mean, it's direct influence to the NOI. I mean, you have rent and you have costs, and that comes off your NOI that you can effectively pay back to your business, and therefore the valuation of the assets. So yes, absolutely, I mean, it's a direct consequence of how much money we make, and then how much money we can get investors to pay or increase our business. So yeah, absolutely. And I think the other one just to think about is also this building has one of the first green loans, large green loans in London. So, and that loan was I think it was about 20 basis points off the loan was taken off because it was a green loan, which again, that's cheaper money. So there's lots of benefits to it, but within the appraisal, it does cost more.
So my final question maybe to you, Angus, and I don't know how much time we have left, but would you consider doing it again? We've been on this track now for 3 years, and it's as you know, it's been difficult because there's not many of these already existing. Definitely not in the UK at this scale. Definitely not in London. Would you do it again? I hope you're saying yes, because that's a bit important.
Otherwise, you haven't got a job anymore. I think if I go back 4 years and know what the journey we've gone from now to, from then to now, I don't know that I'll do it again. But now I've got the rule books, sort of, or Daniel's writing them. Now we know how to do it, no doubt. And I truly believe the GLA is changing to the energy performance that these building anyway. So in 5 years, residential is going to be doing what we're doing anyway. I don't know if they'll go all this way, but the energy performance of the buildings has got to go. I think 2050 we need to be carbon neutral. Well, or 30 is it? I'm not sure, but Britain is taking it forward quicker than most places in the world, and I think the GLA within London certainly is going to change to that. So this is going to be the normal building certainly in 10 years, but maybe it might be quicker than that anyway. So the answer is yes, and as you know, we're doing it already.
So thank you very much. I don't know how much time we have left. Do anybody out there just have a single question you want to ask? We've been working on this very hard for the last 3 years, and also pushing the boundaries because, there were so few buildings in the world that has done this. We were counting 4 or 5 or 6. And also applying it in London is another factor to the whole equation. Do anybody have any questions they want to ask the panel? Just wait, there's coming a microphone.
Sorry, just to ask if how transparent are you intending on being with the sort of post-occupancy evaluation information, which would be fascinating to see.
I'm sure Thomas will tell everyone about it, but I'll pass this over to him.
Yeah. So, transparency in terms of sharing everything that we learned or that we achieve Passivhaus at the end of the day. So that's actually for Angus more than me because it's not my building.
Sorry, didn't quite understand the question. Absolutely, no, we'll be broadcasting it from the rafters because we want to educate others to do it. I mean, one of the reasons we're here is we've got the new generation of all of us here in our buildings, and we do have a massive opportunity to teach them something. So yeah, we're the point. One of the things in this building is we're working with the marketing people to put every single little bit of information that's coming out of the BMS systems, and the BMS is huge on this building because it's coordinating it, and it's going to be broadcast to every student, every university in London. Because we want to fill our buildings inherently, but we also do feel that there's 850 children becoming adults in there who are going to become the next environmental people, and the more we can tell them about this sort of stuff, then the better. So yeah, I mean, it'll be we're certainly not hiding it away.
Then I'd like to say thank you to you all for taking time to come today and share. We are still work in progress. If anybody want to go, they could go to down to Battersea and see the building is already in construction. So thank you very much for your time.
Thank you all. It was a great panel from different perspective on one of the largest European Passivhaus projects. Now there is going to be a coffee break.
No, mementos for speakers.
Okay, yeah, memento for the speaker for the photograph. Yes, of this session only. So. Sorry?
First one is Peter Jackson.
Yeah, first one is Peter Jackson. If he could come on the stage, please.
If you've got their artistic skill. But it all goes together very simply, and it's sort of based on the steel colour and sort of format, but you can see the link back to Kyoto very clearly. And the way that building works is the panels just do what they need to do. So you've got clear glass, you've got opening glass, you've got a door, things just effortlessly drop into that system and work in a very understated way. They then infuse that with the connection with inside, outside, and all their beautiful objects. And I work at Hopkins Architects, and Michael and Patty Hopkins built this house in a similar vein in Hampstead. This is different in that they didn't literally buy everything off the shelf. The sides and the top are metal. The two end walls are glass. You come in on the first floor. And they used a very sort of similar idea, which goes back to Kyoto, of a 2-meter grid. It's a very small structure on a very repetitive bay to give some character. Wonderful house. I'm now going to jump around in time and go to a building that just absolutely stupefies me. This is the glass house at Beckton. No one quite knows who designed it. It was probably put together by a firm of glaziers who used this patented section that held the glass panels together. And what I find amazing about it is it's a building that's sort of been designed by the facade and almost doesn't have a structural engineer involved at all. You'll notice at the back there's a wall. And being a hot house, this building faces south. It's in Britain, in Devon. There's a stone wall at the back, and it's built off that. They worked very hard to sort of make the shape in the science of what they thought would get warmer, which is why it's not spherical. But the way that detailing works and the fact that the glazing bars just become the structure and hold the whole thing up is absolutely amazing, technically. I mean, just, you know, would any of you want to make that today? I think you'd be struggling. And it's still standing from the 1820s. So there's a lot of stuff that was happening a long time ago that was really pioneering technically, and the modern movement, and we as architects and you as builders and contractors and everyone else, engineers, we all came along and appropriated their inventiveness. And this is an example. This is 1932. We think of this as avant-garde, but that previous building was 112 years earlier. This is Maison de Verre in Paris, which was using glass blocks, which had been patented in 1866 or thereabouts. And just a very beautiful assembly of metalwork frame, glass blocks, which give you a degree of insulation, don't they? And this sort of interesting translucent facade. And then they dropped in little opening lights that gave you some visibility to the outside. So based around a courtyard, really quite a charming modernist project. I'm then going to just up the scale a bit and take you to Liverpool. This is Oriel Chambers by Peter Ellis. And no one quite knows exactly whether he was a surveyor or a builder or what, but this is another remarkable building. So people talk about this as being the first curtain wall, in that it's a sort of somewhat detached from the structure. The stone you're seeing there is just elements of cladding, and they run with an I-section beam up the centre of them and have a sort of unusual way of finishing at the top of the building. It's called Oriel Chambers because we've got these Oriel windows, which are little bay windows with incredibly fine metal corners and an opening panel at the bottom there. And so from the inside of this building, which just has a corridor from that door straight down the middle, you have daylight on both sides. It was small offices that would be rented out to commercial businesses. So they wanted lots of daylight. So for 1864, a really remarkable building, lots of expression, lots of daylight, and sort of amazing clarity of engineering and facade. And on the back of it is this remarkable facade, much less expensive and showy, but he used these glass panels above the bay window just to get more light into the space. So 1864, I mean, remarkable. And from that kind of rationalization of the facade leading to the whole project and showing you the way to develop it, we've got Mies van der Rohe's Seagram building in New York. I'm sure you're all familiar with that. I think you can see that kind of unitized facades, all those things have grown out of this rationalization of the process, expressing the elements, again, just simply clipping the glass in and using the sort of wind post to become the architecture. So as we move forward, things are being stripped out and the purity of the facade, the transparency is becoming the expression of the architecture. And that all really, you know, reached an absolute peak in 1851, the Crystal Palace, which was just, you know, it's a shame it's not there, isn't it? We could all marvel at it, and it would be a wonder of the world if it still stood. Absolutely incredible rationalization of the process, not only of making all of that glass, but the way it was assembled, the engineering, the inventiveness of the way all the beams fitted together, just to speed up the process, and the little devices and trains and things they used to assemble it was a sort of work of genius in itself. And a bit like Beckton was, you know, an incredible, brave, pioneering spirit. You'd have struggled to get PI insurance for that and convince your backers it was a good thing to be done. We couldn't probably do it now for all those reasons, but it is just absolutely remarkable that all that kind of clutter of architecture had been stripped away, and here is this glass palace. Amazing. And I think if you look to where that ends up in modern architecture, I'm going to jump to Ipswich, Willis Faber building by Norman Foster with Michael Hopkins. They were partners at the time. And this sort of dematerialization of the facade, this is the modern representation of that with Pilkington's planar fixings, just holding those panels together. A sort of intoxicating vision of modern architecture at night. You know, the inside of the building becomes the architecture. There's just nothing there. And in fact, the rendering by Helmut Jacobi, top right, you know, I think the final facade's actually got less structure in it than they even envisaged when they had their scheme design there. So It's probably not that warm. It probably gets quite hot. Probably uses quite a lot of fossil fuel. But an amazing image, and also architecturally quite a difficult building to put a door in. How do you kind of get through that? So, there have been, as I said at the start, it's non-linear. So, 15th century in Cambridge, King's College Chapel, people were trying to do similar things out of stone, remove material, make the building as transparent as possible, as awe-inspiring as possible. And the largest fan vaults in Europe sit at the centre of this absolutely amazing structure. You can't really say who designed and built this. It was an effort by many over centuries, but clearly the original vision and the kind of clarity and sense of purpose is absolutely singular. And I think, the way that stone works, it has to be in compression to get forces to the ground. So you've got big buttresses on the outside, you've got pinnacles to increase the downward load of the structure so it can stay stable. That allows you to remove material in the side walls and make these really quite amazing openings. Interestingly, when you look at that stained glass, each piece of glass is very, very small, but it's broken up, it tells a story. I mean, a complete synthesis between architecture and sense of purpose, and the facade is all part of that. And I've put this Hopkins project in because it was very experimental. It's in Cambridge again, and it's a load-bearing stone building we did out of Oolitic limestone to match the Wren Chapel next door. And what we did, instead of having buttresses and pinnacles, which are certainly not part of the modernist canon of architecture, we post-tensioned those columns with stainless steel rods and put the load on those of about another 8 piers weight equivalent above. That takes out the lateral loads, and we then use the concrete slabs inside to shrink and put the arches at the end under kind of post-tensioning. So very sort of sophisticated engineering by Bureau Happold. The facade itself is panels of ashlar, express piers, which are, exposed on the inside and the outside. So what you see is what you get in terms of structure, and then insulated panels of stone in between. And as we talk about carbon and the benefits, you can cut stone out of the ground in low carbon terms, and if you can use it like this, all to the power. So the stair tower there, inspired by the Maison de Verre. I'm now going to go, in terms of stone, to another absolutely remarkable building, probably one of the most remarkable buildings in the world in terms of its history. This is in Sicily, in Syracuse, in Ortigia. This building existed on the site in about the 5th century BC. The Temple of Athena, which you can see there with those Greek columns, was from 70 BC. And the building has withstood an enormous number of changes over the years. So on the left there, you see the walls of the Greek temple, the columns. On the right is the inside wall of the Greek temple. And then switched to top right, it became a Christian cathedral in the 7th century. That space then became a monastery with the Arab invasion. It was then in about 1085 converted to the Duomo of Syracuse. And then in 1863, there was a massive earthquake, which it mostly withstood, got repaired. All the time, those Greek columns are there. They've been built into the fabric of a mosque and a cathedral. And when you talk about long life, loose fit, this is the building that eclipses all others. And then to cap it all, in the 17th century, this Spanish Baroque facade and entrance was put on the front end of the church. So, building with stone, kind of incredible masonry, and what an epic story. And just in terms of sort of longevity and learning from projects, I think the Sagrada Familia in Barcelona is an amazing project in that regard. Antonio Gaudi never really saw most of it. He had these incredible ideas, which were very rational, given the kind of imagery of the buildings he built, and that was to use a catenary structure and invert it. So on the top right, you see how he formed these arches that he flipped over, and therefore the stone was all in compression, as on the left. And he was fascinated with hyperbolic paraboloids, which are effectively geometries derived from straight lines. So all of those incredibly complicated shapes, like you see one in on the bottom right, have actually formed by straight lines. So generations of future kind of scholars and engineers have taken over. Mark Burry did a lot of work on it. A Kiwi and Arab are working on it now. And so it's become a kind of laboratory of experimentation in terms of construction, and absolutely, staggering when you go inside it. I'm now going to go to brick. I can't miss out brick. So this is another kind of lineage of the story. And this is an architect I used to work for who was based in Milan, who built in the Renaissance town of Urbino, in the Marche region on the east of Italy. And this is the main Aula Magna building for the University of Urbino. It's called the Magistero, and it's probably quite different to all the other buildings we've looked at, and it's not a pure building. It's not an object that stands there. It's been formed entirely by the void that was left in the town. And he has this kind of very complicated 3-level auditorium underneath that glass roof. And the way that works, it drops light inside. And actually, he just relegated the facades to pieces of the town, if you like. They're just modern interventions where he cut windows into it in a very minimal way. But nonetheless, it's an absolutely iconic building. If you're in the east of Italy, I recommend you go and visit it. And in terms of taking brick and elevating it to a kind of incredibly high status, you can't really mention that without talking about Louis Kahn, as Peter Barber called him, the brick whisperer. This is the Exeter Library on the east coast of the States, and he built this sort of monumental building, kind of playfully cutting away the corners and exposing the top and having a colonnade at the bottom. Built it in brick, meticulously detailed. Hopkins has inspired many of our buildings with the way those details go together and the piers reduced down and the kind of very rational approach to that structure. And what is particularly nice is the building has a concrete interior structure, which you can see there with a large void in the middle, but the brick becomes a very human place on the outside of the building. And actually you literally inhabit that facade with those little, he builds the 2 height spaces on the outside and then puts his little reading desk literally into the window. So you're between the bricks, with your books, with the light coming in, and you've got your own little window there. So a really charming place to study. So you can't really do this talk without looking a bit to the Middle East, and I've chosen one mosque, and I'm no expert at random, but I think this building is worthy of looking at in this kind of wider picture because of it brings ceramic tiles, puts them on the outside of the building, puts decoration on the outside of the building. And I love the way they play with the kind of inverted volumes on the outside of the building, something we don't do in the West at all. This building has an amazing stained glass window on that left-hand side as well, which gives you this rose-tinted light in that space. But I think decoration taken head-on and becoming architecture is something that the Middle East has done spectacularly well. In the West, we're less comfortable with that. And we have a few examples where decoration has become really important. Most of the buildings I'm talking about have been in the modern movement tradition, so have tended to strip decoration away, or we've used structure to form decoration. There are exceptions, and Louis Sullivan's sort of Prudential building is a classic case. This was, as skyscrapers were becoming possible, as we call them, this is an iron frame, and he was pioneering that kind of use of structure in giving really big, clear, open spaces, tall buildings, good return on investment. But at the same time, he was very comfortable working that facade as a totally decorated piece of faience and sort of ceramic. And so here you see this amazing image of the frame going up on the left-hand side. So there it is with the sort of bracketry and everything else. And on the right-hand side, that very top corner detail as he sculpts in those oculus windows and puts all the decoration onto the cornice on the top. I mean, I have no idea how those elements are held mechanically back to that frame. Again, your PI insurers will be getting very nervous about that, but absolutely beautiful and staggering piece of architecture. So as we move towards the end, I'm going to talk about the Beinecke Library by SOM, by Gordon Bunshaft at Yale. And this is a building where, in some way, that facade expresses what's happening on the inside. It's a rare books repository, so they have to protect the books from UV and from sunlight. And that building is made out, that facade is made out of 1¼ inch, 30mm slabs of marble, and then little cruciforms of granite which hold it together. So there's probably some quite nice conversation you could have there about metamorphic rock and non-metamorphic rock. But the nice thing is, as the sun hits that building, you get this incredible pattern on the inside, and the light is protected. Again, like many of the buildings in this series, not great U value in that facade, but stunningly beautiful. And just as a point of reference, I mean, this is Orvieto Cathedral. The window above the door there has exactly the same thing. Before they were using stained glass, they were putting slivers of marble into facades. So, stunning. 20 great buildings, you've got to put one of your own in, so here you go. This, again, just to make this point about a building expressing on the outside what's happening on the inside. So here we had a building which was all about the bicycle, the function of the bicycle, the efficiency of the bicycle, and we engineered it right down with the guys at Expedition Engineering. We had a cable net roof, and we sort of used everything in the building to have a real sense of engineering purpose and to remove everything else. So we had a very lightweight building, very efficient, but it also had to express about track cycling. So we had the dynamism and expression of the track. The track's made out of Siberian pine. This is Western red cedar, and we just clad that very simply on the outside, then had a ring of glass so you could see in underneath. So a slight link to the Beinecke in that the building is trying to tell you something on the outside about what's happening on the inside. And then 2 buildings to conclude, really. I mean, this is a, absolutely remarkable building, isn't it? Stunning kind of imagery, pop art. If you remember, the original competition entry had the floors that could slide up and down and be totally flexible. And it had all kind of imaginative pop art, sort of super studio images of how the facades could have screens inbuilt in them. In the end, it became a bit more static, but very colourful, very playful. But it sort of speaks of consumption of fossil fuels, doesn't it? Almost literally with all of this pipe work. So it was a wonderful moment, but we can't really do that anymore. So what should we be doing now as we move to the future? And I've chosen as my last building, this one by Foster & Partners, recently completed, which is a museum of Roman antiquities, so kind of quite nice looking back, looking forward. And this uses sort of structurally insulated rammed earth facade. And these walls have been used on various projects, somewhat experimentally, but I think they give a really beautiful finish, obviously low carbon. And whether the whole building is the lowest carbon, I'm not quite sure. There's quite a lot of concrete in the roof, but I just chose this as an example for what we need to be thinking about as we move forward. So you see there, these walls, they've got the same strength as sandstone, and it's typically a compressed layer, 12 inches wide on the outside, 4 inches of insulation, and 8 inches on the inside. And they suit very well this monumental architecture that Foster's managed to put together on this sort of epic scale with all these Roman remains on the inside. So that's sort of my 20 buildings. It's been a bit of an indulgence for me to look back and choose my top 20. Hopefully there's been a few in there that none of you have seen before. But I think just to summarise, architecture is an amazing thing, isn't it? And it's so complicated, and the kind of cultural connections and diversity of those buildings speak volumes. But I think as we move forward, it's quite easy as an architect to talk about great buildings from the past and from now, but I think we have to look around ourselves. Most of the stuff we've built is dross, let's be honest. And I think if I'm to implore anything, there's no one tradition we should be following, but we should all be striving for excellence. Thank you.
Thank you so much, Mike, for that. The next one is an interesting one for me, and I'm going to say it. I'm probably going to regret it, but I'm going to say I tended this building, and I was very, very sad when unfortunately we lost it to the competition. That sometimes you win, sometimes you lose. And when it comes to train stations, I feel there are some fantastic buildings around, and this is certainly one of my favorites. HS2 Birmingham Curzon Street is the building in the next talk, and here to talk about the project envelope, prefabricated approach and sustainability are 2 brilliant people. David Walker, Associate Director for Facade Engineering at WSP, and Max Fawcett, Associate Principal at Grimshaw. Please welcome them on stage.
Thanks for a great talk, Mike. I really support a lot of the sentiments in that explanation of simplicity, rigor, clarity in design. It's something I hope that we have been able to achieve with Curzon. Right, go back one. So this is quite an interesting opportunity. You're actually quite lucky because it's quite rare that we get a chance to talk a little bit more about the detail of the HS2 projects. I'm sure you've all seen the big picture stuff. There's a lot of information out there on the internet and on YouTube and on the HS2 site, but we're grateful to be able to be given this chance just to have a slightly deeper dive into what we're going to be doing at Curzon Street. So we're going to be talking about we were asked to choose three topics, and there's just so many things that we could talk about the building. Such a large project, but we decided to look at the timber roof soffit, the cassette system, the platform canopies. That's a modularization system, which is really a development of 2 other stations that we've completed recently. And then finally, we'll look at the photovoltaic story, effectively almost like building a small power station in the centre of Birmingham. That is effectively what's going to be happening. So, just to give you a little bit of context, I'll work my way through this really quickly. This is obviously a plan of Birmingham city centre. This station is half a kilometre long, so effectively, in a way, we will be extending the city centre of Birmingham by half a kilometre. So much more than just a railway station. It will be, I suppose, a coming together of several elements, a major new transportation hub, conventional rail at Moore Street Station, a new bus station, 2 new tram stops as part of the West Midlands Metro tram system, and a raft of development opportunities and regeneration, in particular towards Digbeth, which is located south of the station. In this area, is this working? Maybe the screen's too bright. Digbeth, which is located south of the station, so that's obviously on the bottom half of the image you can see there. Birmingham is really a hill town. It's the city core is sort of a slightly higher level than the rest of the city. This is a view. You're obviously looking towards the centre, so you're facing southwest. The new HS2 tracks are coming in around about 5.5 metres above grade on viaducts. So Curzon is partially a viaduct station, and at the end of those viaducts on the western side, the tracks sort of half burrow themselves into the hillside, into the Curzon slope. And what we have, if I can get this laser to work, it's quite faint, isn't it? On the right-hand side of the image will be one of 2 new entrances, 2 new concourses. So we have the western concourse at the top end and the eastern concourse, which will sit below the viaducts at the eastern end with its own tram stop. You can see the blue West Midlands Metro tram heading in there under the new viaducts. 7 platforms. And the stone building you can see in the centre foreground, that's Philip Hardwick's 1838 London to Birmingham railway terminus. That was the world's first intercity railway. So everything is coming back again to Curzon with a new intercity railway terminus, which I think is really fantastic. There's that 15-metre level change. So the central yellow band is where the platforms are slotting in a sort of a central slice. And really, I suppose, negotiating that level change is one of the key challenges we have on the project. The top image is the hybrid build design. That was a reference scheme which HS2 provided us with, and that was used as part of the parliamentary hybrid build process, part of the Act of Parliament. The sketch at the bottom half of the image is where we are currently. So you can see from hybrid build through to scheme design, we made a significant reduction in the footprint of the station, same number of platforms, same amount of facilities. And we also introduced 2 new public spaces, one on the west, which we're calling Station Square. That's effectively the gateway to Curzon. And the one in the sort of right centre at New Canal Street under those HS2 viaducts. And that also, importantly, reduces the chances of severance. So as I said, this building is almost half a kilometre long. So it's really important to create those linkages and those routes for pedestrian cycles and trams between one side of Birmingham and the other. I mentioned earlier conventional rail. There is another project that's happening right next to ours for Moore Street. What's going to be happening there is the station will be returned to what it once was before beaching reduced the capacity. Another 2 platforms reinstated, enlargement of the concourse. Two stations will come together, Curzon Street and Moore Street, with a very significant new public space linking them both. A little bit like St Pancras and King's Cross in the way that they come together in London. Just a view of that space, that public open space, below the HS2 viaducts on Curzon Street. On the left-hand side of the image, you can see Philip Hardwick's Grade 1 listed Old Curzon Street Station terminus. And you can see in the central ribbon, that's actually one of the platform canopy structures, which we're going to talk about in a moment. But as well as providing shelter and cover for passengers, they're also providing daylighting into the public space as well. Last of these introductory slides for you. This really, we call it the kit of parts on sort of a large scale. And a lot of what we do at Grimshaw's with WSP is really trying to get down to the essential ingredients of the building, absolute simplicity, absolute clarity of approach. You can see the platforms in the sort of bottom center there, 450 meters long with the eastern concourse slotting in under those viaducts. And then at the upper level, the main western concourse and the roof canopy. It's that roof canopy that we're going to go into more detail in the next section. So, station shed and soffit. So I'm going to give you a little bit of background to the structure and the scale of this. I think just going back to some of the comments Mike was making in his presentation, what we're aiming to do at Curzon Street is really give complete clarity of expression. So the structure is visible, it's legible, it's understandable. We're not using cladding where we don't need to use cladding. It's absolute simplicity. And it's specifically, it's these timber cassette panels. We're going to talk about it in a bit more detail with you today. That's another view from Station Square, looking down towards the Grade 1 listed original terminus. We have this expression throughout the project when we were developing it. We didn't want the engineering to be separate from the architecture. We felt that the engineering and architecture should and can work together. They're both sort of complementary disciplines, and that's something certainly that both HS2, but also interestingly that the city and the local people in Birmingham really responded to that, because this is the UK's, it's one of the centres of manufacturing and engineering. The structure is basically, it's a parabolic arch. It's tied at the lower level, which basically brings that steel diagrid into compression and enables that structure to work harder. So I think we're running at about 65 kilos a square meter, so very efficient. And this is one of those remarkable coincidences. We did an exercise in the office to sort of take a look at the scale of Curzon in comparison to other station sheds, and it almost exactly fits the Barlow shed in cross-section. So 70 meter span, 20 meters to the crown from finished floor level. We're slightly lower than Barlow's shed because we had to keep under what's known as the limit of deviation, which is one of the conditions that's imposed on us by the Act of Parliament. Fortunately, Barlow clearly didn't have those constraints. Now, before we get into the soffit, and I suppose profuse apologies to Ricardo Bofa, who I do admire greatly as an architect. I think he's done some fantastic work. And Terminal 1 at Barcelona, which is what you're looking at, is also a very great transport building. But there was something that we were quite keen to avoid, which was this sort of diaphanous treatment, the sort of brilliant white treatment you can get in a lot of interchange and terminal buildings. And just going back to an earlier project of ours, this is in Amsterdam, Bilma Station, Bilma Arena Station. What we achieved here, what we like to think we achieved here, was by using timber in the soffit, it gives almost an intangible warm quality, and it gives a variety of texture and play of light, which is really difficult to achieve with something that's so machined and honed as that type of ceiling, the sort of brilliant white ceiling tiles. And if one of those ceiling tiles is out of alignment or gets damaged in any way, it's really obvious. I think timber for us is a much more forgiving material. And we've also carried that through more recently into the work that we've done at London Bridge, which interestingly is also, like Bilma, is also a viaduct station. Diagrid and timber soffit, just down the road from Birmingham. Basil Spence was using that at Coventry Cathedral, which I thought was an interesting parallel. That's a view looking out towards the city. And at night, again, that warmth from the timber, we'll be able to uplight that and get a good ambient quality from that. There's a night view from the outside. One design principle is to keep all the services at low level. So all the lighting is dealt with down at concourse level. That reduces the amount of equipment we have at eye level, makes it easier, safer to maintain. And I'm just going to hand over now to David, who's going to go into a bit more detail.
Thank you, Max. Okay, so I'm going to talk a little about the evolution of the roof cladding, just a few highlights of what we've been doing, just to get from the initial ideas through to some of these renders that you're seeing now. So, the primary structure of the roof made up of two different size members. You've got your 750mm deep primary stills on the 36-metre grids crisscrossing, and then that's sort of filled in with 250mm deep box sections in between that. So our first studies was to look and see, how are those stills going to be aligned, and how we then, what solutions can be proposed for cladding that. So we first considered the 700s and the 250s to be aligned on their bottom surfaces. And then what we've done there is we've proposed that the standing seam roof would be at a consistent level, which requires a lot of additional steelworks and upstands to those smaller beams. And then we have the timber soffit underneath, which runs at a consistent level, as again in between those members. Obviously, there's a lot of wastage in all that additional steelwork, and by doing it that way, it actually hid a lot of the structure. You didn't really get that honesty of being able to tell the primary members from the secondaries. So it wasn't really a desirable option. So moving on from there, keeping the same assumption of everything aligned at the bottom within the structural framing, we've got the standing seam roof follows all of these timbers, whether they're at 700 or 250 height. So that would express the structure externally through sort of humps, as it were, almost running through the Calzic roof or through the standing seam roof. And the soffit, as the same option before, running underneath. So alternatively, we thought we could align the steelwork along the top surfaces. That simplifies things from a roofing perspective. So the standing seam roof could be run as a consistent level, nice and easily on top there. And then the timber soffit panels again follow the underside of all those members, whether they're 250 down to 700. So from the interior, that primary structure is expressed, but more so in timber than is the actual structure. And our final option was basically the same as before, but we keep all of the timber soffits level, and in that way, that primary structure is much more clearly expressed. And that is what was decided to be the favourable option. And that's followed on to all of our design work from there on. So we've looked at some different options as to how that roofing could actually be constructed, what the build-up would be. So first off on the left, this was our first solution using a cassette system which infills the triangular openings. So you've got a steel frame which will drop into those openings, subdivided by additional secondary steel works with a ply deck, and the timber soffit panels pre-installed to those cassette panels. The idea being the whole thing could be prefabricated off-site, dropped into position, and then once the whole roof is done, you come along, waterproof, and lay your standing seam roof. Second option, the one in the middle, is something a little bit more traditional. So not done as a cassette system, we've just taken those diagrids, subdivided them as necessary with secondary steel work to support a ply deck. You then go straight on, do your waterproofing, your roof lining, and then the soffit panels and acoustic insulation all installed later on from the interior as part of the internal fit out. The last option, very similar to the previous, in that it's a more traditional build-up, but instead of applied deck, we've opted for a steel deck, something that will span multiple bays, multiple diagrids. So it omits that need for secondary structure, but we still have this issue of then having to come along later to install this timber soffit panels as a separate item. Sorry, the headers are animated. Right, so this is the adopted scheme. So this is a development of the cassette we saw on the last slide. So this includes the perimeter framework. Instead of applied deck and secondary steelwork, we've opted to incorporate the steel deck, which was part of the third option of the previous slide. And then within those cassettes, you've also got the acoustic insulation layer and all the timber for that soffit panel. So although the timber is designed as part of those cassettes to be installed all in one operation, they are also independently removable, so should there ever be damage or need for replacement, they can be removed at a later date. So one of the main outstanding concerns that we had from this approach was the risk of potential damage to the timber, particularly the deep perimeter profiles of those cassettes. So you haven't got a lot of clearance there as you're lowering those down into those openings of the diagrid. There's risk there that they could be damaged, and any damage that needs to be rectified later requires access from the interior. That takes away from some of those benefits that we're trying to achieve by having that cassette in the first place. So to alleviate that risk, we have come up with an installation sequence that we think will kind of mitigate that risk as much as possible. So first, top left, we have some T-profile guides, the idea being that these will be fixed to the top of a primary steelwork in advance of the installation. Moving on to top left, the cassette panel is lifted into place. That could then be manoeuvred to align onto those guides. It's something that's very similar to a standard, fairly standard unitised bracket, that kind of solution. That then allows the cassette to be lowered into position following those guides, takes away all that risk of lateral movement. It gets you down to a point that you cannot now damage those timbers. And once it's down in position and fixed, those guides can then be removed, taken to the next bay, and ready to be used again for the next installation. So before we go on to the next section, something we should note is that since we completed this phase of the design, we've got BS 9992 2020, the Fire Safety and Design Management and Use of Rail Infrastructure, which has been published. So this is a code of conduct that requires on the build-up of internal walls and ceilings in the public areas that substrates are to be classed as A2 or better, and linings to be class B or better. So this is something we need to revisit, do a little bit of work with our fire engineering colleagues, and just make sure we're still okay with that timber, whether it falls into the correct category, what it's classed as, whether substrate or lining, and get some clarity on that and see if alternatives need to be considered. Hand over to.
Thanks, David. 2 minutes to go, so I'm going to have to zip through this really quickly. So platform canopy, so essentially half the station is canopied, the other half is under the main shed, main station shed. Let's see, looking towards the shed from the end of the canopies. Originally we specified timber for the canopies, but it's possible we might be moving more towards a metal approach here, certainly in terms of bomb blast requirements, which are quite onerous on HST stations, as well as fire, of course, which David just alluded to. You've seen that slide before. That's the canopies working to provide daylight down to the public space. That's a typical view. Modular system. Want to say something?
Come on to this one nice and quickly. We've got a bit of time left. So this is following on from the theme of off-site fabrication. The platform canopies have been designed to be pre-manufactured in 16-metre modules. Here's one here with an exploded view. So these modules include the glazing, cladding soffits, access restraint systems, first fix M&E equipment, and even the OLE masts. The glazing units we've rationalised so that you have minimum glass wastage. And then in areas where glass isn't required for daylighting, to the areas below, that space is utilised for provision of PV panels. But they are not intended to be part of the modular system. They'll come along at a later date to be installed on site, just because of any risk of damage during transportation due to their fragility.
So cross-section, I'll explain in a minute how this is an evolution of what we've done at Reading Station and London Bridge. You can see the two, I won't use the laser, I think it's a bit too faint, but the two walkway routes with the protective guardway, they're located outside the induction risk zone of the 25,000 volt overhead power lines for the trains, so everything can be maintained and checked safely. Now, as I said, this is really an evolution from what we did at Reading, where we maximised prefabrication, because obviously Reading at that point was an operational station, so right down to first fix M&E, the modules were put on the back of a lorry and loaded up and put onto site. That then has been developed again into London Bridge Station, where again that prefabrication process, together with WSP, was in action, and the photo on the right is actually one of those cassette units being installed. They went up incredibly quickly on site. Now, PV. So one of HS2's commitments to their net zero strategy is for regulated load. So that means predictable electrical loads for the station, so lighting, HVAC systems, domestic water, etc., etc. That regulated load to achieve that net zero carbon should obviously, where possible, come from renewable sources. So the most realistic renewable energy source is PV. Now, the story with that was we originally started putting it on the roof, and Birmingham City Council objected to that. They weren't in any way objecting to renewable energy or PV. It was simply the infrastructure, the handrails, the emergency lighting, the signage that goes with it for maintenance, which they found to be a problem on other projects. So what we ended up doing was putting them, as David explained, putting them on the canopies, which you can see on the right-hand side of the top image, and on the southern facade. So this is, I suppose, an example where town planning meets sustainability. Not quite converging yet, but I suppose that's one of the challenges we have with such a large project. But I do want to say something in support of Birmingham City Council, which is that they've been incredibly supportive all the way through the project. Last slide.
Thank you. Yes, last one. So the PV panels on the south facade, they were intended to be the cladding itself. What we didn't want is to introduce wastage into the design by having a cladding system with further PV panels bracketed off it. There also needs to be a level of blast resistance to this facade, as there needs to be on all of them in the station. So what we have here are the PV panels installed into a steel frame with an additional steel backing tray, which is used as a containment for any fragments in the event of a blast, to protect passengers and staff in that situation, and also gives access to wiring at the end. Thank you very much. Thank you so much. Let's look at the level pictures at the end.
Told you it was a really great station design, that one. I'm going to introduce the next talk with a quote from the website, which I thought was extremely, extremely interesting. We design the places where people love to be together. And this is our next speaker's brilliant motto. They're going to be talking about circular economy in a large-scale envelope. And here two fantastic architects from Populous, if they can please come to the stage when they're ready. Senior Principal Francois Clement and architect Andrea Guyate.
Good afternoon, everybody. Can you hear me?
Oliver?
Is it okay?
Yes.
Fine. Good afternoon, everybody. My name is Francois Clement. I'm a senior principal at Populous, and I'm also the general manager of our French office now. Andrea Guyate is with me today. He's one of our architects, and he worked on the project that we will present to you today. Populous, we are a practice specialized in sports facility. We've been around for around 37 years. We have a vast amount of expertise in terms of sports, and we are architects, interior designer, planners. We worked a lot on events that we are covering, whatever is related to sports. And we have around 23 offices now around the world. The project we will present you today is a competition that we won 3 years ago in France. It was the renovation of a stadium in Strasbourg, northeast of France, an existing stadium that was developed by the local authority in conjunction with the Racing Club Strasbourg, which is the local club. It's a really interesting project from 1984. It's a concrete structure that has been designed by engineers and extremely well designed, by the way. We are at proximity, hyper proximity from the center of town, but also within what is called the green and blue grid of the city. Something special about that stadium called La Méno is that instead of being on a north-south axis, it's on an east-west axis. And you'll see that that will have an impact on the project that we had to develop, where the main project was to develop the southern stand, which is the official stand, that was facing that green grid, which is a park called the Park of the Extend Vert. But then we had not only to develop a new stand facing a park, but we also had to protect all the other stands, because currently there's no protection for the general meetings. I have already talked about that blue grid, and then trying to match the aspiration of the local authority, but also of the European Court in terms of identification of the climate, the potential climate neutrality of a project like this one. Sustainability and circular economy, the why. Well, when we started the competition, it was in our winter 2020, which was actually a really bad summer in Australia. Australia was burning, and we were talking a lot about what can we do, how can we design a renovation that will potentially address all the sustainability issues that we are facing. As a practice, we had always worked with the reuse, the reduce, the recycle, but we question ourselves: can we uplift? Can we upcycle elements that have already been produced in order to reuse them within our project? And if we do so, we will do it only if we are able also to provide a level of quality of design that will be the one that we would like to reach. When Mike was talking about decoration earlier, I was thinking of ornamentation. How can we make sure that whatever component we are using will be the base of an artistic production. We had, for a long time, had a conversation about airplanes. There is an airplane, which is the A340, which is at the end of its cycle, 4 engines, and a lot of them are about to be dismantled. The story comes from 12 years ago. 12 years ago, Populous was involved in the construction of the Aviva Stadium with the development of a really complex facade made out of polycarbonate. And we were based in London, and we used to travel quite a lot. We used to go to Dublin every week. I'll take the opportunity to say hello to Andy Karaïskos, who is over there, who was doing those trips with me. And being in those planes, we were saying, what can we do with all of that? And when we started the competition, we decided to try to use some fuselage or portions of fuselage of dismantled airplane. At the same time, we did identify a company in the south of France who had started dismantling, cutting airplanes, not recycling them, but not demolishing them, and then after that, sending them for recycling. But they were able to cut sections. And then at this stage, I will let Andrea tell you a bit what we did with all of that.
Thank you, Francois. The renovation of Stade de la Menon. Here is the project, the first image we're showing to you. And as Francois mentioned, we are in the heart of the green area of Strasbourg, facing the large public park, and at the same time, the training center. And as you can see, the sustainability aspect has been a key aspect, not only for Populous, but also for the municipality that decided to keep 3 stands, the existing stands. So we restored 3 stands and built the brand new south stand. Here you can see the south stand and his interaction with the existing stadium. So you can see how conceptually we decide to keep the legibility between the 2 volumes. So we have the brand new stand that is clearly legible from what is the existing stadium. And as you can see, this white canvas that we decide to create with the upcycled brise-soleil to the green park that we are facing with the stadium. The new south stand, as you can see here, there is going to have the implementation of hospitality facilities and the offices of the club. So to bring La Menon Stadium to the we update the La Menon Stadium to the nowadays standards. So going closer to the south facade, here we can start to appreciate this brise-soleil that are the topic of the presentation, and with one of their main features that was leaving the external face completely smooth, and the internal face was quite sculptured, doing all the profile that compose the airplane fuselage. So from outside, we have this white wall that basically was working as a background for the park, but internally, for the people that use the building, as in this case the main VIP entrance, they can appreciate the sculptural elements of this panel from inside. Why we arrived to upcycling? We worked with the EcoPop, that is our sustainability department, and looking on how a stadium can be sustainable. And in the guideline that EcoPop prepared for us when helping us developing, there was like reduction of wastage and recycling. So we start thinking like, why we don't use something that is wastage in order to be part of a building? So doing so, we thought about why we don't upcycle instead of recycling. So basically we shorten the chain. Instead of like put something in a recycling chain, we decided to put it in, we take something that already exists and directly bring in architecture. So the carbon footprint was minimized just to the installation of the panels in this case. So as Francois mentioned, we started interacting with Tarmac, and we saw how they were working, how they were upcycling components for maintain airplane or to repair airplanes. So also, as also Francois mentioned, like the stadium was perfectly oriented south-north. So we needed to shade the south facade in order to protect from overheating issues. So we put all of these ingredients together, and we end up saying, like, why don't we cut the fuselage and we shade our south facade, leaving free view on the park and on the river, avoiding overheating issues, especially during the summer. So this is the Airbus we are going to recycle on the project. But as you can all are aware, the airplanes are not made to stay on facades. So where then the issue came up? The Airbus has been built over 20-year time, so we had 18 variations of the same type of airplane. So a lot of inconsistency. And also when we spoke with Tarmac, they told us, like, we cannot guarantee you that we're gonna cut this airplane in 2 years' time, because like construction is gonna start 2023, and we were speaking about that in 2020. So how can we know what we're gonna cut and which type of airplane we're gonna cut in 2023? So me, Francois, and Maffei, that were our facade consultant, we became a bit of airplane engineer during that time. So we start analyzing in detail how Airbus were made and which could be the common ground where we can start our detailing process. So we saw there were two main elements: the Z profile, the parallel one that you can see on the screen, and the stringers that are the radial. We know that we have these two profiles in all the Airbus, but we don't know at which distance they will be. So there will be a big inconsistency, but we know we have these two elements. So starting from there, we start seeing how we can cut airplanes based on the drawing. These drawings are coming from Airbus, our official drawing from Airbus. So we know how the airplane are gonna be made, but we don't know which exactly layout is the structural components are gonna be. So we end up speaking with Ayman and say, there are too many inconsistencies here. We don't know how to start. Why don't you cut two panels for us at 1:1 scale? So what they done, they cut two panels at 12 meters by 2.4, and they deliver to us. So we say, these are the panels, how they are. So to doing so, to arrive to a detail elements, we needed adaptable modular connection, because we need to standardize our connection in order to have a mass production. And so this is the design at stage 4, which submitted for tender. And we have the south facade gonna have 49 lines with 2 panels per line. So, and the south stand, this is just an overall view of how the engineer scheme works. We have a 45-meter cantilever roof that is connected to the primary concrete structure, where we have applied a secondary steel structure, where we're gonna install the panels. So looking at how is the structural system of the panel themselves, we saw that we had two main constraints. There was the horizontal load done by the wind load, because we are 30-meter high, so it is quite important wind load, and the dilatation, because we're speaking about 12-meter aluminum panels, so the dilatation is going to be an important factor. So we decided to go with this isostatic scheme. Why? Inch connection at the top, we allow the dilatation towards the ground, and also we pick the vertical load to the top, not big vertical load. We're speaking about 20 kilo per square meter for this panel, so they're quite light. And all the other connections just gonna pick the horizontal load. These are the connections we developed with Maffei. Just two types of connection for all the panels. The AB connection takes the vertical loads and part of the horizontal load. Simple bolt connection to the skin, and a simple hollow square section will bring all the vertical loads to the secondary structure. Looking at the CD connection, this is the adaptable connection that's been like the important one that we developed. Basically, thanks to this hollow circular profile, we've been able to adapt whatever distance will come in all the Z profile. We didn't care anymore, because we say, like, we have over 50 centimeter tolerance, so we are able to install the panel how we want. So we kind of went around all the issue about the inconsistency. So this is how the connection looks in our prototyping phase. So after we look at that, of course, like the first questions come up, how much does it cost? Well, when we ran the first cost check, everything was costing a lot. And we were kind of like shocked about that, and we start questioning ourselves, does it work? And also, especially because how we approach the matter, we did it completely wrongly, because we approached this facade as a standard facade, but this is not a standard facade, this is a upcycle facade. So we need to rethink entirely the workflow. And we had to rethink why, because the budget was really small, 100 million for the entire renovation of the stadium. So we need to be really careful about the budget, and we need to make this facade economically valuable for the client to say, yes, this has a sustainability aspect, but it's also valuable. There is also value. We can also afford it. So we went down to the cost and we make the breaking down of the cost, and we saw that the three main factors were connection, cleaning and cutting process, and logistic. These three aspects are not normally in standard facade because for example, you don't have the cleaning aspect because when you buy a new facade, you have a new facade, you don't need to clean. In this case, we need to clean the airplane fuselage. So we start tackling all these factors. First of all, what we done, we optimize the facade because at stage 3, we have 3 panels because we saw that was nicer in terms of proportion. But then we saw 3 panels much more expensive than just 2 panels per line. What we done, we had just 2 panels, all the same, so we have 90 panels all the same. This allowed us to reduce by 44% the number of panels and reduce the 18% of number of connection because we maximize the distance between the connection. But we just reduced by 4% the shading area. So just reducing a little bit the shading area, we've been able to optimize a lot our facade. So connection cost, we reduce, of course, the number of connection. We reduce the AB connection, the inch connection on top, where that was the most expensive one. We increase the number of CD connection. That were the modular adapter connection. And then here another issue happened. When we designed the first connection with Maffei's, basically we designed a nice connection. And then when we went down to the manufacturer, they were like, we saw on our quote there was a 25% of cost of material waste because the plate we designed were outside the CNC machine standard plate that they usually use to cut. So we had to run 7 iterations to achieve the best compromise between plate thickness and the dimension and the shape. And doing so with Maffei's together, we've been able to optimize, we reduced by 50% the wastage of the material in the cutting process of the connection. Then cleaning process, really simple, standard panels, less time to cut, less time to clean the panels. The manufacturer were really happy. We have always the same panel, same layout. We really, really smooth workflow. Then logistic. Okay, how we approach that? At the beginning, as I say, we did it completely wrongly. We basically done as we usually do for standard facade. So we post-plan from the installation day and say, oh, we need the panels that day on site. We post-plan the production. But that was completely wrong because for many factors. First of all, we need to remember that the production time of the panels is 11 months. So doing just 6 months workflow, the time for Airbus to basically find the airplanes that they need to cut was really short. So they make us like a really high quote for the panel. Then second problem was the continuous production chain. I know that usually in manufacturing, continuous production chain is something is good, but in this case was not, for a really simple reason. Because you have to imagine that in one day, or I mean in this case in 1 week, this manufacturer, the contractor, is going to have 4,000 square meters of fuselage in their site, in their factory. And they told us, how do we store this? Where do we put them while we produce the connection? Where will we put them while we paint them? Where we put while it's drying or when we need to transport them? So suddenly, on our quote, there were 49 steel racks that was needed to transport the panel, to store the panel, to paint the panel. And there is a huge cost on the overall budget. And at the same time, there was a big wastage because we have this, imagine these 12 meter by 5 meter high racks, steel racks. And we say like, what we do with these racks after the project is over? Where we put it? So doing so, also the last problem was the stocking because the manufacturer were telling us, guys, you want us store these panels for 12 months, you need to pay us to, put 4,000 square meters of this panel in our factory. So we rethought entirely the workflow from scratch, and we spread it over 30 months. Doing so, we gave 1 year to Airbus to find the airplanes, so lower cost of the panels. Then we divide the cycle in 3 steps. So what we say, we cut the panel, we transport in the manufacturing, we produce, so we do all the connections, and then we install. We repeat this for 3 times. Doing so, we basically reduce by 86% the cost of the racks, because basically with the same racks, we can basically transport, paint, and install. And at the same time, we reduced by 100% the cost of stocking, because as soon as something was produced, was installed on site. So to wrap it up, the cost, this is how we've been able to achieve in terms of costing. We reduce a lot the cost since the beginning, and just rethinking the workflow, rethinking how we work on this facade. And overall, we've been able to optimize by 25% the cost of the facade. So to conclude, I mean, I think this project is a good proof to show that upcycling is possible. But to do so, we need to really work hard on detailing. So to find the correct detailing to bring something that is not burned to be in architecture, but working hard on detail, we can bring something that is not native for architecture into architecture. And then secondly, rethinking the workflow, thinking differently the workflow. I think we are able to bring upcycling in architecture also for good value, and also for an affordable cost, also for a public project as Lameno Stadium. Thank you.
Do you have any questions?
Yeah, I think we actually have
We have 4 minutes.
Yeah, we have a few minutes for questions. We have probably time for 2 questions from the audience, perhaps.
If you have some questions, we're here for that.
Okay, I've got 1 question, but not 5 minutes. So first of all, thanks a lot. That was brilliant. And I think, again, the title of the presentation really attracted a lot, because probably some people thought that we were talking about maybe something else. So really, really good and interesting, and really good way to recycle stuff and going into circular economy, which is something that we used to do, and we've done through the ages, for ages, but we kind of seem to have lost track of how we do it. What was the key challenge? If you, the worst thing that you've come across that really, really, really challenged you? Technically?
Inconsistency of the panels. We couldn't find a single panel that was same as the other one. So how we can, you know, like we had to do all the calculation at stage 3. So before cutting an airplane, 3 years earlier than cutting an airplane. So that was the biggest challenge for us, I think.
But I think also that it's also sticking to the design intent.
Yes.
Taking a decision even before deciding and forcing ourselves, I'm talking for all of us, and forcing ourselves to think differently. That means that on your next project, can you start saying, we will do it in a different way? Because, I mean, seriously, things are not getting very well for the moment. Things are getting a bit worse every day. I mean, it's too hot and then it rains too much. But we are aware that things are happening like that. That I mean that as designer, I think it's really important for us to take decisions, to design in a different way, and to identify the new path that will help us to design in a different way. But it's not easy. Because we are pouring concrete. We are using aluminium. We are using glass. How can we design a different way when we do that? And then instead of protecting a facade that is 4,000 square meters with brand new brise-soleil that would have been melted somewhere and bring on site, can we think of something different? That's an example. I mean, that's just an example because of it's a facade that was facing south, but there are plenty of other things that we need to think of.
So,
a really good example to finish, sorry. A really good example, again, I'm talking about the Viva Stadium that we did with Andy over there. When we demolished Lansdowne Road, we kept all the concrete on site. And for the 3 years of the construction, that concrete has been used as infill, moving from place to place. All the rebars were recycled. And there's a lot of things that you don't see, that nobody is aware of. But it's important to remind that to everybody constantly. And then there's about using those fuselage for as brise-soleil is interesting, but it is also interesting because suddenly it opens the conversation.
Francois, thanks a lot for inspiring our audience to effectively look for opportunities to actually apply those principles. Please do give a round of applause to Francois and Andrea. Thank you. I'll give you a number, 68,000 kilometers. 68,000 kilometers is the number of special steel profiles that Montanstahl has produced since they were founded in 1983, 1984. And sales director Axel Dell'Orto is going to provide an overview of the key aspect of their, I think it's fair to say, very famous profile. Please, if you can welcome him on stage, welcome Axel on stage.
Good afternoon, everybody. I'm Axel Dell'Orto. I'm working for Montanstahl. As we said, Montanstahl was founded in Switzerland. I don't know if you see it, in the very south of Switzerland, very close to the Italian border. We have about 40 years of history, and we are about 250 employees in Switzerland. Globally, we are about 400 people. We make 180 million euro turnover and produce about 26,000 tons. As the name says, Montanstahl, German, Stahl, steel. These 26,000 tons are products of steel. So steel and stainless steel. We produce them with various different production technologies. We have hot rolling in-house. We have hot extrusion, we have laser welding for tiny sections, we have code drawing and code rolling. Montanstahl is a group, as said. We are located in Switzerland with the main technologies, where we have all the main technologies in-house. We have different branches in the United States, where we have also a production for laser welded sections, and we have the production for hot extrusion in Germany, as well as a sales office in Germany, which is focused on facade profiles. Today we are going to focus on laser beam welding. We started laser welding in 2004-2005. Very simple T-sections, which were, by error shown to architects, and they loved them because they are nice, sharp corners, and so the interest was very big, and we had to start producing them, and here you see a sharp corner profile. That is what the architect likes. The separation between light and shadow, which is possible through to these sections. The previous picture was for the mock-up. The series was then rounded a little bit because due to safety reasons it was too sharp. So custom shapes are possible by means of laser welding. You can optimize the material, you can place the weight wherever you need it. You don't have any minimum runs. What you see here are hollow sections which are welded already in curved shape. This is for a project here in London. It's the YY London. And these sections are one separate, different from the others. Another production technology we use for producing sections for facade business is the hot extrusion. And you have, again, the possibility of producing customized shapes. You have the possibility of having a structurally optimized section. You can have floating material thicknesses, as you can see. You can have different thickness on the extremities for stiffness. You can add functional details on the sections. And again, also with the hot extrusion technology, there are no minimum runs. So this is a brief overview of what we're doing. Today we will talk a little bit about this project, which we have done. This is Q Berlin. It's in the center of the town. there is this fabulous building which has been designed early in 2009, and everything stopped. 2015 they started again, and in 2015 the facade became a double skin facade, even though at the origin it was a single skin facade. And for Montanstahl, our customer is the company Gig Fassaden in Austria. It is a little bit the business card of Berlin. When you get to Berlin, you take the railway, you get off the central station, and you pop directly on this huge square, and you have the building in the middle. And it is also a little bit hiding itself due to this shape of the very particular facade. And we have here you see there is the inner facade, and externally there is the second skin, which is installed on top of the other and connected to the inner facade. The ground floor and the first floor, they are made with steel sections. The upper floors are in aluminum, while the entire external skin is supported by steel sections. And they are all, of course, as we do, sharp corner. There are different reasons why we've chosen this project to present to you today. Especially, we're talking about steel, we're talking about sharp corner profiles. There are standard sections, there are special sections, there are small volumes, and there are large volumes. So we cover almost the entire spectrum of what Montanstahl is doing. The double skin facade is giving advantage about the microclimate inside the building. It is adding natural ventilation, thermal insulation, and reducing, of course, costs for heating and air conditioning. As said, we supplied the transom and the mullions for the inner facade. The building has a footprint of 42.5 meters on each side, and being a cube, it is also 42.5 meters in height. You see, it's very particular. It's generating reflections. The glazing is very particular for the reflectivity and for the thermal insulation. It's generating a sort of kaleidoscope. So you're seeing yourself, but you're seeing also what's going on around you. So it's very, very complex. At the origin, the mullions for the outer facade were, according to this design, more than 1,000 different shapes. The customer, our customer, Gig Fassaden, came up with a solution in order to reduce the various types of mullions, and we were able to reduce them to about 11 sections, so from 1,000 to 11. You see, they're all nice, crisp sections, and luckily, because they are really time-consuming to produce, we have to take the plates, we have to mill them in order to get the right angle. We have to assemble them. You're seeing some dies. We are TEC welding them, and after that we are laser welding them. But you see the corners are not nice and crisp, so we are going to mill off and grind off the excessive material. After that, there is also some straightening in order to supply a straight bar. There is a grid shot blasting in order to have a uniform section packaging, and that is the final result. You can see here there are mainly three different families. There is the internal, the internal facade sections, which are parallelogram shapes. There is the external facade sections with the gig hinge, which are standard sections, and then there are, for each corner of the building, there is one dedicated section made express for each corner, adapting to the angularity of the facade. You can see it. Normal rectangular hollow sections, standard shape. For us, it is a standard shape. It is particular because it has two different thicknesses, so it's nothing you can press break or make by bending. And then there was a second shape, a little bit larger, also with a greater material thicknesses. Here you can see how many steel there is on this facade. So, summing up, we supplied steel, S235. We supplied rectangular hollow sections, about 100 ton. We supplied custom sections, about 25 tons. And we supplied a special angle bar, nearly 20 tons. And when preparing this presentation, going through the drawings, I never found the angle bar. Discussing with the architect, Torben Ostergaard from 3XN, he explained to me that the angle bar is not within the facade. The angle bar is quite big. It's 300 millimeter times 100, so it's huge. He said it is installed on the balconies. There are two balconies each side of the building, and so he was showing me them on the picture, and here you see it. It's a handrail, so it's a very heavy, huge handrail. And why so huge? And the answer was, life is much more enjoyable. I try to get his words. Life is much more enjoyable with a glass of dry martini, and you must be able to place it in safety on the handrail. And so please guess, how many glasses of martini can you place on a 420 meter handrail? Any clue? 3,387 martini glasses, so more than one each here. So thank you very much.
And no, you're not going to get a martini in this session, I'm afraid. Maybe later, maybe later. Have you ever thought whether, in the whole discussion on carbon, sustainability, and so on, we can use some of the materials that we are already using to actually reduce carbon impact? In particular, the interlayers that we use extensively interlayers in our facade constructions, but also on balconies, balustrades, and the like. So Allan Gibson is product manager from Kyriakos. Please do come on board, Allan, and he's going to talk to us about exploring exactly those opportunities. How can we use laminated glass to reduce the carbon footprint of our constructions? Please give him a round of applause. Thank you.
Thank you, Savario. So, good afternoon. Good to see you all here today and to be able to share some good news with you regarding some progress that's been made in a format that is
I don't know
a little
where
different
everybody else is
from
now.
what I'm normally
My
talking
panel
about,
discussion.
glass, ballistics, so on and so forth. So
discussion.
let me start. For those
So
of you
we've
that
gone
don't know me, my name is
four-
Allan Gibson, and I've been
3 or 4
involved in the supply
panelists
and the
in each
specification of
but I
specialist
don't know where
materials
they are.
for the construction industry for over 23 years now, both here in the UK, the Middle East, and in Northern Europe. I have a BA in Management, I have a Master's in Facade Engineering. We're also sponsored members of the board of CWCT, and I'm responsible for the delivery and specification of Kyriakos' high performance product portfolio for the north of Europe. So Cupertino has a strong focus on new technologies and innovations, underlining their commitment towards serving the ever-changing demands of the global glass industry through innovation and leadership. So Cupertino's advanced interlayer business is a leading global specialist in the development, manufacture and supply of PVB and iron glass interlayers for laminated safety glass applications in architectural, automotive and marine industries. And it alarms me, has alarmed me, when I hear comments being made that laminated glass and glass are the two evils in the strive towards the embodied carbon construction of facades. And admittedly, there is more that can be done to address this issue. But let's not forget also the importance of safety. And I would like to address this in today's presentation. So I wanted to go through and share with you the following topics: the carbon footprint of our interlayers used for laminated glass, and the solutions that can be engineered into the facade, and the progress that's being made in achieving the reduction in embodied carbon for laminated glass. So over the years, Cupertino have come to be the leading supplier of interlayers used in architectural laminated glass, but little was known about its contribution to sustainability. The figures represented in the industry were estimated values based on presumptions, but now having analysed our production process, this detail has now become more accurate. Sphera were our auditors for carrying out life cycle impact assessment using the GABI database framework, along with all the data supplied by our two European plants, Troisdorf in Germany and Holešov in the Czech Republic. The Intergovernmental Panel on Climate Change, the IPCC, AR5 contains GWP, or global warming potential values, for timeframes of 100 years, or GWP 100. So this formed the benchmark for our process in calculating the kilo of CO2 for our products for these particular production sites. And the assessment measured the cradle to gate impact, looking at the resource of the material, processing and manufacture of the productions for each location. Environmental product declarations for all our products will be available either later this year or the very latest, beginning of next. And this will help establish the true impact on the environment through the cycle of this product. So in more detail, you can see the schematic that all the areas of process from cradle to gate are captured, which include the emissions to soil, water, the air energy used, and the resources required to manufacture 1 kilo of finished interlayer. So in summary, the use of virgin PVB material represents 3.34 kilos of CO2 per metre square of PVB from our plant at Troisdorf. Century glass production at our Holešov plant represents 2.77 kilos of CO2 per metre square due to its very strict usability of post-production trims that we take back from all our processes. We have two products which actually have a greater reduced carbon of less than half a kilo of CO2, where we're able to maximise the use of 100% recycled material with products like Glutaside G and our translucent white. The asterisk, by the way, represents a 0.76mm gauge. And here you can see the illustration and difference in metre square and kilo of the two main product types. But there are many other factors of LCA required when establishing the distribution, life and ultimately end of use, and how to assemble this information and guidance on this methodology has recently been published by the CWCT in a recent document, Life Cycle Modules Explained. And it's a process that requires a standard practice that needs to be adopted by the whole industry, as there is a risk of ambiguity due to the variety of different methods from a variety of different companies using different factors, producing different results. A single harmonisation of single method is therefore required so comparative studies can be matched accordingly. Now, we understand the importance of collaboration, and this has been witnessed across the industry, and it's refreshing even to see today so many parties striving toward that same objective. And I want to highlight a couple of these collaborations that both highlight different conclusions, but ultimately the same benefit of sustainability. Now, the first of these collaboration efforts focuses on the carbon footprint reduction during use, or dual reduction. And this is an engineered solution that looks outside of the box of the standard modular configuration that we tend to see in our facades, and utilises the structural performance of sentry glass and its reduced carbon footprint and structural performance to provide a more sustainable solution. Now, tests in France provided this information that I wanted to share with you today, and the Tour de Montpensier, get my tongue around this, the Montparnasse Tower refurbishment project in Paris, and this was selected as a case study to make a comparison between PVB and sentry glass in terms of embodied carbon. And this supports a paper that we recently submitted earlier this year at Challenging Glass in Ghent. There are many contributors to a building's carbon footprint, some obvious and some that aren't quite so obvious. The building's energy use is something that most of us are very aware of, and the efforts to reduce that with solar, wind and geothermal elements are fairly common. Water supply is another contributing factor, as pumping into the building often requires fossil fuels. Some lesser-known factors, like greenhouse gas emissions of transportation of materials to the job site, as well as the embodied carbon of those materials used to construct the building. So the Montparnasse Tower in Paris originally was built between 1969 and 73. It's currently under a major refurbishment, including the replacement of 40,000 square metres of existing facade. And this is to improve the environmental performance of the building. The elliptical building spans a footprint of 61 metres to 39 metres. The existing construction was a high spec of its day: anodised bronze panels, DGUs, opening vents, full unit widths of 1.3 metres spanning columns with, from slab to slab. A really iconic building of 70s architecture. Now, the refurbishment project itself, which was designed by Nouvelle AOM, defines 6 principal typologies for the facade. 2,500 square metres of the Sierre, which is a rooftop garden, 27,000 square metres of main core, known as the checkerboard, 1,050 square metres of the suspended garden, and 10,050 square metres of loggia, which is the covered balcony, followed by 2,600 square metres of the lobby and 1,500 metres square of the patio area. In total, these areas contribute to 30% total of embodied carbon for the whole project. Now, the checkerboard facade, the biggest typology of this project, represents 27,000 square metres, and it will be a natural ventilated double skin facade assembled in a unitized system, each unit approximately 5.7 metres wide by 3.15 metres high. Now, the deepness of the double skin varies from 600 to 900 millimetres. The outer skin is comprised of 1 laminated glass panel, and the inner skin is composed of 4 IGU units. The design of the new facade presented a big challenge. In particular, the additional weight compared to the existing one. The main core of the tower is supported by pre-stressed concrete beams spanning above a subway station, so it was critical to limit the impact on the load takedown. Reducing the weight of the facade is also a double lever to limit the carbon footprint of the project. The lighter facade, the less embodied carbon on it, but also the reduction of the structural reinforcement that was needed. The outer glass contributes to around about 20% of embodied carbon of the whole facade. As the main design load for the facade was actually wind load, a wind tunnel test had been carried out to precisely establish the wind load on the facade. And the wind tunnel test, combined with the use of structural interlayers, has allowed to minimize the thickness of the laminated glass because of the coupling effect of the sentry glass to the glass. And the specified structural layer in this particular case was SG5000 or sentry glass. So the laminated glass of the outer skin checkerboard facade has been calculated according to the equivalent thickness method defined in EN 16612 and the DTA French technical approval of the Century glass. And a comparative with the standard PVB interlayer has also been established, and this allowed the design team to evaluate the advantages of using a structural interlayer. And the image shows the elevation of the 4 facades, showing glass compositions for each outer pane, depending on the interlayer and the relative wind loading. You can see that with the coloration. So following thickness calculations, the carbon footprint of both options have been established according to the natural French INIES database. And this database is established according to NF EN 15804. The kg per CO2 of meter square for each gas composition has been defined, and the impact of the interlayer in the LCA is integrated accordingly with the information provided by ourselves at Curie. Now, the thickness of the interlayer considered in the calculation is 0.76 for PVB, but actually 0.89 for Century Glass 5000, which is why it's showing 3.35 kilos as opposed to CO2 as opposed to 2.77. And the values represented are the values considered for each glass composition and are calculated as follows: stages A1 to A5, B1 to B7 for a lifespan of 30 years. Now, the use of the structural interlayer allows you to reduce this by 15%, the embodied carbon of the outer glass panel. But actually, this could be increased to 20% if the year span was increased to 50 years. So very quickly, from a collaborative point of view, end-of-life laminated glass and how this could be deconstructed to enable reuse or recycling. For the last 50 years, we have been developing a high-performance interlayer with an increased coupling bond to glass. So now we've been asked to delaminate the glass, and this obviously comes with some challenges. So for a few years now, we've been working with ARA, looking at ways to deconstruct an IGU and identify a commercially beneficial method of taking back a laminated piece of glass to its constituent parts, where the glass can be reused, reworked, or put back into production as coloured, and for the interlayer to be removed to enable repelletization and extrusion into an reusable interlayer. And a couple of options of this process have been identified, and tests have been carried out to ensure product reuse can be achieved successfully without any limited deterioration on quality. But this does possess a question. And it was a question that was actually raised by James Exley-Callan in a presentation I saw at Delft in Delft Glass Forum last week. With an increased demand on recycled glass, turning away from low iron glass, requirements that demand increase in energy, production, what are the expectations of the client? Will they accept a reduced, less clear product with possible imperfections as an alternative, in exchange for a reduced embodied carbon solution? These investigations are a positive step in what could be a major step in reducing the carbon footprint of an interlayer, utilising greater volumes of recycled material that could be included within the final product. However, we are not there yet, and this is still work in progress, but much closer to meeting that objective. This creates other problems. How do we manage the transparency and availability of potential material inventory and of sites to take back? How do we incentivize the contractor to remove the glass units for separate demolition? How do we arrange regional locations for glass collection? These are other challenges that need to be solved to help ensure the success of recycling glass and laminated glass from the construction industry. But we would like you to know that we are involved in this process. Thank you very much.
We are going to conclude this track with a panel discussion. I'd like to start calling in the panelists, and they're going to be talking about a project they all worked on together. The title of the presentation is a discussion on the Timber Oasis project. And moderating the panel discussion is Andrew, and I'm going to let Andrew introduce the theme and the speakers, so please do welcome them on stage.
Take a seat, everybody. Good afternoon, my name's Andy.
You carry on.
I have the pleasure this afternoon of introducing a panel to you. I think with our industry at the minute, we have a huge interest, obviously, in sustainability, and timber is a material that's part of that. And this afternoon, we've got a wonderful chance just to showcase. Sometimes in these sessions, we see gigantic 50-story towers, stadiums, huge things. This afternoon, hopefully, we've got one of the little gem projects, some of the experiences we've had in bringing that to you. So the panelist team we have today, we have Kate Donovan from Lendlease, representing effectively our client and builder, Ivy from Meinhardt, our facade engineering perspective, and Mark from Acme as our architect. So maybe and hopefully you'll see some images of the project from your eyes yourself as we go.
I'll check that.
Should be some wonderful pictures, glitzy stuff coming. Thank you. But we'll just kick off as we go. So there's a bit of a scene setter for everybody. What were your initial understandings of the client's drivers for this project?
That's the Quran
How did
presentation,
that
and you're
influence
saying
your approach? Maybe Kate as the client's first.
Yeah, so the client driver originally for this project was that it was a planning requirement to provide a visitor centre for the Queen Elizabeth Olympic Park. But instead of just providing that visitor centre, they wanted to do more to create more of a place for people to come, as it's also at the entrance to the square of our development. And they also wanted to basically provide a building that would be in contrast from the surrounding commercial buildings. So they decided to go with something that's timber, a bit different, but it also depended on the site location, which happened to be on top of a tunnel. So the building and the loads had to work within those loading constraints.
Fantastic. And then Mark, over to you as an architect picking up that.
Yeah, just like I see we haven't got any images yet, so you'll have to just imagine.
We're teasing you, see. When you see it, you'll be like, wow.
So I think at the heart of the brief for us was a notion of placemaking. So the building sits on one side of Endeavour Square, which is kind of major public space within the International Quarter Master Plan. And it was all about activating that space and inviting people in, creating a space that people could really enjoy. I think at the time we started on the project, it was kind of bounded by 2 office buildings and a bridge, kind of open to the elements and this tunnel. So from the very early stages, we were thinking about an extension, the building as an extension of the public realm.
They were all
and that meant for us kind of thinking about that kind of folding topography and almost a vertical piazza. And that starts at the ground floor with a kind of amphitheatre which cranks up from the ground plane, continues with a series of terraces and steps which bring you up to the roof, which is itself this kind of folded topography into roof terrace, which gives you views to the Olympic Park, back towards Stratford and the orbit.
I don't know, that's what it's saying, and the architect was expecting, that's what I don't know.
And then the fact that we were on the DLR tunnel and we had to be lightweight. So part of the brief was actually your structure has to be timber, which for an architect is fantastic. I think we love working with timber structures, timber buildings. Obviously, from a sustainability perspective, it's a great thing, but also from a kind of material tactility, quality perspective, it's great. And so we really ran with that, and we decided that the building should be a celebration of timber and not just the sort of structural frame, but the whole building. There you go. Well, we can see it anyway. The building should be a real celebration of timber. Magic.
That one, right?
In the middle of, as Kate was saying, quite a contrasting sort of, it's quite a glass and steel environment. So that was our kind of focus.
Fantastic. And then Ivy, over to you. Picking that up as a facade engineer, what challenges did you see?
This was quite interesting because we've done a couple of plots on the IQL side, and it's a bit of a big deviation from CCF to this. So the first thing was to basically, in a way, deconstruct all the component parts in our mind to understand what is what, where does what go, and then basically work on bringing them all back together to say what is the intent, how do we then, meld each piece to the other and each type to the other to get, the effect, the intent that, was in the design brief. So there's a lot of, it's a very fluid structure, so it's a very fluid building. So one bit sort of melds and, blends very well into the other. So for us, it was identifying, first of all, the component parts and then looking to see how those can then be brought together to basically make it work, have the performances. And
fantastic. So taking that on there, so we're hearing about this requirement for this really lightweight structure in CLT as it was. How does that influence the facade design then? How do you marry these things together? What kind of experiences came out of that?
So I think our first thought was, can we push this? Can we actually make the mullions and the facade part of the timber story? So the initial aspiration was to integrate structural timber mullions into the facade, and then the intention would have been to sort of let the structure and the facade package to one specialist contractor who could have delivered that. Unfortunately, commercial pressures meant we didn't quite get there, but I think when it comes to working with facades and timber, a couple of the challenges or interesting things about that. One is that because we were looking to expose the timber frames, so we've got exposed soffits, we've got exposed timber beams and columns, it becomes more challenging and there's more emphasis on how you detail those interfaces because there's nowhere to hide. We spent a lot of time working with the guys on site and with the contractors to try and figure out those details and make sure that when you step back, it all looks great. And I think the other advantage that timber comes with it is just the tightness of the tolerances you can achieve because it's all machined off-site and controlled conditions in a factory. When they put that slab on, I don't know whether you can see from the images, but we've got a kind of zigzag faceting arrangement on the curtain wall. We've got a double height section of that, and to actually get, if you're working in concrete, that's quite tricky to ensure that you're getting the tolerances correct. You can get the facade to shoot by, but in timber, we can be confident that was going to be achieved quite well.
Fantastic. And then all of that over to you, Ivy. You've got a zigzag curtain walling, zigzag structure, lightweight CLT. How do you make sense of that as a facade engineer and get the sketchbook out?
A lot of rationalization. Obviously, with the facades, there's you have the performances to deal with, but you also have the commercial aspect to deal with, which is actually very, very important. If it's not commercially viable, it just won't get built. So trying to get systems that are not too far a deviation from standard systems was very important in getting it well within the aspirations. And also, so that meant, for example, it started off as a more angular building, but then that eased off a little bit to make it less angular so that, we had the opportunity to make that in standard systems without having to go bespoke on the frames and on the mullion sections. So those were some of the things that we walked through. Also the cleaning and maintenance for the glass was obviously quite important. So making sure that everything was accessible for in case of replacement was also important, and even down to the balustrades at the on the roof terrace was we walked through that, and I think the final solution we came to was it would be better in a metal rather than glass, just because it's a transient space. Somebody can decide to throw a Bono concert or something on the roof, and it's like, we didn't design for that barrier road. So we walked through all of that element to basically come to the solutions that we ended up getting there.
Fantastic. We just had that slide flashed up there showing the movement of the structure. How did that go together with the facade? Maybe you could explain everyone the particulars of the project.
Yeah, so with that one, we worked quite closely with the facade contractor to, it was dealt with in the mullion connections and also in the corners. I think we're quite used to dealing with deflections quite a lot in facades, but not so much lateral movement. So it had to be dealt with in the corners. And I think having the building actually angular did help to hide a few nice movement joints, because we had quite a few corners to assist with that.
Fantastic, thank you. And then Kate, as the project manager, you've got to buy it, build it. How did you find that process?
Well, in relation to the facade, from our point of view, and as the contractor, some of you might not agree, but the roof is the 5th facade elevation, and we consider that quite important. As you know, with the sides, obviously, it creates that watertight building to allow the follow-on trades to commence their works. So for us, the waterproofing detailing, and especially that relation to the facade upstands and the external balustrades, as you can see, was quite crucial, because any sort of water ingress would then damage that timber structure. And it's not just like concrete. You've got to then you can't just fix the leak. You've got to remove all the waterproofing, dry out the structure, and then put it all back again. So it was really crucial, for us to make sure that those waterproofing details at the balustrades and the facades, they were really robust to avoid any risk of water ingress into that timber, because obviously, as you're aware, it can really decay with any sort of moisture.
Yeah, fantastic. Don't want to end up like that guy in Grand Designs who never finishes the roof and it all comes in. Absolutely. That's fantastic. So then, I think moving just from the structure then, and from the images that we see, one of the most striking visual aspects of this building is this series of timber fins that go around the building. What particular challenges did they bring, and how did you set about solving those? Maybe Mark, to you first with the concept.
Sure. So the fins are there for two reasons, really. One is, as architecturally, it's this element which kind of draws you up from the ground level all the way, wrapping around the building and up to the roof. And secondly, they're there because they hide a lot of vents, they hide louvers, they hide cameras, they hide lighting and all sorts of services that go beyond this. So they allow us to sort of create a much cleaner looking building. And they're also geometrically quite complex. Obviously lots of folding. I think Kago, the man in our office who put these together, calls it the Timber Lamborghini. But so it was, we were always worried about kind of if the fins were too straight, A, it could end up looking like an airport ceiling if we weren't careful. B, stability is always a big issue with timber. So that was kind of one of the key drivers. If things are very straight and they start to twist or warp, then you see it very easily. So stability was always key when we were looking at kind of material selection, which we'll come on to in a moment. I think coming back to the issue of cost and sort of viability, which has been mentioned already, we're working for Lend-Lease, obviously. They're a very commercial client, so we had to convince them that we were giving them value for money. And a lot of that was about how much timber did we actually need to do the job that we were doing. So we initially started with fins that were perpendicular to the structure. And what we found was that actually you need a lot of timber to kind of create enough of a screen for what was happening behind. So we ended up turning those through 90 degrees. We've got this parallel arrangement there. And after that, there was, again, a whole series of studies about how deep do the fins have to be, what's the spacing, until we kind of got to an optimum arrangement where we were happy with the job it was doing. But we managed to reduce, I think, the total quantity of timber by something like 60% from kind of the initial rough sketches. And then just in terms of the material itself, I mentioned stability. I think we always thought this was either going to be an engineered timber product or some kind of modified timber. And I think we quite quickly realised that we looked at things like LVL, actually long term in terms of longevity, that was never going to stand up to the elements and risk of delamination. So we ended up with a Koya, which obviously sort of acetylated timber. It's much more stable material dimensionally. It comes with a 50-year warranty. It doesn't mean that it's never going to go silver, that it won't necessarily get spots of kind of mould in some corners, but we accept that it's a natural material. That's part of the story. So that there was the material selection, and then obviously we had to work out how to put the thing together, and that was where we worked very closely with Ayman, who obviously timber specialists. We produced a sort of parametric model based on control points, and then passed that digital model over to them. And they then went through a process of tidying up all of the junctions and optimizing the
way the timber was laid out for cut sheets and so on. So it was, yeah, it was an interesting process, and it's always good to work with specialists who really know their stuff.
Fantastic. And then my same question with you, Kate, the Finns, what challenges did they give you?
Yep, so in terms of construction, there's obviously quite a lot of pieces that we had to put together. We looked at various ways, whether for them to be in cassettes or individual, but eventually we decided to sort of get some inspiration from a paint by numbers and sort of make it build by numbers. So every timber panel fin had a letter, so the operatives on site knew exactly which ones to go where, and it was quite easy to follow along and basically install it piece by piece. Though considering how much they do sort of extend out over the balconies that you can see there, it was really important to look at access and maintenance long term, just with all the CCTV lighting we also had behind the fins, as Mark mentioned. So we did quite a detailed review, making sure that any glass replacement strategies, balustrade replacement, or any items behind the fins could be easily accessible.
Fantastic. And then Ivy, over to you with the technical challenges. I'm sure timber always gets followed with the words fire, and we heard about waterproofing.
Yeah, so obviously because it was external, it's exposed to the elements. So I think at the time also fire was also a big issue, and all the products that were sort of out there at the market at the time required some reapplication, and just looking at the sheer quantity and area of it, you know, trying to get somebody there to reapply anything to the fins, it'll be just a rolling, continuous process. So that was one of the reasons why the Accoya really worked well for it, because it did give a much longer design performance life with the pressure impregnated fire retardant system. Yes, and just as Kate mentioned, the maintenance was obviously a big issue. So obviously getting access to the facade at any time, all areas was, you know, check the width of the openings, the entrances, to ensure that, you know, we can fit a mute through it. There was, you know, all that was done. So yeah, it did present its challenges as well, and also all the bracketry. There's a lot of bracketry hidden behind in there, you know, whereas it's paint by numbers, it was also bracket design by numbers. So it was a never-ending stream of calculations and you know, to get it right. But
yeah, there's this wonderful image as we come around. You see all the different fins and all the bracketry. I don't know if we were all thinking, what was the final number of brackets and fins? I can't remember. It was in the hundreds, wasn't it? It was fantastic.
Yeah, we worked out about kilometres worth of fins overall the entire building.
Yeah, but that must have been a lot of fun from the structural verification perspective.
I will not comment on that.
Late night, lots of coffee. Yeah,
it's one of those. I mean, the fins actually went up in a matter of a few weeks, and it looks incredibly complex. But I think it's fair to say there was hardly any cutting on site, and it's one of those things where you do all the work up front, digitally, you know, digital manufacturing, and everything goes together exactly as you expect. And we were very, very happy.
Fantastic. Time whizzing away already, but one more question for you, I think, is what was it that was a one big takeaway on this project that you felt, as an industry, we could do better than this? Who should I go to first? Mark, you.
I think it would probably be just, in general terms, that we increase people's knowledge about how to work with timber and modern methods of timber construction. Kate's talked about weather, movement. There are a lot of things which are not necessarily particularly complex, but you have to kind of learn partly through doing, and you know, we're part of that. I think that as an industry, it's going to become more and more common. I know that this is, in a sense, a bit of a legacy project for Lend-Lease, which maybe Kate can talk about, the kind of pathway to net zero. So that is something I think we're all going to have to be more familiar with.
Absolutely. With that, tee up, Kate, you.
Yeah, I would agree with Mark. Just increasing the industry's knowledge surrounding working with timber. This building was 40% less embodied carbon than the sort of standard buildings. So whilst it was a great improvement, there's obviously still a long way to go. So it includes obviously using timber much more, increasing the knowledge around waterproofing, moisture, what the tolerance is to get the moisture content of the timber to equilibrium, what that means for the follow-on works as well. It's really important, and I guess all the other companies like Lend-Lease, we're trying to get to absolute zero before 2040. So it's got to be done with products like this.
Fantastic. El-Hibri, to you.
I think timber has taken a bit of a bad rap in the last few years with the fire regulations and all the changes that are happening. But I think there's a lot more coordination that really needs to be done, especially in facade use. I think the structural side has a bit more headway in terms of it's still being used up to a certain extent. You can hide it in different things to give the fire performances that you need. But if you're using timber in facade, it needs to show off as timber. You can't hide it, or else it then becomes beside the point. So I think there's a lot of scope for its involvement, its inclusion, its development, as a material, as a product, in the design space of how we can, as you say, work more with it, and obviously just the quality of the products are being brought out, and the longevity. And I think, unfortunately, the more you have to work more with these things to know and push the boundaries. So I'm hoping that, irrespective of all the fire debacles and everything else, that it'll come back in a way.
Fantastic, thank you. Thank you all for your perspectives today. That's been fantastic chat. I'm hearing, timber, we love it. Catching up with structures. Fire, yes, we know. Don't forget the waterproofing and moisture. That's what I heard today. Thank you very much.
Thank you. Thank you. Thanks. And thanks. Well, this completes and finishes this track session. I'd like to thank all of those who stayed with us this afternoon, and enjoy the rest of the day. And if I can please have all the speakers and panelists on stage for group pictures and the like. Thank you.
I was trying to think how to start this talk, because the funny thing about the towers is they've been part of my life for just about half of my working life, which is interesting and slightly frightening. But I think for those of us in the building industry, buildings take a long time. They're a heavy investment in money, obviously, but in people's time. So perhaps if you'll indulge me, I'll just tell you a few little stories about how this particular job came to us, because it was a rather curious one. As a company, we tend not to do concepts. An architect's contribution to the world is manifold, but the contribution part of the concept, well, that's the fundamental genesis of a project. So if you just do a concept and that's all you get paid for, well, what's the point in doing it? To us, and as a company, as Foster's, we've always been known for the quality of our delivery, so we have to see the whole thing through. So when we agreed to do this particular project, it was just for a concept, but it was too good an opportunity to miss. At the time, Qatar was a fairly underdeveloped country, and it's changed a huge amount since 2006, when this story starts for us. We were asked to create a vision, a landmark, if you will, for a city that didn't exist. Lusail, which you will all see fairly soon when the English football team will no doubt win the World Cup, is now quite a substantial place. But in 2006, it was literally desert. There was just nothing there. So as an architect, how do you respond to something when there's nothing to respond to? It was a vision of a new city that would be for the government and other facilities, but in theory, the government departments would move to Lusail. It was for unknown users. It was for a gross area of about 1 million square meters, give or take. We didn't have a client ready to work with to develop a detailed brief. They just needed a vision, which once created would then spend a few years being shown at various MIPIM events and other such developer gatherings to, I guess, launch an idea of a new place. as an architect, we're always trying to do something which is timeless. And we also wanted to try and do something which sometimes is in contradiction, something which would create a place, human scale as well as city scale. The project was to be at the head of a grand boulevard. The boulevard is exactly the same proportions as the Champs-Élysées, so it's terribly long and terribly wide and rather grand, culminating in this thing. When we did the concept, there was no metro station that ran underneath. 2 or 3 years later, the metro network was integrated, which we had to do some updating, but it was an idea of create a place at the head of a boulevard to announce a new city. That was 2006. Over the years, Qatar had changed and indeed continued to change quite dramatically. And these two pictures at the bottom, which is almost when I was first going there in the early 2000s to today, there was just a phenomenal change. But what was also interesting is that between 2006 and the phone going in middle of 2018, a lot of twisting towers had been built. And our original idea back in 2005, 2006, was to create a series of forms which twisted as they ascended to deal with overlooking and a few other climatic shading criteria. So we were in a situation where time had moved on, our design had stood still, so we were seriously questioning, was the original design appropriate to continue with? Now, the problem was that this particular nation had just run a rather well-known sporting event, so it was firmly on the face of the world's map. So the phone did go in about the middle of 2018, and a few months later we rang this gentleman up and said, what are you up to next week? Because we had to then design the towers, and in fact we were also in charge of the stadium, which the closing match of the World Cup will take place. But we were also under tremendous pressure to deliver the design within 9 months for a project that started out with, if you remember, no real brief and not really a firm area and no client. This time we had 4 separate clients and we had a very demanding schedule, and the project had to have a semblance of completion by the back end of 2022, so 2 weeks' time, and maybe you've seen it on the world's press anyway. What you will see is a fairly complete project, so that's a phenomenally quick construction process. The original design was inspired by climate, probably more than anything else. The diagrid structure, which I'll explain a little bit more in a moment, was the most efficient way of allowing this form, this twisting form, to stand up. It was based on a center core, but the facades rotate as they ascend. The original concept was for a 90-degree twist, which, as we worked with Bob Halverson back in the day, was becoming more and more challenging simply because gravity was just too difficult to deal with, because these towers were 80 floors high. When the phone went and we answered it and we then agreed a fee and started working about October 2018, we had to work to a budget, which we didn't have when we did the first concept. The concept was just limitless. It didn't really matter what it cost or how long it took. So we got a situation where we've got a building, or rather 4 buildings, that have been shown around the world. Everybody knows what they look like, including the Emir of the country, who's a rather important gentleman. We then are given a budget and a time frame, and we're meant to put those 2 ideas together, which didn't really go terribly well together because, well, it just didn't. So we had a lot of head scratching and had to maintain the original concept of something influenced by climate, but also more structurally stable and quicker in terms of how we're going to build it, and somewhat cheaper. So my first presentations to the steering committee were quite interesting ones, because each time I went, I would go with something slightly different that gradually moved away from what they'd seen for the past 14 years, which was this. And I had to gradually introduce them to this, which is achieving a greater amount of twist, which is perfect because of the way the buildings sit on the side. It has a more rational structure because the columns are going virtually straight up and down, not quite. But importantly, the 4 towers maintain the idea of creating a heart, which is where the metro station was to be located, and that the broad facades facing one another at the base would create a sense of a place. But yet, as you ascended, overlooking was minimized and the views out to the sea were maximized. So we kept all the original ingredients of the project, but we had to organize them in a slightly different way. The towers themselves, they started out as 80 floors and 55 floors. Throughout the design, well, the first 2-3 months of concept, because of value engineering, had to shrink in size, which was not only a challenge because you've then got to read all the geometry, but as an integrated team, and we were largely a Foster's team of structure, M&E, all the BIM systems. As an integrated team, we then had to take on board this change. And if you've got a twisting form, that means every floor plate that you spent weeks working out has now just completely changed. So this system, which we call Hermes, was something which our in-house scripting geniuses put together, which meant that at any one time we had real-time transmission of information between us as the architects, the engineers, Evan's team of facade engineers, because we always had to be able to react so terribly quickly because of this 9-month design period. The facade as a concept, as I was saying, came from the idea of shading. So the mullions, the projecting fins, which rotate in almost like a thread on a wood screw, as they ascend the tower, there's a great deal of repetition, but yet, as it's an elliptical form, it's not complete repetition as though if it was a circle as a plan. So there's a great deal of complexity which we had to simplify, A, because of budget, but also we have to be able to build this thing quickly and simply. But the idea of an enveloping skin, which importantly wrapped over the top, because these towers are visible from the flight path. When you fly into Doha, as long as you're on the starboard side going in, you can see them, and if you're on the port side leaving, you can see them. You do get to see the roof, the fifth elevation, as architects often say. It is important, and because the two tall towers were able to look over the lower towers, then the roof is something which is incredibly visible. So as a complete sculptural form, it was important that it had this cohesion. The project itself is also about creating a place, so there are a number of low-level buildings, which I'm going to touch on. We're not going to talk about the cladding of them specifically, but they're an important part of the project because this is not just about a landmark on a city scale. It is about trying to create a sense of place, to actually create a human destination, a series of neighborhoods. 3 of the towers have 3 of the premier banks within the country. One of the lower towers is probably going to be taken by the prime developer. But it is a place where real people have to go to work. And the towers are, forgive me, I didn't mention, the towers are purely office space, and the buildings at the base are support spaces. So it's a living, working environment, and it's surrounded by a huge amount of residential space. So it has to become part of a person's life. It's not just about a vision on a skyline. The interesting thing about the facades that were heavily influenced by shading was that their rough texture aided in the wind modeling, which we had to undertake. And what's fascinating about when you start to do wind tunnel tests is that those results then feed back into the design, into what we do, developing the facades, to then change the design. It's a very iterative process, which, if you remember that image about the Hermes system, each one of these little interventions, a wind tunnel test or another structural test or another MEP consideration, is a completely interactive process and is constantly making a change. We always had an idea that the facade should project to give it a 3-dimensional form, and we always wanted this green color, which is the metal cladding, which Evan will talk about a little bit more in a moment. We wanted that to do as much as possible. So sure, it could just project at right angles from the glass, and you might get a 50-50 ratio. But we were interested in trying to push the amount of solid relative to the glass as much as we possibly could. So the ultimate form was that of something which projected beyond the actual amount of glass if you look in straight elevation. This is an interesting thing because as a designer, we're trying to be as environmentally sensitive as possible. But from a user's point of view, they're always terribly worried about, well, can I see out of the window? So things like mock-ups, and this is Mark, one of my colleagues, and myself on site at a very early stage of the design. This mock-up is as rough as old boots, but it didn't really matter. It was about three-dimensional testing of the idea, checking whether this piece of glass here is sufficiently big enough for someone to be able to see out of, which was to placate the client. But it was also fascinating because it began, and I'm not going to steal your thunder, it began a very interesting conversation about bent glass. Now, everyone knows you can curve glass. Some people say it costs a fortune, others say it doesn't. And some people were talking about bending sheets of glass when they're cold, a completely new technology, which was something which we were fascinated to explore because it would allow us to clad the more acute radiuses, if you like, of the plan form. So we got to the end of 2019, there or thereabouts, with this vision of these beautiful, shimmering sculptural forms. And what was incredibly satisfying for me and for everyone else who worked on the team was this kind of a photograph, which was taken a couple of 3 months ago. This shimmering concept, which we had right from the early days in 2006, was being materialized. It really did look the way we wanted it to, because you never really know. You can build as many mock-ups as you like, you can do as many visuals as you like, but sometimes the only proof is in the eating of the pudding and the building of it. So this was apart from being a huge sense of relief, it was incredibly satisfying and a very lovely series of moments when we realized that this highly sculptural form was to be what we hoped it would be. They are, and of course, I'm one of the authors, so I'm slightly biased, but they are unique, and I think they are incredibly beautiful. They're also stunning internally. The idea of these projecting fins in some of the internal spaces is continued. So the colonnades with largely non-direct light are beautiful places. And even as a construction site, you can sense this is what's going to happen. We used a lot of natural materials. The terracotta on the right is one such example. And the aluminium, which Evan's going to talk about, is left in a fairly natural state. It's a skin which descends to the base. So it very much envelops the whole tower and is modified in terms of its profile as it hits the ground to allow people to enter into the towers, entering amidst a series of streets, which is where the low-level building story starts. These are 3 or 4 or 5-story buildings which have a very simple but strong agenda in terms of being as environmentally sensitive as possible, that we would create shaded streets, that we would use landscaping as much as possible and use tolerant, drought-resistant species. And we also had ideas of exhausting air from the offices into the streets so that we could modify the climate. We were asked, can we air condition the streets, which is a slightly curious concept. It does happen, it is used, but it's so heavy in the consumption of energy, we were always very resistant to employ it. But we did think that we could do something with expelling air that's already been through the low-level buildings to some good effect. The buildings are entered through lovely landscape courtyards, and this human level is the bit I was mentioning right at the beginning. This is where we try and be, and in fact we were inspired by regional and Qatari architecture. The traditional house is something which has a central courtyard. It is often landscaped. It's a very quiet space, and it creates a sense of privacy and an interesting sequence of spaces to get into these buildings. Very briefly, this courtyard, as I was saying, is at the heart of a series of rectangular forms. They're based on a very regular grid, lovely, as tight as we could make them, streets, a series of cascading terraces for the roof of the building, breaking the mass of the bigger block, like a city block, down into individual cubes, and then grouping these together with varying heights so that they all have a view towards the east over the water. Sadly, due to fire regulations, we weren't allowed to make them quite as tight as we would have loved to, but they still are naturally shaded spaces and begin to create a sense of a human scale, if you like, to a project, using as much solidity as possible. One of the contractors did say to me a few months ago, he said, Jonathan, I didn't realize that windows were an optional extra on buildings, because quite a lot of the facades are wonderfully solid, because we don't need to have windows everywhere. We are clever in the way that we bring light into the buildings. We wanted to have the most solid skin possible, again, inspired by climate, minimizing energy consumption, creating internal atria spaces, creating shaded, protected roof spaces, using the idea of the punch window, developing ideas with this fabulous new material, ultra-high performance concrete, which maybe we'll talk about some other day, to create these naturally lit, but as you see here, 22%, very small amounts of glass, but still achieving this lovely naturally lit quality, which, and this photograph's now probably a month or 6 weeks old, is being realized in reality. We have these overhanging portions. We are creating shading streets, and this natural concrete material is a fabulous new thing that we're very happy to have promoted our local building industry. The companies that are making this stuff were used to making precast concrete, but they'd never heard of ultra-high performance concrete. So it can be as thermally efficient, it's much lighter weight, it has less impact on structure, which means less impact on foundations, which means less carbon. It's just a really clever, simple material. And together with landscaping to soften the public realm, and canopies, which are used for illumination as well as shading, we are creating, in a very harsh part of the world in terms of its climate, a series of very humane spaces. Now, as I speak, the temperature in Qatar midday is probably still in the high 20s, but it's just a beautiful climate. So it isn't a dream to be sitting outside in the desert, far from it, especially if your design is smart in the way in which it's put together. So this vision for the World Cup and part of Qatar's 2030 vision overall, and again, you can see these shimmering forms, is something which, I don't know, I think one of the nicest things I think about the buildings, one of the strongest things, is the fact that they actually look as though they're almost solid, which to me is a fantastic success. They're not the usual glass towers which seem to festoon the world. We've been trying as a company to do solid buildings as much as possible because they're actually quite clever. And I think with this one, we're all fairly sure that we've succeeded. This photograph is a few weeks old. The tower cranes have now gone. It's getting ready for the World Cup. You can see the low-level podium buildings are cascading with views to the sea. And I'll close with a very short film, which is the one I take every time I go up to site on the highway. They change whichever angle you're looking at them from. They're just lovely, beautiful things with quite a lot of clever thinking behind them, which is why I'm going to hand it over to Evan.
Cool. All right. Yeah, so I'm going to very quickly now, I can see the clock's ticking down, blast through the facade and how to kind of realize this facade. So as Jonathan mentioned, we started the concept and scheme design in the fall of 2018, and we were at this time employed by Foster & Partners as our facade consultants. And then in the spring of 2020, we were novated over to the integrated design build teams. Towers 3 and 4, the taller ones, were by Hyundai and Harim. The 2 lower towers were Midmac and MIC B6 Construction with Arcadis as the architects. And then Alitech, the Qatari facade contractor. And then we ended up kind of porting over under Alitech to kind of oversee the fabrication BIM model and all of the sort of design consulting to kind of help realize this. So for us, it's a pretty spectacular kind of moment where we get to work through and see a project to reality from, conceptualizing it in Foster's office here and then, getting to make it. So yeah, basically we go from concept, sort of digital world into a reality. I'll talk very briefly about this. There's a lot of, million little threads about this, but I'm going to talk about materiality, shading dominant building, briefly hit the computational process, and then we're going to talk about how to cold bend at scale, because we ended up making the world's largest cold bending project by accident. So the materiality, we have a opaque shading dominant building. There's all the conversations early on were about, I think, authenticity of material and how to how to like make the material do the most for it, both from a structural point, but also from materiality. And how can we make a metal, how can we make a concrete, things like this, and what is the aspects of that we like. And so, you do the normal studies, you study everything, cost benefits, luminance, solar radiation, you're looking at glass properties, projections, and you're kind of trying to understand the sense of everything to kind of evaluate what are your best options here. And then you run through a ton of different options, whether projections, are we changing the facade, are we changing the shape of it? We go through all these kind of things. We end up finding that, by adjusting the solidity and keeping the protrusion, say, the same distance away from the facade, we actually got an architecturally interesting object, but also a very cost-effective object for a shading-dominant building. And we studied a ton of window wall ratios, but we ended up at a 45-55, which was the best use of the sort of glass and also for the sheet materials used to make the opaque elements. And it ended up being the most cost-effective as well. So now we get into materiality, and we studied a ton of different materials. We started with GFRC because of this idea of a matte sort of heavy building of exudes solidity. Looking at UHBC, looking at a more traditional go-to PVF coated option. We looked at a duplex stainless steel. We have all these kind of things that don't work, so we ended up at aluminum, and we actually liked the fact that we could potentially using fully untreated aluminum. So it's a marine grade. The alloy specifically is 5754, and this led to some interesting ideas. And it's something we had used previously. This is the Situ Center in Hong Kong. It's a completely raw aluminum with a mechanical finish. So the fins are an extruded element that have a sandblast. And then there's a backing panel. It's a mechanically brushed finish. And it has a really matte, solid experience, but it's very, very corrosion resistant. Another project we did as well with it was in the Medi Shrem Museum in Davis, California. And this is also a similar, completely raw, it's a raw aluminum with a mechanical abrased finish and perforated, but it has a sense of materiality and of metal, and it is metal, and that's kind of what you want to see. And so, another super kind of great advantage of aluminum is that you can tailor the supply chain to really look at your embodied carbon. And in this case, working on the design build team, we were able to really identify a supply chain that we could move all the sourcing of the aluminum to a European production and bring it into Qatar and greatly reduce the amount of embodied carbon in the building. And you making this much aluminum, you really have to think about these things. Another interesting and particular challenge of this is the reflection. You've got a raw material and it's metal, and you're kind of worried about burning stuff or creating uncomfort things. And so we did kind of localized pedestrian reflection studies and also a wider kind of kilometer radius reflection study to look at the impact of various types of specularities and treatment and sort of treatments on the metal to determine if there's any issues. I co-opted Jonathan's video, but we ended up finding that actually we have some problems at higher specularities of the aluminum that we have to actually treat it in some way. We found that we can't do the mechanical abrasion because it's too cost effective and we have a crazy time schedule. So we got to do something else. And so we went to anodizing, and we did a very light touch, like 10 microns, just to cut the specularity. And Alutech, the facade contractor, purpose-built, I think, the deepest anodizing bath on the planet to do a 2.6 meter wide panel. A little quick video of it. So, they built this very large anodizing bath for us to make, I think there are about 60,000 of these individual triangles all in a very short amount of time. There it is. And what's really beautiful about, I think, a metal as close as you can get to it is that it really changes in the light, and it really absorbs the sort of environment around it. So I have these series of drone shots taken by Hyundai. These are all on the same day, actually within minutes of each other. Depending on the angle of orientation to the object, you get a totally different kind of reading of the building and understanding of it. Okay, move on. The computational process is another into this as I'm moving quickly here. So working on the sort of design build side, working for the contractor, we have to feed the beast. We have to make this building as quickly as possible. And we're in charge of producing all the fabrication information for this building. And so just to like go back and give you a sense of it, we've got about 411,000 square meters of total cladding area. 85,000 of that is cold bent glass. We've got a 445 millimeter out of plane maximum for the cold bending. And we've got about 8.5 million fabricated parts we have to get through very, very fast. And we have a 1.2 terabyte facade model for all the fabrication information. It's just, that's not including the production information. It's just a lot of stuff, a lot of data. And so stepping back, kind of this is something we've been doing for a long time. We did a project 8 years ago. We started this now. It's kind of crazy. We worked similar role for the facade contractor to realize the Moorfield Hotel's freeform cladding. And it just sort of crystallized a lot of the technologies and thought processes that we use to sort of deal with intense kind of complexity and very tight time schedules. And I think at the core of it, and I use this project because I have this slide, it's about like DFMA as a process where every aspect of design, not just designing the part, designing the information workflows from, being an author of something, I know how to put this together, but I have to tell 100 different people how to cut thousands of different parts. And I got to tell another 100 different people how to put it back together. To go from a model to a little tiny part back to a constructed object, I think is the core of the DFMA process. And so that led us to, we call up this term procedural building information modeling. It's basically a collection of technologies, methodologies, thought processes that kind of culminate in a sort of procedurally generated networked BIM model, and it results into a fabrication information in the end. The other side of that coin is El-Hibri. It's a kind of a data management, information management, interoperability tool. It's freely available if you want to get it. And it's the other side of the kind of procedural BIM bit. Things goes, yeah. See, the core of all of this is basically a graph-based modeling approach where complexity arises from very small interlinked models to arrive at basically as much detailed information as you get, because you can't start this process knowing how to get to the end. It's an organically growing, sort of ever-changing modeling process that's made of thousands of little interconnected moments. And which is nice, it's highly collaborative. It can be run by relatively small teams. And it allows you to just generate complexity from tiny little things. Part of the core bit is the data inheritance. So this kind of takes you through one object as it moves from the model to the factory. You'll notice on the side the kind of amount of metadata that's available for that part kind of grows as it goes through. What's nice about that metadata is it's completely searchable, completely indexable, and allows you to kind of move something very easily from this idea, from wireframe, all the way to actually making these products. And that's kind of the core bit of this. Other bit is interoperability and analysis. So representing the data, representing the model in as many different forms, like we can make a Revit model, you can make a fully formed FEA model, you can see the things in different ones, you can pull out information, recombine. All this is super important, like taking this, making an FEA model, same model then represented as a bill of materials, keeps on going, make a drawing. It's all the same model, same bits. What's cool about this is you can also store infinite amount of information. In this case, we store all the CNC data inside, say, the holes, all the cutting bits, so we can automatically tell the CNC machines how to make the part from the part itself. So it's kind of goes into that. That leads to this, how to make a ton of fabrication information as quickly as possible. So in this case, we had 18 months or so to make, I don't know, a few million unique parts. And this is sort of the timeline as we're ramping up the production to feed the factory to build the products. Let's see, how many unique parts do we get? 1.3 million, okay, that's pretty good. Yeah, so it leads you to this, cold bending at scale. Okay, we're running out. So thinking about, going back to them and thinking about the architecture, and we start with these sort of like, how do we wrap this building? And the kind of first thought is you triangulate everything, because you can cover any surface with the triangles, but it ends up being, you end up creating an unfortunate mullion in the middle of your view, which kind of goes against, it's not great for the office. And you actually get pretty terrible thermal performance, you get a lot more material, it's actually no good. You look at, okay, making some planar quads. It's actually really interesting geometrically, but you got little fiddly bits between the panels, which drive up your fabrication cost, increases the time to make it. Your thermal efficiency is bunk, and it costs a lot more. So we're like, okay, well, actually, the only way to do this in the time we have is we have to cold bend everything. And it kind of meets all the requirements, but then we got to figure out actually how to do that. So back to the thermal stuff, just because it's kind of important. So on the left is a kind of the thermals of, say, the cold bending facade. But as you kind of pop, say, the planar quad one back and forth, you end up between 9.5 to 30% worse thermal performance, which, you know, on a grand scheme is actually a huge amount of extra energy you have to pump into the building to maintain an adequate thermal comfort. And so through all cold bending and through all of the sort of things we did as a design team, we kind of beat the sort of GSAS requirements, it's the local LEED equivalent or green building equivalent, by a 31% margin. So we have for the Middle East, a very high performing facade, not London, but just the Middle East, we have to remind ourselves. So for cold bending, there's basically two things you got to think about. One, the glass design, two, the frame design. I'm going to go to this. So if you take a frame, for example, and then you push it, all your members rotate. But however, from the architecture standpoint, we cannot have a rotating transom because the transom is aligned with the finished floor. So on the top, on the right, you have kind of three options. The rotating transom doesn't work. If you kind of have the mullion, but the glazing tape no longer is consistent, that doesn't work. So you have to find some option that allows the glazing tape to be consistent, and also the transom to be consistent. Another kind of quirk, since all the mullions are twisting, you end up installing, say if it's a flat panel against a twisted mullion. In this case, you have a very long tail, up to 20 degrees of twist, that it just won't work from an installation perspective. So you have to actually make the panel in 3D in the factory. And so what we did is we figured out a way to do a complex miter at the transoms such that when you screw it together, it automatically pops into a 3D shape. And then what's nice is also keeps the transom perfectly horizontal. And you do a little micro relaxation of the mullion to pull it up so the glazing tape is consistent. So that does two things: continuous glazing tape, but also no permanent stress in the structural bond from the glass to the frame, which is actually super huge because you just eliminate that aspect of it. So we talk about the glass. So now we got to how do we make the glass to actually fit on the frame? So conventional means are take the wireframe, you make a surface, you unroll it for fabrication. But we find that doesn't actually work in extreme levels of cold bending. So this is the whole building. There's 550 millimeters for the opaque, but we're at 445 for the glass. And the reason why is because your CAD software, you're defining something, say, by 4 sides. Once you apply material properties and engineering kind of real life constraints to it, the shape deforms in the middle. And so the CAD software has no idea what the shape of the middle is. So we need to find a way to actually figure out what that shape is in the middle and do it at a massive scale. You can kind of see here, this is the panel above, the exact same panel above. You can see that there's flattening across the diagonal as you kind of move into shape. You've got a high level of curvature due to the overall flexure of the panel. So these are the kind of things we have to figure out as we go through. Another interesting phenomenon, I'm kind of going super fast here, sorry, is that as you deform it, the shape of the sides actually pull in a very slight amount, and something you have to account of, because you can imagine here, you've got this variation along your glazing line, and if you don't take into account, you've got a shifting about 6.5 millimeters, which for your silicone applications or your sightline is not good to deal with. So we need to find a way to eliminate that. So the way to solve that problem is first you have to categorize what types of shapes you have. So we roughly have 4 classifications of shapes, different kind of edge conditions. And here is the same 4 shapes, but you can kind of see the amount of curvature is very different for each panel. So this leads us to okay, we have to think of a way to do this in a way that we can actually predict this. And so through analysis, through some testing, through just some time, we find that there's basically 3 parameters: the top, out of plane, and the curved of the edges. You could use those 3 parameters and derive some sort of function to give 7 points on the surface of the glass that would adequately describe the glass shape in the middle. So we don't know that actually. And so here's an example of that. And so we're taking these three parameters, and we get these kind of depths from a straight line at these points. So this is actually a really good real-world example of machine learning from earlier today. So we need a way to predict the shape of the glass. And what we do this is we run basically a shape function, or we determine we fit a curve or fit a function to a data set. And the data set we generate from thousands and thousands of simulations to train a model to predict what the glass will be. And so abstractly, this is what it is. You know, have to show, there's too many dimensions here, so we don't have enough, you know. So basically this is the depth at the top, the parameter at the top, the depth, and you know, one aspect of, say, one of the points, right? You can synthesize that across three kind of input parameters for a single point. And through that synthesis, you can kind of predict the topology of what those points will be. And these points themselves are derived from this material simulation, this sort of learning matrix you have to make. So basically you end up, you know, creating basically fitting a function for all these points through this simulation. So I'm trying to get to the video, here we go. So this is our training model. We simulate, I think we started the database with like 3,500 panels, just simulating the shape, slightly change the parameter to create the data set to do it. And this is, well, just all the panels. It's visually interesting, so. Okay, it's a lot. It's a long story. So this is the new algorithm you end up with. You take your three input parameters, you map them to your shape functions, it generates a twisted shape, okay? And then through the cool use of metadata, you can push that information to an FEA solver, you flatten it, you then extract the 2D outline, push it back to the 3D federated 3D model, and then you simulate it into 3D, and then you measure it against the 3D outline in the real shape is what we have to meet. If it's out of tolerance because you don't have the data, your function doesn't fit the data set that you have, you measure it again, you add to the database, you retrain it, and you bring it back in. And all of that to produce a really dumb fabrication drawing at the end of the day. But that's how you do it. Produces a ton of different shapes, installs, you know, have a 3D installation into a little bit. So this is February? Yeah, February. We get there. This is 3 weeks ago. I don't know, a couple months ago. We'll end with this, and then we're done. So all of this accumulates in how to install this thing, and I think the peak installation was 206 panels per day of super complex, highly twisted forms. The contractor let me stick a 3D camera to the lift, which was fun. So we got this out of it. And there's a whole other story about the opaque panels, which is a crazy bit, but another time. Yeah, I think it's done. Yeah, at some point.
Welcome.
Thank you very much. Both of you. I mean, we could spend a whole event just talking about this project and the execution. It's an absolute tour de force of design and of execution. And all I can say is well done, both of you. Thank you so much. We're going to have our last talk of today. Our speaker is lurking over there, ready. It's Tony Ryan. He's Chief Technical Officer at SideRise. He's going to talk to us about managing fire risk in the structure and the external walls.
Thank you. We good? Next back. Okay, super. Thank you. Thanks everyone for your attention. Really appreciate the opportunity to present. Obviously, last speaker. I'll try and be as quick as possible before the panel debate. I'm going to focus on curtain ones. Just to introduce myself, I'm the CTO of SideRise Group. I've been really impressed with a lot of the projects that have been presented today, but particularly Lucille Towers that was just presented a few moments ago, whereby SideRise passive fire protection systems were within the facility. I'm not quite sure if you could see in the last video, I did spot some of the SideRise logos. So logos. So really nice to follow on from that presentation. I'm going to kick off with quite a few slides to get through. I'll try and run through them relatively quickly. As I mentioned, I'm going to focus on passive fire protection, specifically for curtain wall and systems. Just to introduce the group, we're 50 years old this year. So we had some celebrations during the summer. It's quite an achievement for ourselves, and we're quite pleased to be in existence for those 50 years. During those 50 years, we've accumulated a lot of intellect, knowledge that we like to share within the industry. We have in excess of 300 large-scale fire resistance tests completed. Our products have been used in excess of 300 large-scale reaction to fire tests, such as NFPA 285 and BS 8414. During that course of time, obviously, we've collected a lot of knowledge, a lot of data that we do like to share. And you can see from the slide here, predominantly manufacturing in the UK with distribution and sales channels throughout the world, really. So yeah, just to kick off, what I'm trying to cover today very, very quickly, just to outline all curtain wall and systems, or predominantly all curtain wall and systems in the UK are non-fire rated, they're aluminium. As a result of that, we do see structural loss of aluminium happen in excess of 300 degrees Celsius. As a result of that, it can create voids due to buckling and deformation, which fire stopping within the curtain wall and system needs to cater for. I'll discuss that. I'll also discuss some of the testing associated to passive fire protection within curtain wall and systems, what we're currently working towards, and what potentially we could be demanding going forward in the future. Just as a backdrop, I think this was mentioned earlier on in terms of the Whitechapel fire in East London, which happened earlier this year. It's an example of a fire which has happened in a curtain wall. March 2022, fire occurred on the 17th floor. As you can see some of the pictures, that it looks like there has been fire to break out through that window and actually enter the zone above. Passive fire protection systems in curtain wall and systems try and eliminate this from happening, essentially. So it's sad to see that it has happened with the Whitechapel fire in East London. Interesting that, you know, the Fire and Rescue Services sent 15 engines to site and 125 firefighters. There was no reported fatalities, and the cause of the fire, I believe, is still unknown. Just a little video just to explain two things. You know, perimeter fire stopping at the slab edge is there to prevent fire spreading vertically between the curtain wall and the slab edge. However, that's not the only thing that needs to be considered. The spandrel zone is absolutely critical as well from a passive fire protection system within curtain wall, and particularly to try and eliminate leapfrog effect. I'm sure the majority of people in here are familiar with leapfrog effect. There's various different tests, which I'll talk about in a few moments, that cater for both spandrel zone and fire stopping at the slab edge. And there's other tests that only look at fire stopping. We believe, you know, tests that combine both represent, you know, as-built configurations as best as possible. Just to introduce some of the products and essentially solutions that we have, you know, you can clearly see we test with non-fire rated systems, so curtain walls that are aluminium. We have a perimeter fire stop to provide compartmentation. We also have, you know, spandrel boards or fire protection systems within the spandrel zone, which is required for EN 1364 Part 4, which I'll talk about in just a few moments. And we've also got mullion covers. So this system can be subjected to, you know, robust testing to EN 1364 Part 4, which again I'll talk about in a few moments. Just as a backdrop as well, in terms of fire safety, compartmentation is within regulatory guidance in the UK. It's very, very important that curtain wall facades are tested and leapfrog is prevented to the best of their ability. We believe EN 1364 Part 4 helps to do this. And something that's often forgotten about, it's not particularly regulated, but in terms of best practices worth noting, is the need for fire stopping and passive fire protection systems in curtain walls to cater for movement. Okay, so it's absolutely critical that movement within curtain wall and systems is catered for with respect to fire protection. And again, I'll talk about that in a few moments. But just a quick synopsis of regulatory guidance across England, Scotland, Wales, and Northern Ireland. To be honest, if we take a step back, there's typically, traditionally European standards and there's British standards. Still routes to compliance from a fire resistance perspective with passive fire protection systems in curtain walls. With respect to the European standards, the EN 13501 Part 2, that makes reference to 1364 Part 4, which I'll show you in a few moments, and also 1364 Part 3 for Type B fire-rated systems, although I think fire-rated systems can be tested at 1364 Part 4 also. But with respect to BS 476 Part 20, it is a fire resistance test. However, you're testing the fire stop material in isolation. So it's useful to note that, and we'll show you a quick schematic in just a few moments. Also, in terms of best practice from a side race perspective, and in terms of integrity in all we do, we like to adhere to testing to best practice. We adhere to the ASFP Advisory Note 7, whereby it makes recommendations to use EN 1364 Part 4. It also says EN 1366 Part 4, which is testing products in isolation, should not be used. With the curtain wall and product standard as well, it makes reference to EN 1364. With the EAD, it makes reference to cycling. Cycling obviously caters for movement within curtain wall and systems, and also the CWCT earlier this year have noted the potential for their technical note 98 to change to make reference or recommend EN 1364 Part 4 also. That is yet to be finalized and published. So what do I mean by testing products in isolation? So you take, for example, EN 1366 Part 4, BS 476 Part 20. Typically, you're testing a fire stop material in isolation with brackets between two concrete slabs. Okay, you're putting it through a furnace. Over time, you get a period of fire resistance from integrity and insulation. I'm not going to explain that because I expect the majority of people to know that. But you're testing a product in isolation. It's very different to EN 1364 Part 4. We believe it's the correct standard in the UK to adhere to, even though regulatory guidance still makes reference to the BS 476 Part 20 standard. It caters for dynamic post-flashover pressurized. It caters also for dynamic testing. It tests a product, tests a spandrel zone as well as the fire stop, so something that's more representative of what you see on site, which is very, very important. Again, it's a fire resistance test, but you're testing an assembly. And more importantly, you're testing spandrel protection, fire stopping in conjunction with a curtain wall. Okay, so you're testing to the best of your ability an as-installed system with respect to fire resistance. It's the best that's out there at the moment, we believe. Movement is important, and I can't stress this enough because I think it's often not catered for, or sometimes forgotten about. I think everybody in this room understands that curtain wall facades move. There's various different loads, from seismic, depending on what part of the world you are, to thermal loads, to wind loads, etc. Settlement. And for the fire protection systems, passive fire protection systems, such as a fire stop that you can see here, to be able to cater for that movement is critically important in terms of resilience of the building over time. Okay, so buildings will move over time. Of course, the time, say 40 years, you can imagine the amount of cycles that building will go through in terms of this movement. You've got to have confidence that the fire stopping system and passive fire protection system installed in that building will last the test of time, which is sometimes not catered for. One of the best ways to deal with that is by cycling the passive fire protection system or the fire stopping material. Collaboration with facade manufacturers. So we've collaborated during our 50 years in existence with various different facade manufacturers, and you can see a few on the screen. Obviously big names, and some of them are here today, so we do really appreciate the opportunity to collaborate. We have to do that because we enjoy and we think it's the right thing to do with respect to testing in conjunction with curtain wall and systems that you'd see installed on site. Critically important. So this is what the test looks like. I'm not quite sure how many times I've said EN 1364 Part 4 just yet, but I'll say it once more just for the fun of it. But it's a robust test. It's the best that's out there at the moment. You can see it's a curtain wall and system. It's a large furnace. It's a 3.5 by 2 meters in terms of dimensions. It's you can see there's a spandrel zone. I don't think the laser is working very well, but there's a spandrel zone. and your fire stopping between the slab edge and the curtain wall. Reflective of what you'd see on site. In terms of fire resistance, we get different periods of fire resistance from 30 minutes, 60 minutes, 2 hours. We've some systems also tested at 3 hours, so depending on the thickness and the specification of product or the system, you can achieve different periods of fire resistance. Just want to take you through another project actually in the Middle East, so following on from Lucille Towers, it's another project in the Middle East. Typically, we might get construction details or project details. We'd work very heavily with the design team, we'd support them by your side, and we would then move on to making sure with that design team that there's regulatory compliance in the UAE, in the new UAE Life and Fire Code, which is under review at the moment. Will be released, a new one will be released next year. But even at the moment, there's the provision for EN 1364 Part 4 in the UAE. We do help with in terms of on-site training, on-site inspections. We've got an inspection app that contractors can use themselves, generate reports, send them back to us. We'll tell you if the installation is in line with our recommendations. And typically you see a project delivery, which we'd support contractors through. So it's not just about testing and selling products, it's about being involved in the design team, the specification, the training of installers, making sure specifications are correct, making sure on-site training is delivered, the site supervisions, and there's the recommendations that we make, and making sure that projects or products are installed on projects in line with our recommendations, which is critical. Our recommendations then are backlinked to test evidence and the knowledge and know-how that we've built up over the 50 years in existence. And I said to myself I'd make back some time. I'm almost finished, which is probably a good thing. We heavily rely on third-party certification as well. So EN 1364 Part 4, curtain wall and fire resistance standards is third-party certified. And what does that mean? I'm not quite sure. People often ask for it or think it's a good thing, but not often do people fully understand what third-party certification actually means. And I've listed a few things on the screen here, which is important. So upon third-party certification, there's an audit of our quality system, there's an audit of our factory control and processes, there's witnessing on manufacturing. So speaking to someone from UL earlier, we have UL certification with the various different products. They come to our factory in South Wales, they witness the manufacturing of products, there's verification, obviously product testing, review and assessment of test evidence, certification is issued, and then one of the most important things, the ongoing surveillance and ongoing auditing. So auditors from the likes of Certifier, UL, etc. can actually come to our facilities, sometimes unannounced, and say we're going to carry out an audit of your facility to make sure the products you're manufacturing today is in line with what we've audited first day prior to testing. So just to mention a few of them, Certifier, Intertech CE, got UL, mentioned UL already. Hope to have UKCA by December 22, and earlier this year we got Emirates Safety Laboratory. I think we were the first ones in the UAE to achieve the ESL certification, which we're very pleased with. With all this comes a lot of administration and work in the facility, but it's worth it. I think all of these brands command respect in the global facades industry, and we like to adhere ourselves with best practice. So we think it's the right thing to do with respect to not just testing, but making sure testing is certified with third parties. Just to finish up, basically, I think I've got 30 seconds left. I've just a quick timeline, but I really want to just focus on two elements. 2012, Sideways first launches. Sideways launches first tested and certified EN 1364 Part 4 perimeter seal on the market. So it's not a new standard. It's 1364 Part 4 is not a new standard. It's 10 years ago. We're celebrating a decade of 1364 Part 4 testing this year. However, it's critically important that it's embarked upon, because I think the industry is not fully aware of the benefits associated to 1364 when compared to some of the perhaps less onerous standards on the market. And yeah, 2022, we've seen a lot of change, a lot of trade bodies turn and recommend EN 1364 Part 4. So just to finish up then, we believe in robust testing and certification is key to ensure performance, There's currently a reliance on BS 476 Part 22, which tests a product in isolation of fire-stop material. It doesn't include curtain wall, doesn't include protection of the spandrel zone. Similarly with EN 1366. We think it's time for the industry to move forward and use best practice. So very happy to take any further questions or contact me on LinkedIn, no problem. LinkedIn, Tony Ryan, and thanks so much.
Thank you very much, Tony, for taking us through that. We are pressed for time, so I'm going to call our panel discussion. Unfortunately, our moderator, John Downs from Lend-Lease, is unwell and is not joining us this evening, but I'm glad that the rest of the panel is here. So I will announce them onto stage, starting with David Metcalf from the Center for Window and Cladding Technology, who will moderate the panel this evening in John's absence. We have Zara Edwards. We have Tenny. And we have Damien. And we have Will. Thank you. Over to you.
Thank you very much. So welcome to this panel discussion on the topic of, is the facade industry responding to the climate emergency? It's been a long day. We're running slightly late, but thank you very much for staying right until the end. As Stephen has said, and you probably noticed, I'm not John Downs. John does send his apologies. He was very much looking forward to chairing this session. Yeah, you've got me as a substitute, I'm afraid. So I'm going to be both moderating it and being a panelist. So I will be asking myself questions at times, which might be slightly odd, but we'll manage with that. That's fine. Stephen's introduced our panelists already. So in the interests of time, I will just crack on with the session. So I'm sticking to John's plan, as I'm a last-minute substitute. And John wanted to really try and understand how much the guidance that we've produced is getting out to industry. So I'd like a quick show of hands, if I can. How many of you work for CWCT member companies? Good, quite a good number, quite a few, that's good. I'm pleased by that, thank you very much. Who's aware of the recent work that we've been doing in terms of sustainability? Again, good, I'm very pleased about that. Who's downloaded it and actually read the guidance that we've produced recently on sustainability? Slightly fewer hands than the last one, but still quite a few, so that's good. So please do look at that guidance. Please read it, please digest it. And you all have a really important job to do. I want you to spread the word. I want you to tell people that the guidance is there. We need to, the industry needs to be part of this journey. So we all have a really important part to play. So please do, read that guidance and spread the word. So I'm going to sit down. Oh, that's better. You've heard enough from me already, but actually the first question is also to me, so sorry. I told you it'd be slightly weird. So John's first question was to ask me to say a little bit more about the work that CWCT is doing in terms of sustainability and what our sort of aims and objectives were. So we were a little bit late, I think, starting our work, but we've done a great deal in a short space of time, and I think we should be very proud of that. There is, of course, lots we still have to do, and hopefully we'll talk about some of that future work a bit later on. Our initial aim was really one of education. Whilst there are clearly lots of people and lots of companies who are very knowledgeable about sustainability and who work on projects where sustainability is a key driver, there are more people for whom sustainability is completely new. And because it's such a complex subject, it's quite daunting. So we felt we had a role in supporting those people upskill and better understand the impact that the facade has. Call it levelling up, if you like. Without that knowledge, people can't affect change, and I think we all recognise that is what's needed. So we established a sustainability committee, and we identified a number of different areas that we thought guidance was required, and we established work streams to provide specific guidance on those areas. You've already heard about the first one. That was looking at embodied carbon and our methodology, which we believe is the first methodology specifically related to calculating the embodied carbon of facades, was published in September. Having consistency in those calculations is obviously really important. We think this guidance document will help a lot with that. And we also think it will help make the analysis more widespread and more mainstream. We also have work streams looking at refurbishment, circularity, how sustainability fits into the plan of work, carbon thread, and LCAs and EPD. So there's an awful lot going on at the moment. And very quickly, one of the reasons we've managed to do so much is because of the willingness of people to help support us. The support we've received from our members has been fantastic. It's really inspiring, and I think it's important to acknowledge that. So thank you all, everybody who has participated in the work we've done so far and who will participate in future work. As part of what we've done, we seconded Will and Tenny for a short period of time to really accelerate our guidance, and I think that's been really successful. Tenny, do you want to just say a few words about that from your experience?
Yeah, as David mentioned, so myself and Will, we were seconded to the CWCT as part-time roles, and we were working on the embodied carbon methodology work stream primarily, but also had a chance to work with a lot of other people within our industry on other work streams. And it was a really fulfilling experience, just because not only did we get the time to think about a lot of these issues that we have in terms of sustainability and the challenges of making the facade more sustainable, and how we communicate this on projects and quantify it, but part of this process was us working with individuals that would typically be our competitors sometimes. On this work stream, it was myself from Bureau Happold and Will from Arup, and we had other colleagues here that are on the work stream today from Windtech, FMDC, Thornton Tomasetti, Lend-Lease, and we all worked together to tackle these big issues. The biggest issue that we were facing in our group was creating this methodology, and it was a knowledge sharing process as well, because there are things that potentially I had a good understanding of, but others didn't, and it went both ways when we were doing this, and ultimately that was a benefit because we were able to get a very holistic approach from what everyone in our field is really thinking about, and in terms of embodied carbon with facades. And the document that we've created today, I think, is really robust as a start. We've got a lot more to do, but it was just a really good experience just to make sure that we were getting a lot of voices from everyone in this industry to create this document.
Great, yeah. Thank you very much, Sunny. The next question is to Will. I've explained a bit about what we're doing as CWCT. How does that fit into wider industry initiatives? What else is going on?
Can you hear me on? You can hear me on this mic. It's a great question. Obviously, here today is all about facades, but we really need to be mindful of how we fit in with the rest of building design and the wider industry, and even more broadly than that. So a few things that stand out to me: the Department of Business and Energy's Environmental Audit Committee published their report onto building net zero end of September, I think it was. And that makes clear recommendations to government that they've got to mandate whole life carbon assessments for buildings over 1,000 meters squared by the end of next year. And they've also got to set progressively ratcheting targets to go alongside that, so we can hit our legal obligation for net zero by 2050. There is a bill making its way through Parliament at the moment that sort of supports that and regulates those two things. That doesn't mean it'll become regulation, but it's certainly a strong signal in that direction to me. Inside the industry, I'm involved with the UK's net zero building standard. I can never get that acronym right, but there's a standard underway to define what it means for a building to be net zero carbon. And I can tell you now, it'll include limits on whole life carbon, and it'll include limits on building energy use. I think there's an update to publicise that more broadly coming later this month.
Yeah, thank you, Will. So collaboration is really important. You mentioned that, Tenny. You mentioned that before. Tenny, what's your experience been about collaborating with other organisations?
Yeah, so in addition to just being able to collaborate with other consultants and contractors, and just with my time at the on secondment, I've been able to reach out as well to wider industry with architects, with RIBA, CIBSI, with those that are more focused on building services. And through that, we've written some articles that kind of promote what we're trying to push out there in terms of how to consider the facade, start to think about some of these interactions and how we can work together to make the best decisions. And this has been nice because at the end of the day, I think it's clear that we all want to meet the same goal, and we all want to do our best to reduce our impact. So it's been very welcoming, I think, in terms of just the wider industry and collaborating and being open to that. So yeah.
Good. Long may that continue.
I would add to that. My experience was that some of the other parts of the construction industry are really interested in how facades tackle a low carbon transition, because in many ways they recognise that how facades do it is the problems that buildings face more broadly. We can't focus on embodied carbon or operational carbon by necessity. We know we've got to think about whole life carbon, and also we have to grapple with the fact that facades are the face of the building and will define what a net zero future actually looks like. And I don't think those are easy questions to answer.
No, and we may come back to those later. Great, thank you. So there's clearly an awful lot going on at the moment, and that's got to be encouraging. Zara, taking all of that into account, how would you say how are we doing as an industry in trying to address the challenges that we're facing?
So there's been a lot of learning going on. We've been given a period of grace, I would describe it as, to get up to speed, learn, share, wait for the industry to get on board with it all and make the changes. And this period of grace was recognised by Letty when they first wrote their guidance. We're now end of 2022, and according to that guidance, we should have 40% of our new buildings at net zero carbon now. So I'll let you think about that. Reflect on your portfolios and think if 40% of those are net zero carbon. And it's hard when there's still guidance out there defining exactly what net zero carbon is, as Will said. But that's something to take away, and if not, probe your companies, probe your clients, continue to put the pressure on. In terms of how we're doing, maybe looking at it in 4 ways. Number one is close the skills gap. So we're doing that, and CWCT have done a fantastic job. We're a community of facade engineers who are sharing everything, which is amazing as competitors in the first place. So I think that's a big tick. There's plenty of work still to be had on that. The second is setting targets. And as designers, you don't get the best out of your engineers without targets. If you think back to Part L, how far that's pushed us, particularly with the aspiration to have all glass buildings as it was not too long ago, really pushing the facade performance there. We could do the same for carbon. We just need to draw attention to it. Even if you're not comfortable, if you don't have those targets, you're just going to carry on as you were. And on that same theme, the targets are, there has to be buy-in by the clients. And I came across a template produced by RIBA, who are helping architects approach their clients to buy into those targets. So one of them is operational carbon targets, and the fact that they need to produce the data for energy consumed in the building for the first year post practical completion. And the second is the whole life cycle carbon. And then there's a little bit at the end that says there aren't any issues if you don't meet that. You're not going to be told off. And then the second is it's all anonymous. So I think there's a problem with producing and recording data like this, in that it could be seen as a reduction of the value of the building and the asset. So that's important. You can produce it and share it anonymously, and the various platforms that can be done. The third one of how are we doing, that's on operational carbon. So we're obviously pushing the buildings to the extreme, but there's a lot to be done there, because there's a performance gap with what we anticipate and what's actually happening. The platform Carbon Buzz, which was endorsed by SIBSI and REBA, they've collated real data since 2006, and they found that there's a difference of predicted energy use and actual energy use of between 1.5 to 2.5 times. So that's something that still needs focus, but maybe not by the facade industry, more about just understanding what people are doing inside their buildings. And then the last one, how we're doing, is just mindset. I think hopefully just by talking about it all this time, we're changing our mindset. There's a social awareness of wasting materials and energy, and we're all starting to challenge the brief more, I would say so. I think you would agree that we are doing that. And you can see the evidence in that with the outrage when you hear about buildings that have been demolished. There's a lot of stuff in the press about demolished buildings at the moment.
Great, thank you. Damien, how do you think we're doing?
I think we're doing okay. I'd give us a B-, I suppose.
You've got to start somewhere.
Yeah. I'd agree with Zora's points. I think the awareness is much better. 2 years ago at this event, there were a lot of talks about sustainability, but people were kind of grasping for a hook for themselves. I think a year ago it was 100% of the presentations talked about sustainability in some way, but now we talk about it, and it's much more casual. Like, people are putting numbers on the screen saying, reporting what the embodied carbon they're measuring, and we in the audience are looking at it and go, oh yeah, we're there's more sharing. I think we've got more awareness of what that number means, and so I think the educational is getting there, and the guide is helping us to get there. Are we seeing the people make decisions for the right reasons? I think that's still, for new buildings, we're starting out in a good place. I think we're being set embodied carbon targets, and being measured by those. There's still, I think, beyond embodied carbon, there's a long way to go. I think, as Zara said, about retention of buildings, refurbishment, we need to be much more open-minded. And we might talk about the aesthetics later, but there's a long way to go.
Will, do you have anything to add?
Yeah, it's how we're doing. It depends how you measure progress. We've come a long way. Yes, we've got a long way to go. One thing I'm always mindful of is the targets that we talk around at the moment are derived from what have we done before? Okay, take off 5%, 10%, 20%. That doesn't mean it's sort of compatible with a certain level of warming. And if you look at it the other way and say, okay, well, let's aim for 1.5 degrees warming. There's a certain amount of CO2 we can pump into the atmosphere for that. How much of that belongs to the UK? That's a really challenging question to answer. But people have put numbers to it. A certain amount of that belongs to construction, and a certain amount of that belongs to facades. And when you do it that way, whilst they're still scrubbing the numbers, the targets are an order of magnitude lower than where we are today at our best in practice. And that's really hard to hear. but really important that we do hear it. But it really frames what Zara's been saying, how we look at refurbishment and retrofit, being open-minded to what we can do and branching out more and thinking, well, really, what can a new facade bring to an existing building? And we need to be able to put numbers to that and be held accountable for it.
Actually, you've all mentioned numbers and data there, and I just want to reiterate the importance of sharing information. We now have a consistent methodology that will allow a consistent calculation of embodied carbon of facades. So please use it. Use it and share those results. We need a better understanding of the real impact. Now, there are various figures out there. I think Letty suggests the facade is responsible for 13 to 17% of the total embodied carbon of a building, but we don't know if that's right or not. So use the methodology, report the results back. I think we need a better understanding of the true impact, and that will allow more informed decisions to be made, I think. So, excellent. Okay, moving on and leading on from that, another important question. Damien, I'd like you to start with. What are the key challenges to around low embodied carbon design?
So again, I think we're getting familiar with the numbers. We are struggling to find really the way to. We'll set a target in the beginning. I think following that through from design through procurement to reality in the end is a struggle. Where I think getting the availability of the low carbon products, I think Stephen showed it earlier that we are routinely now, I think, showing, this is your business as usual embodied carbon, this is your low carbon option, can we achieve this? But there's, I think, very little understanding often. There's a bit of greenwashing going on. The people who are doing the assessment, which often aren't us, are putting in artificially low numbers that we can't really achieve because we haven't got through the procurement, really having confidence in how to secure that material. Is there actually enough of it? Am I actually really going to be able to get that on my project? Are there time, program issues that mean that it's not going to be available? And again, to the point of where we really need to be in 2030 for the reduction in embodied carbon we need to make in facades. I don't know where to get those products. And so but still I think there's often a reliance, the market will come. But we need to be we need to be designing to the lowest embodied carbon, and then also encouraging industry to bring those products on. We can't just wait and say, well, they'll get better and therefore they'll find the solution for us. We need to start coming up with those solutions, those design solutions. As I say, a lot of that is reuse of existing materials, and I think there's a creativity thing, and there's an availability thing that we're not quite. That's the biggest hurdle for me, I think.
Yeah, I think the idea of refurbishment, reuse, circularity, all of these words that, again, we're now very familiar with because we keep talking about them, but actually putting those principles into practice is a real challenge. We have a work stream on circularity and on refurbishment looking at that, so we know how difficult it is, but again, we've just got to keep challenging people to try and incorporate those ideas. I think it's not going to be straightforward. Does anybody else want to given the time, I think we'll move on to the next question, and it's another one for me. We spent a lot of time talking about embodied carbon, and there's a very simple question: are we suffering from embodied carbon tunnel vision? And I think it's an interesting question. It is something that we've been accused of. I understand why that is, but I also think the approach that we've taken is justifiable. I think embodied carbon is the obvious thing to concentrate on first. The UK has a legally binding commitment to net zero carbon by 2050. We don't quite know what that means yet, but the focus is carbon. as we've said already, we've been looking at operational carbon emissions for decades, and that continues to be the focus of regulations. But we know that's only a part of the bigger picture. And the next logical step was therefore to concentrate on embodied carbon. And as we saw from several presentations throughout the day, they showed similar things, that the proportion of embodied carbon is getting greater as the operational emissions are reduced. So it is becoming more significant. So it seemed to be the obvious thing to focus on. Of course, we recognise that there is more to sustainability than just carbon. There are a whole host of other things that we could look at: water use, waste, impact on biodiversity. All of those things are important topics in their own right, and we shouldn't forget that. The fact is we know kind of less about those things at the moment, and therefore any guidance will naturally take longer to produce, and we recognise there is an urgency to get guidance out there. So I think our focus on embodied carbon was justified, but it's certainly not the end. And I should point out that we are keen for feedback. We have ideas on what we think we should be producing guidance on, but actually we want your views as well. So if you have suggestions for future topics, please do get in touch. We would like to hear your views. Will, do you think we're suffering from embodied carbon tunnel vision?
That question comes up a lot when I find people start to do the whole life carbon assessments themselves and to dig into it. And when you do, you realise that there are whole other indicators for how we might impact the environment beyond just climate change and global warming potential and carbon. And people start asking quite rightly, well, we're not looking at half of those things on the EPD that's coming through. We're just taking the top few rows and that's it. And they're not wrong. That is correct. That is correct. But I do think the question's a bit. I think the premise of the question is a bit unfair. I don't think they are mutually exclusive, and I actually think, to a large extent, we wouldn't be sat thinking about the broader environmental impact of our buildings and our facades if it hasn't been for the sort of the climate crisis and the urgency to look and cut down on carbon emissions. I think, in many respects, that having that as the focus, not being blinded by it, but maintaining that as a focus is a good strategy and one we should continue on.
Good. Thank you very much. Okay, moving on. So, and actually trying to move away from embodied carbon a bit. So we've starting to improve our understanding of facades and embodied carbon. We're taking steps to reduce the impact. And how does that fit into the bigger picture of the whole building and whole life cycle carbon? Are we doing well? Is there a culture shift that's required? What are the barriers to taking a more holistic approach? Tenny, do you want to start us off on that one?
Yeah, so I think we've touched on some of these things already, just in our discussion of where we're doing well and what we could do better. And just from today's presentations and our discussions, I think it's clear that we've done some good work in terms of understanding and better understanding the impact of the facade with embodied carbon, but in terms of a holistic approach and now thinking about the whole building and how we can really optimize reductions from a whole building perspective, I think it's important for us to now think about, so what does this mean in terms of zero carbon for a whole building, and where does how do we communicate the influence of the facade to other disciplines, to other consultants and clients and architects that are responsible for other elements of the building, so that we can really discuss this in a more efficient way to really understand in greater detail the influence that we can have as a whole in this process of reducing embodied carbon and whole life cycle carbon from the outset. And I think we need to do this as early as possible. And I think we need a big part of this is just how we can communicate this and understand each other in a better way. And additionally, I think in terms of carbon and shifting away from that, there are other aspects, as we mentioned, that we need to think about. while we do want to mitigate carbon, and there's this whole focus on mitigating our impact, we also shouldn't forget that, you know, there's a lot of damage that has already been done to the climate, and we're already seeing that the environment is changing, and we need to be able to respond to this. And not only thinking about reducing carbon and the other influences there in terms of sustainability, but we also need to think about how we can make our buildings more resilient, and what that means in terms of the interaction and in terms of reducing embodied carbon, but also making sure that we're adapting to the changes that we need to face now as well as in the future. So there's a lot of things I think that we could think about in terms of the whole building perspective, not just in terms of how we communicate and make sure we're understanding the influence and the interactions that we have with other elements of the building, not just the facade. But it's just that understanding of this can often be, I think, project specific sometimes, and one solution isn't the best choice for another project. But it's a journey that we need to go on, and we need to do more of these assessments, do more of these collaborations early on to understand, to get some examples really of what these strategies could be to make the optimal, the best choices holistically from a sustainability perspective, which of course is carbon, but it's adaptation, it's resilience, it's a whole bunch of things. So yeah, just in summary, collaboration, and I think thinking it just a bit more broadly and from the outset as early as possible.
Absolutely, and that's something we recognise, and we spoke about at our last sustainability committee meeting about how, excuse me, how we can collaborate more closely with the likes of the RIBA and iStruct and SIBSI and LETI, and actually try and treat this all more holistically. That has to be the goal, hasn't it? I think. Okay. So I'm conscious of time, so I'm going to move on to something. We kind of touched on this before, and it is a very difficult question. Blending of sustainability and aesthetics. Is compromise needed? And if so, are we seeing it? Zara, do you want to start us off with that one?
So there's probably a lot of architects in the room. There does need to be some compromise, but obviously you can't ignore the climate crisis. But obviously we don't want to go through an epidemic of boringness, as architect Heather said recently in a similar conference. You know, if we were to follow the form as part of guidance would say, we'd get loads of spheres and cubes in our streets. And you know, talking about resilience, as Tenny was saying, we've got to look at the future. We don't want to be pulling down all these buildings that are just slaves to form and orientation if they're not valued in the communities. So no, architects will still be required, but it's a compromise that needs to be found. Architects are definitely on the same page as us. If architects would like to submit their entries to a Reba Sterling Prize, they now need to submit a year's worth of data for it to be considered. So they've actually staggered their entry submittals by a year to allow that to happen. So it is on the agenda in terms of architecture, and there are lots of more things that should be considered. And we're seeing the effects now in terms of, it's just common sense. You know, do we need to have buildings that are high visual quality? Does it need to be of the standard that we used to enforce on our fully glazed buildings? If we've got, you know, glass now broken up by solid elements, perhaps we don't need to have the same roller wave requirements. Perhaps we can add that little spot defect without rejecting that huge pane of glass, and look at aspects, you know, visual quality and replaceability, and be more sensitive to materials.
Thank you. Damien, do you think we're seeing a reasonable balance between sustainability and aesthetics?
I think we are seeing some. I think the examples are just cited of being a bit more relaxed about spot defect in glass. Yeah. I think if people are on board with that, I think that, you know, that is definitely an improvement. Is it? Are we seeing a kind of wholesale? You know, let's go for the the lowest carbon facade. It's a complicated thing because you still need to maintain an amount of glass so you get the good internal environment, the good the views out. So there's certainly there's an awareness, and there's people are trying to make the right decisions. But I guess I'd go back to this in refurbishment in particular. The buildings that we're refurbishing aren't we're not taking off the facades because the facades are failing. We're taking off the facades because people don't like how they look. And I think we need to have a lot more sort of open-mindedness and creativity when it comes to existing building stock and making sweating those facades, the existing facades and those assets to make sure that they're really only demolishing and really only taking away the materials that we need to. And I think there's a lot more, we need some better examples of people who are being more creative about keeping buildings, prolonging the life of buildings for it to catch on.
Okay. I would add to that. There's a bit of chat about resilience, and we've been talking about climate resilience, and that's a fascinating topic in itself that is going to become more and more prolific as we move with an ever-changing climate. And I think there's a lot we can learn from COVID and looking back to see how our infrastructure responded to COVID as an example of a shock to the system. Because if you asked me to design an office for a pandemic in 3 years' time, I wouldn't believe you back in 2017. I might do now. But you'd be thinking about ventilation rates, you'd be thinking about airtightness of the facade, and you'd be wrong, really. I mean, the last 3 years have shown that the single most resilient measure that we put into our offices is the IT infrastructure to work from home. So people didn't actually have to come in. And that had these second order effects. As people stayed at home, suddenly they had to restructure their home environment. You might have had family moving in for longer than you would have perhaps liked. And you had to deal with that. And to what extent was the fabric of that building a barrier to, or sort of facilitated changing that space? And I think we need to take that idea that resilience isn't just about the immediate effects of climate change, but also how we adapt to them as a society into how we think about our buildings. It might not be that it's the temperatures on your roof or the wind speeds that you're trying to design for, but you might design your office for a higher wind speed, but if the school roof blows off, then everyone's going to be staying at home looking after the kids. So it's really complicated.
I think we're under pressure to move. One very quick question, if I may, because it's another important one. So, is there a cost to a low carbon and more sustainable design? Very quick responses, please. Will, do you want to start?
It depends.
Good answer. Okay, right, moving on.
As a designer, it depends largely on where your conversation starts. If it's, I've got this design, what low carbon material alternatives are there, then I think as demand for these low carbon materials increases, there's a limited supply. We've already heard that from David this morning. They're going to warrant a cost premium against that. But if your conversation starts with, well, how can we use less? I still keep going around our team saying, why are we designing the facade for a wind pressure that only exists in 5% of the area? We've sized all the millions based off that. I think that reframes the whole conversation, and I've yet to see the evidence that results in a higher cost, and I think there's certainly an opportunity for cost savings.
Okay, Damien, very very briefly, do you have anything to?
Is there a cost? Yes, but that's because we tax the wrong things. Carbon tax and resource tax instead of taxing people's time, and would mean that these labor-intensive refurbishment projects would become, recycling of glass, reusing glass panes, taking them apart, putting them back together. Should all be low carbon, should be low cost if we tax raw materials more.
Interesting. On that point, I'm going to stop before we get kicked off. Sorry that there's been a bit of a rush. We actually had planned to have a bit of a Q&A session, because I think I'm sure there would be lots of questions that you would have liked to ask, but unfortunately, I'm not going to get away with doing that. So we'll stop there. Thank you for staying right until the end. It is much appreciated. If we go back to our original question, which was, is the facade industry responding to the climate emergency? Clearly, the answer is yes. Obviously, there is more to do, but there is a huge amount of effort from a large number of people going into this. And I think that we've made a really positive start. There's a real momentum to this work, and we obviously have to make that. We have to continue with that. So, finally, please read the guidance that's been published not only by CWCT, by other people as well. Spread the word, and we'll stop there. Thank you very much.
So thank you very much, David, and thank you all our panelists. I'm sorry that we had to rush you a bit at the end there. We are running a little bit against time because we have to turn the whole round quickly for the event after. I've been told the registration for the SFE dinner, which is taking place in here, is now going to happen just outside there. So if you have a ticket for tonight's event, you will be able to get a wristband just outside here. And from my side, I will wrap up very quickly. I want to say a big thank you to all the speakers, all the contributors, and a big thank you to Ahmed and the team from Zak for putting on a fantastic event again. And thank you all for coming. See you next year.